it's your favorite NPC, and today I'm going to turn you from a full web development beginner into someone who can actually build websites. I will do so by teaching you HTML, CSS and JavaScript from zero. People think AI made learning HTML, CSS and JavaScript pointless, but it's the opposite. It made it more valuable, because AI is only as good as the person directing it. If you don't know how the structure works, you can't even describe what you want. The people getting incredible output from AI aren't better at prompting. They actually just understand the thing they are prompting. In this course, I will teach you all three core languages of the web properly. HTML for structure, CSS to make it actually look good, and JavaScript for interactivity. We start with HTML. What it is, the basic skeleton, tags, text, lists, links, images, attributes, tables, forms, and semantic structure. Then CSS. Selectors, colors, text, styling, the box model, units, FlexBox, grid, positioning, pseudo classes, transitions, animations, media queries, and variables. And then JavaScript. So variables, data types, functions, arrays, objects, classes, loops, all the array methods, error handling, promises, fetch, async, await, modules, and then JavaScript for the actual web, including the DOM, selecting and changing elements, events, local storage, and more. Most tutorials in the AI era teach you to copy-paste prompts. This one teaches you to actually understand the web. I will get you through it step by step. So even if you're a complete beginner, you will be fine. So if that sounds good to you, let's get started. HTML stands for Hypertext Markup Language and is the foundation of every single website on the internet. It was originally developed by Tim Berners-Lee in the early 1990s to solve a simple problem: how to structure and share information across the web. Before HTML, there was no standard way to display content in a browser. HTML introduced a system based on elements and tags that define the structure of a page. Things like headings, paragraphs, images, and links. HTML therefore focuses on creating the structure of a website. It works together with CSS for styling and JavaScript for interactivity, forming the core of how the web functions. Today, HTML is used in everything from simple landing pages to complex web applications. It hasn't been replaced. It's still the standard and every website depends on it in some form. You should learn HTML because it teaches you how the web actually works. It gives you full control over structure, helps you build websites from scratch, and is an essential skill for anyone who wants to create or understand digital products. To get started using HTML, we first want to get a code editor, and I'll explain you what it is in a second. But first of all, let's download it. Right here, let's just enter Visual Studio Code and let's search for it. Now you can just press the first link right here. You land on this page, and right here you can just press Download for Windows. Installing this will take a short time. Now we can just open the installer right here by clicking it. Right here we press I accept the agreement. Next. Those two marks should be checked, next, and install. This will again take a short time, and once done, we can just press finish right here. And this will open Visual Studio Code for us. So this should be the window that you get. And now let me make this one here a little bit bigger, like so. And now we have a lot of different tabs right here. And the most important one is the Explorer tab right here, because right here you can open your project. When working with HTML, you always have your project inside of a folder. So you can either press here, open folder, go to your desktop and select a folder. So you could, for example, create a new folder right here and then select this folder. Or alternatively, you can also create a new folder right here. So new folder, let's say HTML course. And now you can just take this folder right here and drag it in here. And this will open the code editor within this folder. So this is your HTML folder right now. So within this folder, you can now create your files. In order to create our first HTML file, we press this icon right here, this new file icon, and give our file a name. A common name for our entry file is theindex.html. And every single HTML file ends with the .html extension. So let's press enter. And by doing so, we've already created our first index.html file. And inside of this file, we can now write HTML code. To create a basic template inside of VS Code, you can just use an exclamation mark and press enter. And this will generate the basic HTML startup template for you without you having to write any code. And you don't have to understand this yet, I'll explain this in a second. So let's save this. And now you can just go over to your folder, the folder that we've previously created, and we can just double click this file right here, so our index.html file. And you can see this will open this file in a new tab in the browser. And this right here is now our website. So as you can see, an HTML file is just a page on our web page later on. And if we just want to output some text, for example, right now, we can just write it within the body tag right here. So we could just say, hello guys. I'm going to save this. Let me open our website again. And as you can see, we're not seeing anything. Every time we do a change right now, we have to reload the page in order to see the change occur on our page. But now, once we've reloaded the page, you can see we have hello guys right here. Let me make this a little bit bigger. So this is the text that we have right now. So what is even the purpose of our editor right here? Why did we install this? Technically, we do not really need this. We could also write our code inside of Notepad, for example. Let me show you. Let me just minimize this tab right here and this one. And now we can just right-click this, open with, and now we can choose another app, for example. So let's just use Notepad. So a basic text editor, essentially. You can see we have the exact same text right here, but it looks pretty flat. And it's probably a little bit harder to read because we don't have colors and so on. But it doesn't really matter. You can also just write text right here. So I could say, hey, this is just some random text, for example. I'm going to save this. Let me reopen our page. And you can see we're getting, hey, this is just some random text. So even though we are just writing inside of Notepad and not using any editor, this still works the exact same. So a simple text editor like this works, but we've installed essentially a better editor that gives us some colors, makes everything a little bit easier to read, and also gives us auto-completion, which you will see in a second. For example, you've already seen it. If we just use an exclamation mark and press enter, this will automatically generate a basic HTML template for us. On the other hand, when using Notepad, you can see I can enter an exclamation mark, I can press enter, but nothing happens. So if you would write within Notepad, for example, so within a plain text editor, you have to write every single line yourself, errors will not be indicated, and a lot of stuff will be a lot harder. Therefore, we use something like Visual Studio Code. And something like Visual Studio Code is also often called an IDE, which stands for Integrated Development Environment. At the moment, you've already seen that we have to refresh our page every time we make a change. So if I write something right here, I have to refresh the page in order to see this change. So isn't there a better way? A way to get those changes automatically, for example. And there is a better way. And in order to do so, we can go to the Extensions tab right here. Right here, you can search for a lot of different extensions. There are extensions for formatting your code, extensions for updating automatically, and so on. And we are searching for the live server because that is the extension that allows us to update our website automatically when a change occurs. So let's click on the first one, so live server. And right here, I've already installed it. But if you do not, you just press the install button right here and wait for the installation to finish. Once you finish the installation, you can just go back to your file. Right here, you can right-click the file and press Open with Live Server, like so. This will now open your page with the live server. Let me make this here a little bit smaller. And now let me just change something on our page. So let's say, hey guys, once again. I'm going to save this and you can see our change occurs immediately on the page. So let's now go over the individual elements right here. Let me first of all make this here a little bit bigger for you so you can see all of this. And also remember that you do not have to memorize all of this. It's just important that you essentially understand the base structure, because later on you can always use an exclamation mark and press enter anyways. So as long as you understand what all of this does, it's enough. You do not need to memorize. The first line essentially says that the doc type is HTML. So the type of this document is HTML because obviously it's an HTML document. So this obviously makes sense. Everything in HTML is inside of tags. And usually you have an opening tag and a closing tag. And the opening tag essentially looks like this. And the closing tag looks like this. So you basically have those symbols right here. Within those symbols, you have the tag name. So HTML, for example, or body or head. Doesn't matter. So this is the tag name. And then you have the closing tag. And as you can see, the closing tag has the exact same syntax, but also has a backslash right here. So this backslash tag name and then the closing tag like so. And usually within HTML, we have one root tag that wraps the entire page. And the root tag is basically just the HTML tag. So the HTML tag wraps the entire document. Everything on your website is essentially within this HTML tag. Next up, we have the head tag and the body tag. So within the HTML tag, we usually have head and body. It's also pretty easy to remember because the head is similar to your own head. It stores all of the information. So it stores the information about your web page essentially. Things like the title, the author, the char set, and so on. And the body is also similar to your own body. It is the visible part of your website. So the body includes all of the stuff that you actually see. So things like hey guys, for example. So text, headings, images, and so on. So let me change this title, for example, to Best HTML Course. Let me save this. And you can see right here at the top, we now have the website title Best HTML Course. Let me also show you what this title is in real life. So let's just go over to Google, for example, and let's search for shoes, for example. Doesn't matter. And now you can see right here, we have a shoe website, for example. And the title is essentially just what you're seeing right here. So whatever you define within your title, within this title tag right here, is what a potential customer, for example, would see right here. So Fusion shoes and so on. So all of this stuff. Right here, you can also see that we have a description. So I could also add a description within your head section by using meta::desc. And you can see this here is the power of using an IDE. We can just use meter::desc and press enter. And this will automatically create the meter tag for us that allows us to add a description. The name attribute essentially defines that this here will be a description. And you don't need to understand what attributes are just yet. But just remember that this here says this is going to be our description tag. And the content attribute, again, you do not need to understand attributes yet. But right here, we can just define our description. So this is the best course for HTML ever, for example. Doesn't matter. And this description right here, so whatever we've defined right here, will now be displayed right here in the Google search engine, for example. So I think you get the idea. So let's just close this for now. Let's minimize this again. And let's go right here. So again, the head includes all of the information about your website. And of course, there exist a lot more attributes. I'm going to be honest, I've never really used a lot more than those ones. But if you plan on using a lot of them for some reason, then you can always find all of them in the official documentation. So let me show you how you'll find the official documentation. For example, let's go and search for HTML head tag elements, for example. Now we can go over here to W3 School. And right here, you can now read a little more about the head element, the HTML title element, and the style element. Doesn't matter. You'll find a lot of stuff. And right here, you also find a lot of meta tags. So char set, keywords, for example. Right here, you could define keywords like HTML, CSS, or JavaScript for your websites, which is important for search engine optimization, for example. Right here, we have the description. You can also define an author and so on. So you can define a lot of stuff if you want to for your website. And all of them have essentially the same structure. But again, this is not going to be the visible part. So let me introduce you to the visible part, which is the body again. Let's minimize this. And as mentioned, right here, we will have all of the elements that create the visible part of our website. So if I'm just going to enter some text right here, this is something that actually works. And this will display the text on our website. But even though this works, this is not the most ideal way to display text on a website. Because, of course, we have now text on our website. But search engines like Google, for example, do not really understand the structure of our website. Which text is important, for example. Since Google needs to rank you, Google also needs to know what is important on your website and what is probably not that important. If you do a website about sports, for example, and you write sports right here, and then you give some information about sports, for example, doing sports is cool, then this here should, for example, be the title. And of course, the title should be a lot more important than a word like cool or doing, because this does not really describe what your website is about. Sports is what best describes your website, and therefore you want to rank for the tag sports or for the word sports, because if a user searches for the keyword sports on Google, he probably wants to find your website. He probably doesn't want to find your website for the word cool. And in order to structure your page, you use tags. Again, every tag has an opening and a closing tag. There also exist self-closing tags, but we'll get to them later on. So for now, our tags will include an opening tag and a closing tag like so, as mentioned. And there exist a lot of different tags. There exist tags for headings, paragraphs, images, and so on. So let's start by writing our first heading. And we can do so by using an opening tag that says h1 and a closing tag that also says h1. Within tags, you can now define your content. And our content, when using an h1, is text. So it could be sports, for example, like so. And this is how you define your first heading. You can see we also have a different styling, but it's important to understand that HTML is not for styling. HTML only defines a structure. So even though the style is slightly different, that's something that does not matter for us when learning HTML. There exist a lot of different headings. In fact, there exist 6 types of headings. Also the h2. This one could say sports is cool. Now we also have an h3 tag, for example. This could be some random text, doesn't matter. h4, again, some random text. We also have h5, and we also have h6. And essentially, those headings are ranked by importance. When using an h1, search engines like Google will understand that this word is in fact very important and really is essentially the main topic of your page. There should only be one h1 for every single HTML page you have. So this index.html page should only have a single h1 tag. So if your website is about sports, for example, the h1 should probably be sports. You can use h2 tags then to further subdivide your page into multiple subsections. So maybe you have one section about basketball, like so, and then you have another section about football, and maybe another section about the gym. And now you have h3 tags to further subdivide h2 tags, for example. So maybe you want to have different sections for a couple of different players. So maybe LeBron James, then another one for Michael Jordan, and so on. So I think you get the idea. Now you could, of course, further subdivide your h3 tags into h4 tags. Maybe now you want to write about their children. I don't know. You get the idea. Then you could further subdivide h4 into h5 and h5 into h6. So this is what you use headings for. But up to this point, we've only subdivided our page into multiple sections. So one section about basketball, one about football, one about the gym, for example. But we also want to write a little bit of text for every single section. So maybe we want to write a little bit about basketball, for example. So let me just delete all of them. And let's say right below our basketball tag, we want to write a little bit about basketball. In order to just output regular text, we should use the P tag, which stands for paragraph. And now we could, for example, say, basketball is the best sport in the world, like so. And you can see we now have a little bit of text. We can also use a second paragraph right below, for example. So let's use another paragraph. And let's say it makes so much fun. And you can see every paragraph starts on a new line. So if I'm going to use another paragraph and I'll just say, I am playing it a lot, then you will see it will again start on a new line. So every paragraph starts on a new line. So if you take a look at the structure of those tags, all of those tags have pretty much the same structure. You have the opening tag, then you have some content, and then you have the closing tag. So within opening and closing tag, you usually have content. But as I already mentioned, you also have self-closing tags. And the difference between tags that have an opening and a closing tag and self-closing tags is that tags with an opening and closing tag always include content. So they always contain content. Whereas a self-closing tag is essentially the content itself. Let me give you an example. An example for a self-closing tag is the break tag. You also start with this symbol, then you have the tag, And now you can either just close it, or you can use backslash and close it. Both of this works. Once we're going to save, you can see that we have added a break. So this break tag is essentially the content itself because it adds a break to your page. It does not contain content itself. It is the content. And that is what you have to remember about self-closing tags. Another important example that you might use from time to time is the horizontal rule. So let's use HR, which stands for horizontal rule. Let's close this tag and let's save this. And you can see we have added a horizontal rule right here. So to summarize, the break tag adds a line break, whereas the HR tag adds a horizontal rule to your page. Let's understand another tag, and that is the strong tag. And I think it's easiest to just show it to you. So let's just wrap basketball with the strong tag. So I'm going to use strong right here. Again, you can see we have an opening and a closing tag right here. And in between this tag, we have our content, in our case, basketball. And you can see now basketball is written bold. But that is not really the purpose of the strong tag. The strong tag is again to tell search engines like Google that this word is especially important. So maybe we want to rank higher for words like basketball. Therefore, we want to use the tag strong to tell Google, for example, that our page is about basketball, and therefore this word will now have a higher importance. It is again not for the purpose of styling. So you don't use the strong tag to make something bold. That is something again that you do by using CSS. Let me also introduce you to comments. First of all, we can just delete all of this since we do not need this anymore. We can save the page. And let me show you how to write a comment. To write a comment in HTML, use this symbol followed by an exclamation mark followed by 2 dashes like so. And this part right here opens the comment and this part right here closes the comment. And in between those tags essentially, you can just write your comment. So this is a comment, for example. So pretty much anything you like. And you see, if I refresh the page, we are still not seeing anything. And the reason for this is that a comment is just there for you and other developers to, for example, understand the code, to share information, and so on. So this is just information that is visible to the person who is seeing the code. It is nothing that will be interpreted by HTML and therefore be seen on the website. Oftentimes you will also see those comments to structure a website, for example. So maybe this is going to be the heading of your website. This is going to be the main section of your website, and this is going to be the footer for your website. And of course, a lot of developers use comments for a lot of different purposes. But I just want you to know that they exist in case you ever see them or want to use them. You can also write multi-line comments by actually just moving this here a couple of lines down, and now you can write right here. So this is a multi-line comment, for example. And now I'm going to save, and you see this is also basically just a normal comment, just over a couple of lines. Let me now introduce you to lists. And there exist 2 types of lists: ordered lists and unordered lists. And as the names imply, you use an unordered list if the list basically has no order, and an ordered list if you want to have a list that has a specific order. You can create an unordered list by using the UL tag. Again, you have an opening and a closing tag, as you can see. And within the UL tag, you can now define different list items by using the LI tag, which stands for list. Let me show you. So LI, let's press enter. We have again an opening and a closing tag, and you can already see this bullet point. And now we can, for example, add an item right here. So item 1, for example. And now we can create a lot of different items. We can also just duplicate this tab. So we could just create another tag. So let's use another LI tag. And this here could be item 2, for example. And let's have a more realistic example. This here is apple, for example. And this is going to be orange, for example. So this could be a recipe or a shopping list, doesn't matter. Now we can also duplicate this list item a couple more times. If you press Shift, Alt, and the down arrow, then you will duplicate it to the bottom. And now we could also add kiwi, and doesn't really matter. Let's just delete this. So now we have an unordered list, which includes 3 list items. Let's also add an ordered list. And an ordered list has essentially the exact same structure. The only difference is that we're using an OL tag, which stands for ordered list, instead of a UL tag. Let me show you. So let's have an OL tag right here. Again, we need our list items to create our individual list items. So LI right here. And now let's, for example, rank the fastest sprinters of all time. So the fastest one is probably Usain Bolt, like so. So he should be, of course, number 1. Let's have the second fastest one of all time. That is probably Johan Blake, like so. And the third fastest, probably Asafa Powell, like so. And you can see we can use an OL tag whenever the order matters. And if you want to rank sprinters, football players, and so on, doesn't really matter. Where the order obviously matters because someone has to be the best, then you always want to use an OL tag. So to sum up, an unordered list if the order does not matter, and an ordered list if the order does matter. Let me now also introduce you to lists. Imagine you want to link your Instagram profile because you want to get a couple more followers. Doing so is pretty easy by using the anchor tag. And you can create an anchor tag by just using A, so the A tag. If you press enter, you can see that we are getting this A tag right here, and we're also having this href attribute. Again, you do not need to understand this attribute yet, but within this href attribute, we just define the location to which this link should redirect the user to essentially. So imagine we want to redirect the user to Instagram. Then we can just go to Instagram.com, for example. Then we're just going to copy this URL. This could also be a URL to your profile page, doesn't matter. And you paste it in here. So now this anchor tag points to this URL right here, to this Instagram URL, and will redirect the user to this URL when he clicks on this anchor tag. But of course, you also need a text where the user can click on. So go to my Insta, for example, like so. So within those tags, you find a text that will be visible on your website. Whenever the user clicks on this text, so go to my Insta, he will get redirected to the link that you define within the href attribute, like so. So if I'm going to click this link, you can see that we're getting redirected to Instagram. But oftentimes, you also want to make sure that the user opens the link in a new tab when he clicks on this link, for example. And in order to do so, you can add a second attribute, which is the target being equal to underline blank attribute. So you add the target attribute and set it to the value underline blank. And that's something that you basically just have to memorize or look up every time. But you'll memorize this pretty quickly. And now once you press go to my Insta, you can see we're opening a new tab. We still have our website in the old tab right here, but we also have the new tab with Instagram right here. And every time I click this link, you can see I will open a new tab that opens Instagram essentially. So that is what the target underline blank attribute does. You can also use links to redirect to another HTML page, for example. So right now, we only have this index.html file right here. But we only have a single page, and oftentimes you want to have a couple of more pages. If you think about Instagram, you, for example, have a messages page, a contact page, a friends page, a post page, and so on. So you have a lot of different pages. And oftentimes, you want to have a lot of different pages on your website as well. So you can also create different HTML files. So you could, for example, create a contact.html file that allows users to contact you, for example. Every new HTML page should also include the basic template, like so. And the rest is essentially the exact same. You could also have an H1 for this page. This here could be contact us, for example, because this is the contact page. And now maybe on our index.html, we want to redirect the user to our contact.html. So for the href attribute, it's actually pretty simple. We just need to define the path to our contact.html. And since it's in the exact same folder, we can just say that we want to redirect the user to contact.html. We can also remove target being equal to underline blank because we want to redirect the user on the exact same page. And right here we just say contact, for example, like so. So now let me click the contact page or the contact link in this case. And you can see we're getting redirected to the contact page, which we see because we now see contact us, which should be displayed on our contact.html page. Right here, we could now also create a link that redirects the user to our index.html, so back to our home page. So let's again create an anchor tag. href should now point to our index.html file. And right here as a text, let's just add home. So when the user now clicks on home, he will get redirected to the index.html page. And when he clicks on contact, he will get redirected to the contact.html page. So you can see this is how you implement navigation in HTML. Let me now also explain how this here works a little bit closer. As you can see, if we are in the exact same folder, it is enough to just reference the file name, or to just type out the file name essentially. But of course, it is also possible that the file you want to reference is inside of another folder. For example, you could have a sub-pages folder. And to create a new folder, you press this new folder icon, in case you didn't know. So now imagine we're having the sub-pages folder, and now my contact.html file is within the sub-pages folder. Let me now go to the index.html file, and now if I'm going to save this, and I press contact, you can see that we're getting this error, cannot get /contact.html. And the reason for this is that this path is now wrong, because of course our contact.html is not within the exact same folder anymore. It is within the sub-pages folder. And referencing a file within another folder is very easy, to be honest. You just use the folder name right now, so sub pages like so, and to say that you want to get into a folder, so go inside of a folder, you use a slash. And now you can just define the file that you want to access, so contact.html for example. If you would have another folder within the subpages folder, so let's just say within the subpages folder we have another folder. Let's just say this here's the sub-pages folder. Doesn't matter, doesn't make sense, but for now let's just imagine that's the case. And now our contact.html is within the sub-pages folder. So now again, to go into the sub-pages folder, we first have to go from our current location into our sub-pages folder, like so. And now into our sub-pages folder, so sub-pages. So let's go inside of that one, and now we have to reference our contact.html file, like so. So you can see this here works as well. But now, as you can see, if you take a look at our contact.html, so let's go to contact, and now we want to go back to home, this does not work anymore, because our contact.html is now within our sub-pages folder, and our index.html is 2 levels higher. So now we need to say that we want to go outside of the sub-pages folder, outside of the subpages folder, and then access our index.html. So previously, we went into the subpages folder, into the sub-pages folder, to contact.html, and now we have to go the exact opposite way. So outside of the sub-pages folder, outside of the subpages folder, to our index.html. So I hope that makes sense. And in order to go one level up, so to go outside of a folder, you have to use a // like so. So this is the first level. And now you can use another // to go one level higher again. And now you can see we are already getting the index.html as a suggestion. So now we can just reference our index.html. Let's click that one, and you can see our navigation now works again. And to really visualize this to you, if you say subpages / for example, this is just equivalent to clicking subpages right here. If you now would say subpages / this again is equivalent to just clicking this page. And now just typing out contact.html is essentially equivalent to just linking to this page. If you're now within this folder, saying // is equivalent to going one level back. Saying // once again is again equivalent to going one level back. And now again you could just reference the index.html by typing it out right here. So I hope you understand how this works. This is literally just navigating within a folder by typing it out. So by using this syntax. But for now, let's just delete all of this because we do not need a contact.html anymore. So let's continue. And on our index.html, let's also delete our anchor because we will not need it anymore, like so. So now we have an empty page once again. Now I also want to introduce you to images, because from time to time you maybe want to display an image. In order to display images, you can use the image tag, so img. Let's just press enter. Again, Visual Studio Code will just create the element for us, like so, with the necessary attributes. For the image tag, that is the source and the alt attribute. And you'll understand them in a second. The source essentially references the file that we want to display, and the alt is an alternative text that will be displayed if the image cannot be loaded. For example, because the user does not really have a proper connection, the image is not available currently, or if he is visually impaired, a screen reader will also read out the alt text, because obviously visually impaired users can probably not see the image. So displaying an image would not really make too much sense for them. But you'll understand in a second. First of all, of course, we need an image. And I will just get an image from Unsplash because the images over there are copyright free. But you can literally use any image you like. So I'm just going to click the first link. All of those images right here should be copyright free. So I'm going to download one. I'm going to take this image, drag it into our folder right here. And I'm going to rename it because this will make it a lot easier in a second. I'm just going to say this here is cool.jpg, like so. So this is our image name now. Let me just close this one right here. And let me also close our image right here. And now to display this image, we just have to reference it again. So we just type out the name followed by the extension. So .jpg. Let me save this. And you can see we're getting our image right here. You can see it's way too big. And I'm going to rescale it for you so you see that this actually works. But usually you don't want to use HTML attributes to resize your image. You always want to use CSS. But since we do not have CSS yet, I will show you how it also works within HTML. So you can define a width like so. And you can just say 100 pixels or 400 pixels. Doesn't really matter. I think you get the idea. Again, you do not have to understand this. You will usually use CSS for this anyways. But you can see this here is now the image. And as I've already mentioned, you should also always define an alt text for images in case the image cannot be loaded or for visually impaired users, since the screen reader would then read the alt text. And right here, you could essentially just say cars on grass, for example. Doesn't matter too much. I think you get the idea. Let me again demonstrate how this works if you have an image inside of a folder. Oftentimes you will have an images folder, like so. Then you will have this image within the images folder, like so. And now it works the exact same like before. You just define the folder name, followed by a slash, followed by the name of the image, like so. So images/cool.jpg, and this will have the exact same effect. So to summarize, to display an image, you use the image tag. The source attribute defines the path to your image you want to display, and the alt text gives an alternative text in case the image cannot be loaded or in case a user uses a screen reader. Width and height can also be defined, but that is something that you actually do not want to do, and I just did for the purpose of showing you that this is actually the real image. Now that you've also seen images, I want to explain attributes a little more, because we've used them a lot already, but I've never really explained them. And maybe you can already imagine, but attributes exist to give additional information for a couple of elements. And some attributes, for example, are mandatory for a couple of elements, whereas other attributes are, for example, optional. If you think about the anchor tag that we used previously, if you remember the target equals _blank attribute, that is an optional attribute. You can add it if you want to add or open the website, the linked website, inside of another tab, but you do not have to add it. But a couple of attributes are also mandatory. If you think about the source attribute, for example, an image without a source does not really work. Therefore, you need to use a source attribute for an image tag. So every image tag needs a source attribute to define the path to the actual image that you want to display. You always define the attribute within the opening tag in case you have an opening and a closing tag. If you think about the anchor, for example, you can see you define the attribute within the opening tag, so within this tag. You never define the attribute within the closing tag. Most of the important attributes will get generated automatically by VS Code if you just enter the element name like so and press enter. You can see the important attributes will automatically get generated. So for image, The important ones are source, which defines the path to the image, and alt, which is the alternative text. And that is something that is really nice about Visual Studio Code, because it makes it a lot easier for you and you do not have to memorize all of the important attributes. But you remember them anyways if you just code a little bit. So that's not a problem as well. So to summarize really quickly, attributes get defined within the opening tag and they add additional information to an element. Some attributes are mandatory and required for certain elements, and some are optional. Some attributes also only work with certain elements. For example, a source attribute works with an image tag, whereas it wouldn't really work with an anchor tag. Let me now introduce you to containers. First of all, let's just delete all of this. Let's save this again, and let's take a look at the two container elements that really exist. There exists a div and there exists a span. So what will you use those containers for? A container essentially just wraps other content usually and is used to group related content. Right now, a container will seem pretty useless to you, but it gets especially important once you start working with CSS, because then you can use containers to really style your content, and then you will also understand the difference. So even though it might seem unnecessary for you once I show it to you, just remember that those are really important concepts. So let me explain. Let's start by taking a look at the div. Imagine we're just having an h2, and that one talks a little bit about basketball. You also have a short paragraph. Basketball is cool, for example. And now let's just take this container and paste it in here. And let's say this here says football and football is cool. So as you can see, the first div essentially groups related content, so basically content about basketball, and the second div groups content, related content, so basically content about football. And of course, you could do the exact same by using a span, like so. So let me replace a div with a span right here, and you get the exact same result. So both of those elements are containers. They just wrap content within them. You could also just write text in here. So you could also say hello, or doesn't matter, just this random text. And now let me just delete this span right here. And let me just copy and paste this span in here. So let's also have some random text here. And you can see we're getting this text and this text. So I can output text right here as well, but that is something that you should actually not do. A container should be used to group related content. It should not be used to output text. If you want to output text, again, use a paragraph, because that is the element that was made for outputting text. But this here is really good to show you a key difference between divs and spans. As you can see, the text that I've written within the span sits next to each other. If I'm going to use a div though, hello, and I'm going to duplicate this div by using Shift, Alt, and down arrow again, and I'm going to say hello bro, you can see hello and bro sit below each other, whereas Geob, Adstas, or whatever you want to say, sit next to each other. And the reason for this is that a span is an inline element and a div is a block level element. What exactly does this mean? This means that a span, if you have content within it, only takes up the necessary space, and other elements can essentially sit in line, so next to each other. So a span can sit next to a span. A div, on the other hand, is a block level element, which means a div always, no matter how big the content is, takes up an entire row. So the div essentially goes from here, so from the H, to the end of this row. Every new div, therefore, starts on the next row, or in a new line, if you want to think about it like this. So a div takes up an entire row, a span only takes up the necessary space to display the content. And that is the key difference between a span and a div. And if you remember block element and inline element, that is something that is really important and will make your life a lot easier in the future. Let me also show you the console and the elements tab, because that will give you a deeper understanding of websites. Let me open this right here. Let me right click the website and let's press inspect. If it looks like this for you, you can press this icon right here that will toggle between different devices. So you can see this here is how it looks on a desktop. This here is how it looks on a mobile device. And you can also resize it right here. So that is the first thing you can be aware of. But that is not that important for us now. But if you open this right here, you can see that we have a lot of different tabs right here. And a couple of them are pretty important from time to time. The first one is the Elements tab. As you can see, the Elements tab includes all of the elements of your website. If you hover over the HTML tag, you can see all of the elements that exist within this HTML tag. Since the HTML tag on our website wraps the entire website, or to be precise, every other element, hovering over the HTML tag will create this blue box around our entire website. If we now hover over our head, you can see we will not see any box right here, because again, the head only includes information about our website, therefore we are not having any content. Hovering over the body will again highlight pretty much everything, because essentially all is part of the body. We can now also open our body right here, hover over our span, and you can see the blue box around our span shows the size of our span, and since it's an inline element, it will only take up the necessary space, therefore only the space of our element, and the same goes for our second span, of course. If we now take a look at our div on the other hand, you can see that the blue box goes from the left to the right. So the div takes up the entire row, and the same obviously goes for the other div. So this here also visualizes the difference between inline elements, so spans for example, and block level elements, so divs for example, once again. So the Elements tab is pretty important when you work with HTML. But since you will later also learn CSS and JavaScript for example, I also want to introduce you very quickly into some of the other tabs. You do not need to understand them perfectly yet, but it's good if you've heard of them. The Console tab is essentially pretty nice because it will display JavaScript code later on, for example, and that is something that you will use once you learn JavaScript. Sources essentially includes a couple of sources that might get a little more important later on, but for now it's not really that important. The Network tab displays how long your resources might take to load, for example. Also have a status code. That's not that important for us at the moment as well. And as you can see right here, we have a couple more tabs. But the most important ones for now are Elements, and later on, once you start working with JavaScript, the Console tab. So let's close this, and let me show you that this tab actually exists for every single website. So I can see the structure of every single website by right-clicking the website and going to inspect. And now in the Elements tab, if you take a look at Facebook, you also can see the exact structure of this website. You also have the head, you have the body. Within the body, you have a couple of things. You have divs, for example. You have a lot of divs to be precise right here. Let's scroll down. Inside of the divs, you have more divs. Right here, you have an image, for example. If you take a look, once you hover over the image has a blue box around it as well. And I think you get the idea. If you want to see where a certain element is within the tree, for example, you can just right-click it and inspect. And this will, within this tree structure, jump to the exact element. So let me take a look at the input feed, for example. Let me press inspect. And you can see we are jumping to our input element right here. We didn't learn inputs yet, but that is something that you will use for a form. And by using inspect together with the Elements tab, you can basically understand pretty much any website. Right here you also have a lot of styles. That is not that important for us yet. You will learn that once you start styling with CSS. So let's close this, and let's go back to our HTML code right here. Let me now introduce you to tables. To create a table, you first use the table tag, like so. But as you can see, we're not seeing anything. And the reason for this is that you of course need to define your columns and your rows. To create a new row, we always use the tr tag, which stands for table row. To this row, we now have to add columns. To add a column to a defined row, you use the td tag, which stands for table data. And now within this td tag, you can define your content. We could, for example, say that this here should be the name. Now let's create a second column right here. And this one should have the age. And now let's have a last one that includes the biceps size, for example. So now we have one row that includes 3 columns: name, age, and bicep size. And now we can create another row. Let's, for example, say that our first row should essentially include the placeholders, and our second row should include a couple of specific values for a specific person, for example. So TD, our name is going to be NPC, age is going to be 28, and bicep size is going to be 144, like so. And now we have a second person, so let's just duplicate this row. We'll add a second row, or a third row in this case. And right here we have Jonas. He's also 28, but he has a bicep size of 2 centimeters, for example. So he has a pretty small biceps. So now we can just add rows over and over again by using tr to add a new table row. And now we can populate those table rows by using td, which stands for table data, to create new table data for this row. But maybe we also want to structure this a little bit better, because at the moment we do not really know whether this here is just basic table data or maybe the heading of our row. And in this case, name, age, and bicep size are, for example, table headings and not just normal table data. Therefore, we should mark them as table headings to add a little bit more structure. So, to say that something is a table heading, we use th, which stands for table heading, instead of td for the data, essentially. And you can see we now have this bold outline. Again, this is not for styling though. This is again to tell search engines like Google how the structure of this table looks like. So let's just replace all of them with our th tags, like so, th, and th, like so. And this is how the table can essentially already look like. But if you want to describe even further to search engines how your table is structured, then you can do that by using thead, tbody, and tfoot. So we can, for example, say that this row right here is the head of our table. Therefore, we can use thead and put all of this content within the thead. And this here is the body of our table because it includes the actual data. Therefore, we use tbody right here and put all of the content into this tbody tag. And now maybe we also have a tfoot. In our case, we do not really have a tfoot, but let's just make one up. So let's just use another table row for our footer. And let's have some table data in there. Usually you would use that to summarize numbers, for example. So if you have a table consisting of numbers, you can use that one to summarize the sum, for example. But in our case, we do not have that. So let's just use random numbers. 23, 20, or 43, and maybe 77. Doesn't matter. I think you get the idea. So this is now the footer, the table footer. This is the table body. And this is the thead. Let's now get to one of the most important topics of this course, forms. If you think about a page like Instagram, for example, you know that you have a section to register, for example, a section to log in, a section to contact Instagram, and so on. And all of this is a form. So a form basically allows user to enter some input that will later get submitted to your page. And let me just create a form and then explain it to you, like so. So this is what the form looks like. You have an opening tag and a closing tag. And everything within this tag belongs to this form. Every form tag should have an action and a method attribute. And I'll explain them to you in a second. But first of all, let's take a look at a couple of important input elements. Instead of this form tag, you can now add input elements that allow the user to enter input, essentially. And the simplest input field is an input of type text. And when using Visual Studio Code, you can just use input, which is the tag, followed by the specific type of input you want to add. And you can see we already have a lot of different suggestions. So button, checkbox, color, date, date time, email, and so on. But we want to have an input of type text. So you just enter this within VS Code and then press enter. And VS Code will automatically create an input of type text for you. That includes the most important attributes. But for now, we can just delete name and ID since we will not need it for now. Like so, we have an input of type text. And as you can see, we can now just enter some text right here. If you want to have an indicator that shows the user what this input field is about, then you can use the placeholder attribute. And that one is a really important one because you will use it on pretty much every input field. And this here could be an input field for a username, for example. Now we can of course also create an input for email, so input type text. And this one could have a placeholder email, for example. And this here technically would work, but it's not ideal because there exists a type email inside of HTML. So we should use a type being equal to email if we want the user to enter an email. So whenever there exists a specific type for a specific purpose, you want to use this type. And again, if you just enter input : inside of VS Code, it will basically display all of the existing types to you. So let me just show the most important ones to you. An important input is, for example, the input of type date that allows you to essentially pick a date. So this one adds a date picker. Then there exists the input of type password, which you will use whenever the user should enter a password. And you can see this is kind of nice because it allows you to enter a password and the text is basically hidden. You can also add an input of type file, for example, that would allow you to upload a file. So let's add this one as well. Let me save this. And you can see now I could just choose a file from my desktop, for example. Let's take a look at a couple more. So input of type checkbox is something that you might want to use from time to time. And that one just adds a checkbox. If I duplicate the checkbox, you can see that I can tick this one, I can tick this one, and I can also untick this one and untick this one. If you want to connect multiple checkboxes essentially, then you can use a radio button. So use an input of type radio, like so. And you can see now I have this radio button right here. And let me just duplicate this radio button. So now I have two radio buttons and I can check both of them. So they're not connected yet. To connect them, you use the name attribute. You give both of those radio buttons the exact same name. And this tells HTML that those two radio buttons are now connected and only one of them should be selectable. So I could just say this here is, for example, the gender radio button, like so. And now I can check this one. But once I check the other one, this one will get deselected and the other one will get selected. So checkboxes, if you want to give the user the possibility to basically just check or uncheck a certain field, and radio buttons if you need to connect several fields. Let's take a look at the range input field, like so. And that one essentially just allows you to select a range. And that one also has a couple of attributes, for example, min, which allows you to set a minimum value. This one could be 0. Max, which allows you to define the maximum value, which could be 50. And you can also set a default value by using the value attribute, like so. And this one could be 25, for example. Or let me say it's 10, because then you will see the difference. So now this here is 10, this here is 0, and this here is 50. But now, up to this point, the user does not really have the possibility to submit this form. And to submit a form, you usually want to have a submit button. And there exist two different possibilities to submit or to add a submit button. The first one is to basically just use a button of type submit, like so. So this is the button. And now you can, within the tags, add the text that you want to add. So submit, for example. So now we have this submit button. And whenever I click this submit button, the form will get submitted. What does submitting the form mean when it comes to HTML? Submitting the form means to execute the file that we define within this action attribute. And usually this is going to be a PHP file. So index.php, for example. Let me just reopen this with the live server. Let me press submit. And you can see we're getting this page isn't working. And let me just reopen this by using the live server, like so. Let me change this here to a GET request. And now I'm just going to press submit right here. And you can see we're getting cannot get /index.php. And the reason for this is that we obviously do not have an index.php file. But usually you would create an index.php file. That file will get executed and then store all of those values on a server. But that is something that you'll learn in my PHP course. So that is nothing you have to worry about at this point. But just remember, whenever you press a submit button, so a button of type submit, the file that you'll define within this action attribute will get executed. And the method used to execute this file will be the method you define within the method attribute. In our case, it's the get method. What does get mean? Get is basically a method to submit your data to a server that is not secure. If you submit this file using the get method and you have a name, for example, then the name will get added to the URL, like so, for example. So this is how this would look like. And of course, everyone who would get this URL or see this URL would then know your name. And in this case, it's probably not that bad. But if you would have a password, for example, and you will submit it like this is of course not secure at all. Using a get method is not really secure at all and is something that you definitely want to avoid if you have sensitive data like credit card numbers, passwords, and so on. So most of the times when submitting a form, you actually do not want to use get. If you want your data to be secure, then you always have to use a post request like so. If you submit your data using a post request, then the data will be submitted in a secure way that will at least make it a lot harder for attackers to get the data. So when having sensitive data, always use a method being equal to post. If you want to give the user the opportunity to bookmark something, for example, if you have a shopping page that has a lot of different shoes, then using get can be kind of useful because if you think about a shopping page, then you have index.html/shoe being equal to 1, for example. Then the user can just copy this URL, paste it somewhere, send it to someone, and the other person will have a bookmark and get the exact same shoe, for example. So when bookmarking stuff, this can be kind of useful. And then a get request might make sense. But for most cases where you have sensitive data, you definitely want to use post. The second method to get a submit button is to use an input of type submit essentially. And right here you define the text for the button within the value attribute. So this here could be a register, doesn't matter. And now you have a register button. And there's not really a difference between using input of type submit or a button of type submit, but I usually just use the button because obviously, in my opinion, a button is made to be a button. So I use a button of type submit. And if you want to have a reset button, then you can also use a button of type reset, for example, like so. So one for submitting, one for resetting. Obviously, resetting is something that you barely want to do, but in case you ever want, this is the reset button, and that one will essentially just reset the entire form and therefore clear all of the input elements. Something that is useful about using the right type, so for example type email, is that when submitting the form, you will also get errors within HTML. So hello, for example, I'm going to press submit, and you can see we're getting this warning. Please include a net in the email address. So HTML already gives us a little bit of feedback if something is missing. This is not really a way to validate whether the input was correct, but it is a first step, I would say. Something that you might want to use from time to time is also a text area. So right now we only had a couple of input elements, an input of type text, for example, that allows us to enter a little bit of text. But maybe you have a super long blog post and the user should add a lot of text. Under those circumstances, a text area might make sense, like so. I'm going to save this, and you can see now we have this text area. We can also add a couple more attributes, so let me delete name and ID, since we do not need this at the moment. And we can also add something like calls, which stands for columns. And now we can, for example, say we want to have 10 calls, or we want to have 30 calls. And maybe we also want to have a couple more rows. So let's add rows, and let's say we want to have 30 rows. So now we have a lot more rows and a lot more columns. But actually, you'll barely ever use calls and rows. I just wanted to show you that this works. Nowadays, you actually use CSS to style your text area. Let me also explain a name attribute a little bit closer, because as you can see, VS Code usually generates the name attribute automatically. So it somehow has to be important, right? And it is because the name attribute will be used within your backend to store data on the server. So I do not really have to understand this too much at the moment, because I'll explain this a lot more in my PHP course. But the name attribute will be used as a name, or as a key to be precise, if you store your data on a server later on. So it might make sense to add a name of username, for example, right here, because then later on the key will be username and the value that will be stored on the server will be the value the user enters right here. But again, if you do not understand this yet, that doesn't really matter. Hey guys, it's me again, and I actually forgot to introduce you to one important element, which is the label element. If you have an input, let's create an input of type email, for example, and you want to have a label for this input that precisely describes what this input is for example, then you can of course use the placeholder as already mentioned. So I could say this is our email field. But there is also a second possibility, which is the label. Let me show you. So I can just create a label like this, and now you can add some text right here. So I could just say email right here. So now we have this email label. But what is the purpose of a label? Why can't we just use a normal paragraph, for example? Usually you can link this label to your email field, and clicking on this label will then highlight this email input field. And in order to do so, you need to add an ID attribute to your input field. And now you can define a specific ID. The ID can be email, for example. Something that is important about the ID is that an ID has to be unique. So this ID of email can only be used once on the entire page. So if you have a second input field that is also of type email, for example, let me show you. So let's have an input of type email. And you also want to define an ID. Then the ID cannot be email again. It can be email 1, 2, email with 2 L's, for example, and so on. But it cannot be the exact same ID. So that is important. An ID has to be unique. And now you can link this label to this input field by using the ID. And you define or you specify this ID that you've defined right here for our input within the for attribute right here. And this will now link our label to our input field. And if I'm now going to click on the label, you can see that we're immediately getting redirected to the input field, and we can now enter our text. Let me show you again. We are clicking on the label, our cursor jumps into the email field, and we can now enter the value. So you can either use the placeholder, or you can use the label, or of course you can also use both combined. So that's up to you. At this point, you know pretty much all of the important stuff when it comes to HTML. There's only one important thing missing, and that is Semantic HTML. If you think about all the stuff that we've learned up to this point, you realize that a lot of the things only had the reason to tell a search engine what your page is about. For example, you could also write some text like this. Nevertheless, you use a paragraph to write some text like this. And the only real point of a paragraph is to really structure your page. And usually every page should have a certain base structure. Every page should have a header, a main section, and a footer, like so. And later on, within those sections, you have the actual content. For example, you could have an H2 about basketball within the main section, then a little bit of text, another H2 about football, and so on. So all of this stuff would belong into the main section because it is the main content of your page. So the main section includes the main content of your page. So essentially, the content the user is coming for. If you have a blog about sports, for example, then the main section includes all of the content about sports that the user might be interested in. The header, on the other hand, includes things like navigation, for example. If you think about Instagram, for example, you have this navigation bar at the left. And this is not really the content we are coming for. This is just some content that enables us to navigate on the page. So that enables us to get to the section we are interested in. And this here is basically the content that would belong into the header. This allows us to navigate on the page and so on. The main content, in fact, would be the post or all of the posts, because that is the content we are interested in. What is the footer? The footer is essentially just some additional information, copyright information, information about the company, contact information, and so on. And if you think about Instagram, it's basically the bar right here at the bottom. That is about, blog, jobs, help, API. That's nothing the user really comes for, but it is content that might be necessary for a couple of us. So that belongs to the footer. And those ones are the most important tags in HTML, but you can further structure your page. If you have a navigation bar, like the nav bar on Instagram, you usually put that one into the nav tag. So this here says that all of the links, all of the nav links should be within this nav bar. So this here is the wrapper for our navigation bar. If we have an anchor, for example, that redirects the user to a contact page, another anchor that redirects the user to an About Us page, and another one that redirects to our homepage, for example, then this is the navigation bar and should be within a nav tag. Usually you can also further subdivide your main section into multiple sections, for example. And to do so, you can use the section tag like so. For example, you could have one section that talks about sports, then you could have another section that talks about cameras, And you could have another section that talks about getting rich, for example, doesn't matter. And within each section, you want to have a little bit of content. In the sports section, for example, you want to have a couple of articles. For example, one article about basketball. So let's have an H2 in here that says basketball. Now we have another article that maybe is about football. Article, like so, and H2 football. And now each of those articles has an H2, maybe also a paragraph that has a little bit of text. Doesn't really matter so much, like so. So a section basically groups related content on a page, whereas an article is more or less some content that does not need any other content. If you think about an article about basketball, for example, you could just take this article and put it on any other page and it would still make sense, because it's just an article about basketball. It does not need to be on this page to make sense. So it's more or less a piece of self-related content that makes sense on its own, even if it doesn't belong on this page. Whereas a section subdivides your page into multiple subsections. So a section more or less belongs to the page. If you have some content on your page that does not really belong to the page, but is still on the page, for example an advertisement, then you want to use a site, for example. So right here you could add an advertisement, for example, that does not really belong to the content, so it's basically a side from the rest of the content. I'm going to be honest though, I barely ever use section, article and a site, and I really try to focus on having header, nav, main and footer. But of course, if you want to be 100% precise, I of course recommend you to also use section and article. And that is all you really need to know about HTML. In case something is still not clear or you have questions, I would always recommend you to use ChatGPT for coding, since when it comes to coding, it is, in my opinion, really good. It knows pretty much all of the stuff you need, especially when it comes to simple languages like HTML, and you can literally ask it pretty much anything and you'll get a good response. I would recommend you to probably practice a little bit coding with HTML, and afterwards you can definitely go on to CSS, because at this point, you know how to structure a website, but the website still looks terrible. And if you really want to make it beautiful, you have to learn CSS, because HTML defines the structure of your website, but without CSS, it will never look good. It's your favorite NPC, and today I'll teach you CSS. In this course, I will teach you everything you need to get started programming in CSS. The first website in the internet looked like this. And since no one wants his website to look like this anymore, every single web developer learns CSS these days. In this course, I teach you everything you need to get started. I show you how to set CSS up before we start talking about all the fundamental CSS concepts. And then we are going to build 3 projects together. And the last project will be a full HTML and CSS website where you can practice everything you've learned up to this point. I've designed this course for anyone who wants to learn CSS. So even if you're just a beginner, you'll be perfectly fine. So let's get started, guys. CSS stands for Cascading Style Sheet and controls how a website looks. It was introduced in 1996 by the World Wide Web Consortium to solve a key problem: separating design from structure. HTML defines the structure of a website, but without CSS, everything looks plain. CSS lets you control colors, fonts, spacing, layout, responsiveness, and a lot more across an entire website. Instead of styling elements one by one, you define rules that can apply everywhere, making your design consistent and easier to manage. It also enables modern layouts with FlexBox and grid, as well as animations, transitions, and so on. Today, CSS is used in every website. No matter what tools or frameworks you use, CSS is always part of the final result. You should learn CSS because it gives you full control over design and is essential for turning a basic website into something that actually looks good. For this course, I'm going to use VS Code as a code editor, but feel free to use anything you like. Right now, I only have this index.html file that includes a basic HTML template. And now there exist 3 ways to use CSS together with HTML. You can include it externally, internally, or you can write inline CSS. The most common method is external CSS. So let me show you how to include it externally. In order to do so, you create a separate CSS file. You can do so by, for example, creating a new file and giving that file any name. A common name is style.css. Every CSS file has a .css extension. So let's press enter. And now we've created an external style sheet. Now we need to reference this style sheet in our HTML code. And in VS Code, this is pretty simple. You just use link CSS and press enter. And this will already create the link template for you. So we are using a link to link our style sheet and connect it to our HTML file. The rel attribute is usually equal to style sheet. This just says that the relationship is essentially a style sheet. And href then points to the location. In our case, since our style.css is in the exact same folder, we can just say style.css. And this is actually all we really have to do. If I'm now going to write a line of CSS, for example, and you do not have to understand this one yet, but if I'm going to say background is equal to blue, for example, or black, doesn't matter, you can see that our background is now black. So our style sheet has been applied successfully. If you have your style sheet inside of another folder, so let me create a CSS folder, for example, let me move the style sheet in there, like so. And now, of course, you have to change or define the new location where HTML can find your style sheet. So in our case, we need to go into the CSS folder /style.css. So this just works the normal way. Now I can show you that this works again. Background black, and you can see we have a black background. So to link a style sheet externally to your HTML file, you use the link tag and you define the path to your file inside of the href attribute. That's external CSS, and that's also the most common method. If you remember one of those methods, that's the one you should remember. But there exist two other methods that I want to show you. The second one is internal CSS. And the difference is actually just that instead of linking your style sheet in the head, you write it in the head. So I use a style tag right here, and inside of this style tag you can now define your CSS styles. So I can actually just say that I want to have a background for our body, for example, of blue. Again, you do not need to understand this, but now we have a blue background. And the last method is inline CSS. And that is something that you definitely do not want to use usually. You can do it if you just want to test very quick, because it is a pretty quick way to write CSS code, but it's not a clean way. And it will make your code a lot harder to maintain in the long run. But let me show it to you. For every single HTML tag, you can also use the style attribute right here. And now you can just define a background, for example, or pretty much any other CSS property by writing it inside of quotation marks. So background of black, for example. And you can see this works as well. So to summarize, you can link an external style sheet by using the link element inside of your head. You can use internal CSS by using the style tag in your head, or you can use inline CSS by using the style attribute that every HTML element has, and then within quotation marks, you can just define the style. But from this point on, we'll only use external CSS. And usually you will always use external CSS. So that's also the recommended way. So let's link our file once again by using link CSS and pressing enter. And this will again link our style sheet. Our style sheet is currently inside of our folder. So let me move it out of there like so. And let me also delete the CSS folder like so. And now this should work again. So now our style sheet is linked to our HTML file. Now that we know how to link our style sheet, let's talk about selectors. Because you have elements inside of HTML, but you somehow need to be able to select those elements inside of CSS to target the right elements. Because of course you do not want to apply styles to every single element. Maybe you only want to apply styles to your body or maybe to a paragraph. And you've already seen the element selector, which I use right here. You use the element selector by essentially just typing out the element. So the element body will get targeted by just typing out body. I can also target a paragraph, for example. Let me write a little bit, like hello. So hello. And now I can just target our p tag by using the p selector, so the p element selector, like so. And now I can also say our paragraph should have a background of yellow, for example. And you can see now we have a yellow background behind our paragraph. So that is the element selector. If you would have a div, you would just say div, like so. For a list, you would just use ul, ol, whatsoever. So I think you get the idea. So that is how you select a specific element. The next way to select an element is the ID selector. Let me show you. If you think about this paragraph, for example, you can also define an ID for this element, like so. And now you can specify an ID name, and this can literally be anything you like. You can come up with a name and it works. Most of the times you will of course use descriptive names because this makes your code a little bit easier to read. But you don't have to, you can also use X theoretically. Just doesn't make too much sense. But right here, if you have a name, for example, like NPC codes, then an ID name of name might make sense, for example. And now you can target this ID within your style sheet by using a hashtag followed by the ID that you've specified. In our case, name, like so. And now you can again define a background of red, for example. Something that is important to know about IDs is that an ID is unique. You can only use an ID once per page. So it should not have two paragraphs that have the exact same ID. That is something that you definitely want to avoid. An ID should only be used once. So if you would like to have a second name, then you should use name1, for example, or pretty much any other name. But using it twice is something that you do not want to do. If you want to reuse something multiple times, then you should use a class selector. A class is essentially like an ID, the only difference is that a class is not unique. So I can reuse a class across multiple elements. And it's really useful if you want to define a style once and have a couple of different elements styled the exact same way. So if you think about a card, for example, it might make sense that every card on a website looks pretty similar, or an input field, for example. So under those circumstances, a class might make sense. So I can say this here is the class of cool, for example. Doesn't matter. And now I'm just going to say hello, I duplicate this, hello again, and so on. Doesn't matter. And now I can target every element that has the cool class by going to my CSS style sheet using a dot. A dot means I want to target a class followed by the class name. And now again I can just write a style, and you see this style gets applied to every single element that has the class .cool. Also, you do not have to understand this syntax right now. I'll explain this in a second as well. Those ones were the most important selectors. And if you remember any of the selectors I'll tell you right now, those are the selectors that you should remember, because you will literally use them 99% of the time. But I want to show you a couple of other selectors that you will see from time to time probably, so you'll at least recognize them. So let me delete this. And let's imagine that we have a div right here. So let me wrap all of this content inside of a div, like so. And let me also have another paragraph outside of the div. And that one says, I am outside of the div. And let me also just delete all of them and replace them with the normal paragraph that says, I am inside of the div. So now this is a little bit clearer. So we have one paragraph inside of a div and one paragraph outside of a div. And now I could, of course, just target all of the paragraphs by using the P element selector, like so, and I could give them a background of yellow. But imagine I only want to give a background of yellow to all of the paragraphs inside of a div. And in those circumstances, I can say div space P. And this means target every single P element that is inside of a div. So let me save this, and you can see now only a paragraph inside of a div will have this style, this background of yellow. Every paragraph that is outside of a div will not get this background. And it also doesn't really matter how the structure is. So even if this paragraph is nested deeply inside of this div, like so for example, it will still get applied. So it does not need to be a direct child. Also, since I'm already using those words, what is a child and what is a parent? Essentially, the element inside of another element, so let me delete this and let me delete this. The element that is inside of another element is essentially the child. So this P right here is a child of this div because it is inside of this div. And this div is a parent to this paragraph, so to this P tag, because it wraps the paragraph. If you take a look at this div, for example, and this paragraph though, those ones are called siblings because they sit next to each other. So they are essentially on the same level. And this is especially important for a couple of selectors I'll show you right now. Because right now, we are targeting every paragraph that is somewhere inside of a div. So as I already mentioned, even if we have a span wrapping our P tag, we are still going to select this P, because it does not matter how deeply nested this paragraph is. But now I can also say I only want to target a direct child to this div. What is a direct child? A direct child sits directly under the div. So it's just one level lower essentially. Let me show you. So I can target a direct child by using this symbol right here. And this will only target a direct child. So right now, our p tag is a direct child because it is right below our div. If I'm going to move it into our span though, so let me remove it right here and let me place it inside of our span, you can see that our style is now gone. Because only our span is now a direct child to our div. Our p is now a direct child to the span, and it's not a direct child to our div anymore. It is a child to our div, but not a direct child. And that is really an important difference when using this selector right here. So the direct child selector. Now there also exists the sibling selector. Let me show you. So let's just use a plus. And you can see we are selecting the second paragraph. So a direct sibling to our div. Because it is on the exact same level and it sits directly after our div. Let me also show you what happens if I have another paragraph right here. I am the closest or nearest child, for example, like so. And you can see we're only going to select the nearest or the direct sibling to our div. We're not going to select every sibling. And the closest sibling, so the sibling that follows our div, is the first paragraph right here. The second one is a sibling of our div, but it's not a direct sibling. So that is important to understand about the plus. It will only select the nearest sibling, but not every sibling. If you want to select every sibling that follows, then you have to use the tilde symbol like so. And this means select every following sibling of this element. Now there also exists an attribute selector. Let me show you that one very quick. So let's have an anchor tag, for example, and that one will have href of www.google.com. And now this one redirects to Google, for example. Doesn't matter. This link will not even work, but it's enough to show you how this works. And now we only want to target an anchor tag that redirects to Google, for example. So maybe this here redirects to Instagram, but we only want to select the anchor tag that redirects to Google. And in order to do so, we can use the attribute selector. So we can say we want to select every anchor tag. Now we use those braces right here. And right here we say that our href, like so, needs to be equal. Let's just copy it right here to www.google.com. And only then we are going to select this anchor tag. So let me give it a color of red. And you can see our first Google link is now red, and the second one goes to Instagram, like so, and that one still has the normal default style applied by HTML. You can also make this a little bit more specific. You can also use this symbol right here, and then you could just say www, for example. Let me save this, and this will select both of the anchor tags, because this here means, does this href attribute start with www? And in both cases, it does. If I'm going to say www.sw, for example, then you can see our second link will not get selected anymore because it does not start with www. So this operator essentially means, does this start with this? You can also have include, like so, by using the asterisk, and this will still target both of them. If I'm now going to delete one of them, you can see that the second one will not get targeted anymore. If I'm going to add it right here though, you can see Instagram will also get targeted once again, because now we have www within this link. It's just at a different position. So when using this symbol right here, the position does matter, because this means does the start with this specific value right here, whereas this asterisk means is www anywhere inside of this string. And now, of course, you can also check whether something ends with a specific character sequence. And in order to do so, you can just use the $sign like so. Obviously, nothing ends with a www. So let's, for example, use .com like so. And let's, for example, change Instagram to .de. And now we'll only have this result for google.com. So I think you get the idea. To summarize it very quickly for you, to target a specific element, you just use the element name, A for example, for an anchor tag. To target a specific ID, you use a hashtag followed by the ID name. To target a specific class, you use a dot followed by the class name. To target an element inside of another element, you just use the parent name followed by the child name. To only target direct childs, you use this selector right here. To target the nearest sibling, you use a plus symbol. To target every sibling, you use the tilde symbol like so. And to target a specific attribute, you use those braces followed by the attribute you're looking for. For example, href equals whatever, you get the idea. And that is how you target specific HTML elements inside of CSS. Let's now delete all of this, and let me also delete the anchor tags because we will not need them anymore. Now I want to explain the CSS syntax to you. In order to do so, we can just use a basic paragraph, and let's just have a text hello, for example. Now, as we already know, we can select our p tag by using several ways, but we can just use the element selector, for example, and specifying the element name, so p. This will target all of the paragraphs on our website. Now, after every selector in CSS, you will have those curly braces, and inside of those curly braces, you define your rules, so the rules that you want to apply to those elements, to the elements that get selected by using the selector. And a rule can look like this. You define something like background, for example, so that is a property, the property that you want to target. After the property name, you use a colon. After the colon, you define a value for this property, for example red, and every single statement, so every single property value pair ends with a semicolon, like so. So you always have the same structure. The selector, then the braces. The braces wrap all of the rules that get applied to the selected elements, and those rules consist of property value pairs, to be precise. So you have a property name can be background, for example. It can also be color, and so on. So there exist a lot of different properties that you can define, and you just have to memorize them or look them up, but we go through them step by step. And of course, after the property name, you use a colon, followed by the value, the specific value, and you'll end the statement by using the semicolon. So that is pretty much the structure that you'll always see inside of CSS. And if you understand that, you've already understood the basic concept of CSS. Now that you know how this works, let me introduce you to one of the most important properties, the background property that we've already seen a couple of times. So I can define a background, or to be precise, a background color, by using the background minus color property and just define a color name like aqua, aquamarine, azure, and so on. And this will just use a background for the selected element. You can also just use background, and this is just a little bit shorter, but this works as well. But there exist a lot of different ways to specify colors. You can just define a name, but you can also use the hex code, for example. So you could, for example, also just say hashtag FFF, which is white, save this, and now you will get a white background, which you will not see because, of course, white on white is basically invisible. But you could also use a different hex code, so hashtag E06D60 is a form of red, for example. So you can use color names or hex codes. What exactly is a hex code? A hex code is essentially just a representation of color represented as a text. And every sequence of characters essentially belongs to a certain color. So this sequence of characters right here belongs to this red, for example. So this is just a way to specify colors by using text. You can also use RGB values. Let me show you. So RGB, then you use opening and closing brackets. And inside of those brackets, you have to define three values. A value for red, a value for green, and a value for blue. And every value can be between 0 and 255. Why is that? The reason for this is that RGB works, and we are able to define every single color by using RGB between 0 and 255. Is obviously that every single color is made up out of red, green, and blue. And by mixing red, green, and blue, you can get any other color. So if you say, for example, that you want to mix 255 of red, so basically have pure red, together with 0 and 0, so 0 for green and 0 for blue, then you will basically just get pure red. If you only use 100 for red, then you will get this form of red. But now, of course, you can also mix red and green by using 100, 100, and now you will get this color right here. So this is basically some form of yellow. if you say 255, 255, then you will get pure yellow. So mixing red and green, for example, will result in yellow. And that is how all of this works. Now we could of course also add blue, for example. So 255 of blue. And if you take all of them at the maximum level, then you will get white. If you take all of them at the minimum level, then you will get black, obviously. So by using RGB, you essentially just mix colors to generate any existing color. And now you can of course also use RGBA, and it works the exact same. The only difference is that you can add transparency, so an alpha value. And that alpha value can be between 0 and 1. 1 stands for maximum transparency, so you just basically have the normal color, like so. Whereas 0 means full transparency, which essentially means it's invisible. But now you can of course also use a value in between, like 0.5, which means it's 50% transparent. And let me show this to you for red, for example, like so. And you can see we have a slightly transparent form of red. So I hope you understand how this works. And actually the easiest way to get a color is by just going over to the Google color picker, for example. And right here you can just pick a random color, for example, like so. So you can just grab a color, doesn't matter, that's up to you. And right here you see a representation of that color as a hex code, so I can just copy this hex code. You also see a representation of this color as an RGB value, so you can also just copy the RGB value. And then you can basically take this value right here, so copy that one, paste it in here. Let me minimize that one, and I'm going to save this, and you can see we're getting this color as a background. So to summarize, you can represent colors by using their names, by using the hex codes, by using the RGB values, or by using the RGBA values. And that is something that does not only apply to background colors, that is something that applies to all of the colors you will ever see in CSS. So if you define a text color, it works the exact same. Let's now take a look at background images. And let's actually set a background image for our entire body. So for all of this right here. So I'm going to target our body element like so. And to set a background image, use the background minus image property. Alternatively, you can also just use the background property. So this works as well. Now you have to use the URL function right here, like so. And inside of this function, you can now define the path to the background image that you want to use. So let's first of all download a background image that we want to use. I'm going to use Unsplash in order to do so. So let's go to Google. Let's enter Unsplash. Let's click the first link. And let's select a background image that we want to use for our website, for example. And I'm going to search for seamless pattern, for example. But choose whatever you like. I'm just going to download the first one. It also doesn't need to look too good, to be honest. It's just for demonstration purposes. So I'll drag it in. I'll rename the image to bg.jpg. And now I'm going to go back to our website. And inside of this URL property, we now have to define the path to our image. And in our case, it's bg.jpg because we're in the exact same folder. Of course, if this image would be inside of a folder, then I would have to use the folder name /bg.jpg. So I think you get the idea. This is just completely normal, the same way you would do it in HTML. I'm going to save this, and you can see now we have a background image for our body. But you can see it still looks pretty weird, and there exist a couple of different properties to control how a background image should look like. The first one that is pretty important is background minus size. And right here, there exist different properties, and VS Code already suggests us the most important ones, and those ones are especially contain and cover. And you'll especially oftentimes use cover, because that just means cover the screen. So you can see now it covers the screen. Let me also show contain to you like so. So what is the difference between contain and cover? Cover essentially just says cover the entire screen, even if you have to cut off a certain part. Contain means please show everything, even if there's something that is white in the end. So even if there's something that is not filled. So let's keep using cover right now. And as you can see, the background right here repeats. So in order to change that, we can use the background minus repeat property And right here, you oftentimes want to say no minus repeat to not repeat the background. And you can see our image still covers the entire width of our background, but it does not repeat anymore. If I'm going to use contain, I think now the difference should be pretty obvious. You can see we're only getting this result. So it does not cover the entire width of the page anymore, but it will keep its aspect ratio. So the aspect ratio is correct, but it is possible that there exist white spaces. Let me also show you the background minus position property, because that one is kind of important from time to time. And right here, you can just say things like left, right, top, bottom, center. Let me show you center, for example. And you can see this just centers the image. We can also use left right here, which aligns our image to the left. And we can also use right, which aligns our image to the right. So I think you get the idea. You would not really see this too much if we would use cover, because now right, left, and center would look pretty similar. Now you could use top and bottom as well, and there you would see a slight difference. But under those circumstances right now, using cover together with our background position property does not make too much sense. So I'd rather use contain right here. And the reason that this here does not position our image to the bottom is that our body only takes up the minimal necessary height. I could change that by using a height that covers the entire screen, but that's a topic for another video. So I'll introduce you to this later. So to sum up, you can set a background image by using background together with the URL function. You can control the size of this background by using background minus size, and oftentimes you will use cover. You can also define whether the background should repeat or not by using background minus repeat, and you can define the background position by using background minus position. Let's now delete this and let's understand a little more about text. We already have our text right here, so our paragraph. But how exactly can we style text? And text does of course not only have to be a paragraph, it can also be an H1 for example, an H2 and so on. So this here is of course text as well. But how can we style it? How can we change the font? How can we change the color? How can we change the thickness? And so on. So let me show you. First of all, let's go to our style sheet and target all of the P tags for example. And now imagine we want to have a different font family. We can do so by using the font minus family property. And right now, VS Code will already suggest us a couple of pre-installed fonts that we can choose from. So something like Arial, Times New Roman, and so on. So pretty much every PC has a couple of pre-installed fonts, and those are a lot of those fonts. So I can just choose Arial for example. So let me just choose that font, and I'm going to save this, and you can see we now have a different font for our paragraph right here. So right now, this here means if the font Arial is installed on the system, we're going to pick Arial. Otherwise, if Arial is not available on the system, we're going to pick Helvetica. And if Helvetica is not installed on the system, so on the user's PC for example, then we're going to choose any font that does not have serifs. So sans serif. So then the system is going to decide by itself. So those two fonts are essentially backup fonts. So I could also just write Arial, and this would be the exact same result, but it would be bad if a user does not have Arial installed and then just randomly gets another font, because this could of course break the design you're choosing. So it might be smart to use a backup font. Of course, oftentimes you also want to use different fonts. Maybe you want to use a font that is not pre-installed on a system. And you can do so by using Google Fonts and embedding their fonts on your website. So let me show you how this works. You're going to go over to Google Fonts. Right here, you can browse for a font. So you can just choose a font that you like. A lot of people use Roboto, for example. So you can just press on the first font right here. Now you can just press on the Get Font icon. You can either download the font, but embedding the font is a little bit easier most of the times. So you can just press Get Embed Code. And right now, you can just copy this code right here. You're going to take that code and you can now paste it into the head of your HTML file right here, right before linking your style sheet, like so. So this is how this works. So now you have linked the font within your project, and now you can reference the font by using font minus family Roboto, for example. And as a backup, they suggest using sans minus serif. So any font that does not use serifs. So let's get back to our CSS code. Let's go to our page so we actually see the difference. And let me just use font minus family Roboto sans serif. And you can see it looks a little bit different. But the difference to Arial is not that big. So I'm going to apply that font to our H1 as well, like so. And you can see we have a different font for our heading as well. So let me also explain to you how this works. Let's go back to our index.html. And right here, we've linked our font. And you can see we're actually referencing this page right here within the href attribute. So let me just copy this link right here. And let me paste it in here. Let's press enter. And you can see this is what we're getting. And this right here is the definition of how the browser should get the font. The font, in fact, lies on the Google servers. We are requesting the font from the Google server and then getting this font within our project. And this is what you call a CDN, a content delivery network. Because we're not embedding the font directly in our project, but instead we are requesting the font from the Google servers. The Google server responds and gives us the font, and then we can use this font inside of our project. And right here, they defined the rules of how we can get this font. So that is why we need to use this link within the head of our HTML file. So I hope you understood this, but even if you did not, it's not really that important as long as you remember how this works. And if you want to get a deeper understanding, you can also read a little more online. There's also another option to embed fonts into your project, and that is actually just downloading the font and embedding it into your project. And that's something I've barely ever seen. I just want you to know that this is possible, but usually you will just use a content delivery network like Google. For now, let me explain to you how you can change the size of a font. For example, if you take a look at our heading is pretty big. Maybe we want to have a slightly smaller font size. To change the font size, you can just do font minus size, and right here you can define the font size. You can do things like large, larger, X large. So I think you get the idea, but most of the times you will just use pixel values. Let me show you. So you can just use something like 16 pixels, and that is the default font size of most browsers. You can also use 20 pixels. You can use 40 pixels, 100 pixels, and so on. So let me explain to you what a pixel is. Every screen is made up of pixels. If you have something like a TV, for example, or a normal desktop screen, doesn't matter, it looks something like this. And then every image consists of pixels. And a pixel is essentially just a square. And then you have a lot of those squares next to each other. And every single pixel has its own color. So maybe one pixel is yellow, for example. The next pixel could be red, for example. And then you might have another pixel that is purple. Doesn't really matter. So I think you get the idea. And in the end, an image is just a combination of a lot of pixels. So even though the entire image exists of squares, it does not really seem like that to you because you have so many pixels that you cannot really realize that all of this is essentially just a square. In the end, you have probably here a pixel, here a pixel, here a pixel, here a pixel. And after a while, once you get enough pixels, essentially, you can see this might look like a head. Obviously, I don't have enough pixels right here, but I think you get the idea. At a certain point, you will just not see the blocks anymore, and you will just see a normal head, for example, or whatever you see on the TV. And if you define a font size of 40 pixels, for example, then you say the font should have a size of 40 of those pixels, so 40 out of those building blocks. And if you think about Full HD, for example, those screens, for example, have 1920 pixels of width and 1080 pixels of height. So that is Full HD, for example. And 4K is 1920 times 2 and 1080 times 2. So pixel values are essentially just absolute values that define the size of a font. If you want to define the size of text, there also exist em and rem. So let me demonstrate it to you. Let's, for example, say we want to use for em. You can see our text gets a little bit bigger. You can also say for rem. And you see we have the exact same font size. So what is the difference between M and Rem? And what is even M and Rem? Rem always refers to the font size of the root element. What is the root element? The root element is our HTML element because the root wraps every other element on your HTML page. So the HTML element, because the HTML element wraps every other element on the page. So that is the root element. You can target the root element by using :root, for example, like so. And now we can, of course, also for our root element define a font size, like so. So we could say 10 pixels. Let's save this. Let me also delete the font size right here. And you can see our paragraph now has a slightly smaller font size, and our H1 also has a slightly smaller font size. The reason for this is that a lot of CSS properties, including the font size, will get inherited from the children. So if you define the font size, for example, for a parent element, like the HTML element, which wraps the entire page, so every other element on the page is a children of the HTML element, then all of the children will inherit this font size that you've defined for the parent element. If I'm now going to say for H1 that I want to have a font minus size of 20 pixels, we will use this absolute value of 20 pixels or 40 pixels. That doesn't matter. But of course, I can also define a relative font size for H1 that orients its scaling on the font size of the root element. So I can say for rem, which means 4 times the font size of our root element. Since we have 10 pixels right here, this is equivalent to saying 4 times 10 pixels, so 40 pixels. I can also say 10, and now I'm getting 100 pixels of font size because the font size of our root element is 10 pixels. If I'm going to change the root font size to 4, for example, you can say that this font here gets smaller as well because we're scaling our H1 font size according to the font size of our root element. So I hope you get the idea. If I'm now going to say M instead, you see we're still getting the exact same effect because M orients to its closest parent where a font size is defined. But if I'm now going to use a div and wrap our H1 and P tag with a div, for example, like so, and now I'll define a font size for this div, for example, like 10 pixels, for example, so font minus size 10 pixels, you can see that this here gets a lot bigger because M orients its font size to the font size of the closest parent element. And the closest parent element right now is our div. I could also set a font size for the body. Maybe I'll say font size 20 pixels. Nothing changed because at the moment our closest parent where we have a font size defined is our div. If I'm now going to delete the font size for our div though, then the closest parent will be our body, and therefore we will have 10 times 20 pixels. So 200 pixels of font size for our H1 element. And you see it gets super big. If I'm now going to use rem though, even though we have a font size defined for our body, it is going to take the font size as a reference of the root element, which is 4 pixels, so 10 times 4 pixels, 40 pixels. And you can see it's a lot smaller right now. So rem uses the root element as a reference, whereas M uses the closest parent where a font size is defined as a reference. So that is the difference. And pixel values are always absolute values. So if you just want to have a fixed value, you use pixels. Let's also delete this and let's understand font weight. If you take a look at our heading, you see that the thickness of the text is pretty big, whereas the thickness of our paragraph is pretty small. But maybe you want to have a thicker paragraph or a thinner heading, for example. In order to change that, we can use the font minus weight property. Right here, you can use text values like bold or numeric values like 100 to 900. Let me first of all show the text values to you, so bold. And you can see now our paragraph is bold. I can also use something like thin, for example. Now we have thin text. And you can see we have a lot of different text options. So you can just go through them yourself. We have bold, bolder, light, normal, and so on. But most of the times you will just use numbers. 900 is super bold essentially, and 100 is super thin. And everything else is in between. And the text value bold is essentially 600 as a number. changing the color of text is actually pretty simple. You just use the color property. And the rest works exactly the same as for backgrounds. So I can either use a color name, like blue for example, or yellow, that's up to you. You can also use a hash code like hashtag FFF, which would be white. So we can also say hashtag 6C, 3E, 3E, like so. Now we have red. Or we can of course also use RGB values. So RGB of maybe 255, 150, doesn't matter. And of course we can also use RGBA, which again includes transparency as the last value. So we can add a value between 0 and 1, for example 0.4. And now we have a color that has 40% transparency, or only 40% visibility to be precise. Let me also introduce you to text align. If you want to align your text, you can use the property text minus align. And you can align your text to the center, for example, like so. You can align it to the right, like so, or to the left, like so. If you have a little more text, so let's imagine we are having, hello guys, this is the best course online, trust me bro, like so. Imagine that is what we're having right here. And now I want to have a little bit more spacing between those lines. And we can do that as well in CSS by using the line minus height property. And right here, you can define a line height. 1 is just the normal default value. 2 is of course a little bit more. 0.5 would be a little less. So by using those values, you can essentially define the spacing between characters. And of course, you can also use super big values like 5, 10, that's up to you. But I think 1.2 is kind of right. And let's also take a look at text minus decoration. From time to time, you maybe want to have an underline, you want to have an overline, you want to have some stuff like that. And you can do so by using text minus decoration. Text decoration of underline adds an underline, for example. Text decoration of overline adds an overline. Text decoration of line through, for example, adds a line through, and so on. So you have a lot of different options. But actually, the option that you will probably use most often is going to be none. Why actually none? Let me show you. The reason for this is that every time you have an anchor tag, so let me add an anchor like so, and that one says Google, for example. Every time you add an anchor, HTML will by default add this underline right here. And this underline, of course, doesn't look too good. So something that you might want to do pretty often is target an anchor tag, and then you will just say text minus decoration of none, because now the underline is gone. And I think this looks a little bit better already. So let's just delete all of the styles and let's now understand width and height. In order to do so, we will first of all create a div, and let's just start to style this div. So let's go back to our CSS file, let's target our div, let's give it a background so we can actually see what's going on. And let's say the background is yellow-green, like so. But at the moment, we're not seeing anything. And the reason for this is that our div does not have a width and it does not have a height. So we can specify one by using the width property, like so. And now we can, for example, say that our div should have a width of 50 pixels. But we're still not seeing it because it still doesn't have a height. So we also need to define a height of maybe 50 pixels as well. And now we can see that we are seeing a yellow-green block. Of course, we can also say we want to have a height of 100 pixels. So that is up to us, but I want to have a square for now. Now there also exists the max width and max height property. And they are especially great if you want to have a responsive layout. Let me show you. Imagine we're defining a width of 1000 pixels. As you can see, we're having this block right now, but this block is super big and we need to scroll. And for responsive layouts, like mobile phones, this is not really good. So we can use max width under those circumstances, like so. And you can see, now our square fits on the page. And the reason for this is that our max width essentially says you can take up a maximum width of 1000 pixels, but if the space is not available, you do not have to take up that space. So you can shrink if necessary. And if I'm now going to resize this window, you can see it can take up a width of 1000 pixels, so essentially the entire screen basically. Otherwise, it can shrink if the space is not available. And using max width is especially important if you want to create responsive layouts that also work on a mobile phone, for example, or on different screen sizes in general. Let me now also explain different units to you for scaling. You've already seen the pixels unit, and you've already seen M and rem for text. But if you want to scale a div, for example, you can also use things like percentages, for example. So I could, for example, say, take up 10% of the available space, or take up 20% of the available space, or 50%. So that is up to you. It does not work for the height like that though, so let me show you. Because by default, the body element, so this one, only takes up the minimal necessary space. So by default, the body has a height of 0. And if you now say, take up 50% of the available height and there's no height available, then of course 50% of 0 is still 0. So by default, the body has a height of 0 and a width of 100%. And now you say, essentially for your div, take up 50% of the available space of the parent element and 50% of the height of the parent element, and then draw my div. And under those circumstances, of course, this div is going to be invisible. If I now say 50 pixels though, this works. So let me show you how this works by creating another div. So I have this div, and now I want to have a div inside of a div. And let's say this div will have an ID of container or parent, doesn't matter, and this div will have an ID of child. So this div is the child of the parent. Now let's target our hashtag parent, for example. Let's say our parent will have a width of 50% and a height of 500 pixels, for example. Let's give it a background of yellow. And actually 50 or let's say 100 pixels, that should be enough. And for the color, I use something that is a little bit darker. Now I also want to target our child, like so. And now I'm also going to give our child a width of 50% and a height of maybe 50 pixels, like so. And for the background, I'm just going to use a random color, so maybe yellow, green, like so. And you can see, now our child takes up 50% of the width of the parent element, which is in this case, hashtag parent, so the div, the parent div. And our parent div takes up 50% of the parent container again, which is the body in our case, and the body by default has a width of 100% and a height of 0. But since we've used absolute values for the height, that does not matter, but we scaled our width of the hashtag parent element relative to the parent container, which is the body, and the width of our hashtag child relative to the width of our parent. So 50% of 50% are equal to 25% of the entire body. So that is how this works. Width and height always refer to the width and height of the parent container. But you can also use units like viewport width and viewport height. So for example, 60 viewport width will take up 60% of the available space of the viewport. And the viewport in our case is this entire window right here. And by doing so, we are not limited to the size of our body container, but we rather refer to the viewport. And that is also great if we want to create designs for different devices, for example. Because by doing so, it does not matter whether we are on a mobile device or a window device. We will always take up, in this case, 60% of the available width of the device. And in this case, for example, 40% of the available height of the device. So I think you get the idea. Viewport width and viewport height refer to the device width and height, whereas percent refers to the height or width of the nearest parent. And if you just want to use absolute values, again, you can use pixels. So usually you can use pixels, M or rem, if you want to define the size of fonts, so of text. And you can use pixels, percentages, viewport width, and viewport height if you're working with things like divs, for example. Let's now understand comments in CSS. So let me just delete all of this. And imagine we wanted to create a node for ourselves, for example. In order to write a comment, you use a / followed by an asterisk, and you end the comment by using an asterisk followed by a / again. And in between those asterisks, you can essentially write your comment. So this could be a node for myself, and this can also be a multi-line comment by just moving this down, that my biceps is getting too big, like so. So I'm saving this, and you can see we are not having any effect on the page because a comment will essentially get ignored by the browser. So whatever you write within a comment is just there for yourself or other developers as a note, for example, as a reminder, and so on. So you can essentially use comments to document your code. So let's go back to our HTML code and let's just create a basic paragraph right here instead of having our divs. And that one could, for example, say, hello guys, like so. So right now we are having this output on our page. But maybe I want to have a border around our paragraph. So how can I create borders? In CSS, you can create borders by using the border property. So we first select our p tag, or every single p tag. Then we use the border property like so. And right here, we now have to define a couple of values. To be precise, we have to define 3 values. The first one is going to be the border width. That can be something like 1 pixel, 10 pixels, 30 pixels. So I think you get the idea. I'm going to use 1 pixel for now. As a second value, you have to define the border style. This can be something like solid, for example, like this. And as the last value, we have to define a border color. This can be something like black, for example. This could also be an RGB value, like so. So 100, 100, 100, and so on. Now, when I'm going to save this, you can see that we are now having a border around our text. Let me show you how this changes once I change the values. So let me just use 10 pixels, for example. And you can see we are now having a thicker border. I could also change the border style, for example. So instead of solid, I could, for example, say I want to have a dotted border. And you can see now we have a dotted border. Or let me also try something else. Let's maybe try double, for example. Now we have 2 borders. We can also use dashed and so on. So there exist a couple of border styles. To be honest, those were the most important ones, and you'll probably use solid most of the times. Let me also show you a different color. So let's maybe just use pure black, like so. And you can see we're now having a black border. Of course, we can also use yellow, yellow-green. So that is up to you. The box model is one of the most confusing things for a lot of beginners, but it's actually really easy. In HTML, every single element can be represented as a box. Imagine this paragraph, for example, that includes a little bit of text. This can be visualized as a box. Right around the paragraph, we have a second box. This box represents padding. Usually, this box is invisible, because padding is set to 0 by default. The third box represents the border. This one is also not visible by default, because there's no border unless you define one. If you do define a border, you will see that it is just a rectangle around your element. The outer box is called margin. This one is also not visible by default, because margin is usually 0. So what is the difference between padding and margin? If you set padding or margin on your page and do not have a border defined, it can be hard to tell the difference, because both just add space around the content. If you add a border, however, you will see that padding adds space between the content and the border, whereas margin adds space outside of the border around the entire element. Let's now take a look at the box model inside of CSS and HTML. In order to do so, let's first of all go over to HTML, so to our index.html, and let's create a basic p tag. Instead of this p tag, let's just have a little bit of text, so maybe hello bro, like so. Now we can visualize our CSS by maximizing this window. Let's right click on the element and let's press inspect. And this will open the Elements tab. And you know this Elements tab from HTML already, but right below this Elements tab, you also have those tabs right here. So styles, computed, layout, event listeners, and so on. And when working with CSS, especially the styles tab is important, because you can essentially go over an element, click that element, and you will get all of the styles right here that you defined inside of your CSS code or that HTML adds by default. If you take a look at the body element, for example, by default we have a display of block and a margin of 8 pixels. So a lot of elements in HTML will have a default margin of 0 pixels, but a couple of them will also have a little bit of margin added to them by default. So HTML just adds that by default. And the body is one of those elements. So the body by default has a margin of 8 pixels. You don't need to understand margin and padding yet, I'll explain that in a second. But just remember that you can click on an element like the p tag and you will see a lot of CSS styles. And if you now scroll down, You will also see a visualization of the box model. And that one is really great to take a look at an element. If we hover over the p tag, for example, you can see those boxes right here. And you can also hover over the box right here. And if you hover over the center box, for example, you will see a blue rectangle right here. And that one is the visualization for the content of the paragraph. So for the inner content box. You can always hover over the different boxes and you will get a visualization of those boxes. If you hover over the padding box, for example, you will see that we are not seeing anything, and the reason for this is that we're not having any padding yet. So you see we have padding of 0 at every single side. So it's also possible to specify different padding for top, right, bottom, or left, and the same of course also goes for border and margin. But I'll show that to you in a second. If we hover over our border, we also have a border of 0 pixels, so we're not seeing anything. But this is slightly different for the margin. So once we hover over the margin box, you can see that we have a little bit of margin top and bottom. So again, by default, the browser adds a margin top bottom to paragraphs of 16 pixels. And we can see that margin once we hover over this box. So that is how our paragraph currently looks under the hood. So now let me show you how the box model changes once I add a border, for example. So let's, for example, add a border to our paragraph instead of CSS by targeting our paragraph. And now let's add a border of 1 pixel, solid, black, for example. Let me go back to the page, and you can see now we have a border of 1 pixel around our paragraph. And you can see once we take a look at the box model, we also see that we have a border of 1 pixel at every single side. But now you can see that we have 4 sides, and we just defined the border for every single side at once. So isn't there also a way to define a border only for the top or only for the bottom? And of course there is. Once we go back, we can say that we only want to have a border top, for example, of 1 pixel, solid black. And you can see we only have a border top, for example, right now. And right here, we also only see a border of 1 pixel at the top inside of our box model. Let me minimize this for you for now. And let me show you the other properties. So I can of course also say border bottom, like so, which adds a border to the bottom. We can say border minus left to add a border to the left, or border minus right to add a border to the right. So by using border, you add a border to every single side, or you could specify to which side you want to add a border by using top, right, bottom, or left. So that is up to you. But for now, let's just add a border to every single side, because that will allow us to understand padding a little bit better. Let's go back to the page. Right-click the element, inspect. Let's go back to the box model. So imagine we want to add a little bit of spacing between our content, so the text, and our border. In order to do so, we have to use padding, as you can see, because padding is between content and border. How can we add padding in CSS? That is really easy. We can just use the padding property. So padding, and right here, we now have to define a value. So maybe a value of 40 pixels. This will add 40 pixels of padding into every single direction. Let's go back to the inspector, and you can see this is the content. We now have padding of 40 pixels into every single direction and a border of 1 pixel. So we added some padding between content and border. Now again, we can only add padding to the top, bottom, right, or left by using, again, padding minus top to add some padding to the top, padding minus bottom to add some padding to the bottom, padding minus right to add some padding to the right, which you will not see because there already is enough padding, or enough space to be precise, and padding minus left to add some padding to the left. There's also another shortcut. So of course you can use padding, 40 pixels for example, to add 40 pixels into every single direction, but you can also specify 2 values at once. So 40 pixels, 20 pixels for example. And this here says add 40 pixels top and bottom. So the first value defines the padding for both top and bottom, and the second value defines the values for left and right. So top bottom, left right. So to sum up, 1 value for all 4 sides, 2 values top bottom, left right, like so. And you can also use 4 values. So you could say 40 pixels, 20 pixels, 30 pixels, 10 pixels. And this would now be 40 pixels top, 20 pixels right, 30 pixels bottom, 10 pixels left. So top, right, bottom, left. So you can either use 1 value for padding, 2 values for padding, or 4 values for padding. Or alternatively, you can of course also use padding minus top, like so, padding minus right, bottom, left. So I think you get the idea. And now let's imagine we want to have some margin outside of the element. So outside of the border, we want to add a little bit of space. Let's scroll down. We now have a little bit of padding to the top. We have our content, we have a border, and we have a margin top bottom of 16 pixels. So one option would of course be that we don't want to have the standard margin HTML adds. In order to do so, we could essentially just say that we want to have a margin of 0 into every single direction. And you can see the margin is now gone. We can also say that we want to add a margin of 40 pixels into every single direction. So now we have a margin of 40 pixels into every single direction. Again, the syntax is similar to padding. Let's also say 40 pixels for padding. And now we can also say, or we can also specify 2 values. So top, bottom, left, right, for example. So now we have 40 pixels to the top and to the bottom, and only 20 pixels to the left and to the right. Or we could say 0 left and right. We can also specify 4 values. So 40 pixels top, maybe 100 pixels right, maybe 40 pixels bottom, which doesn't even matter because we have enough space to the bottom, and maybe 10 pixels left. Whoops, 40 pixels and 10 pixels. And you can see this here is the result. So 40 pixels top, 100 pixels right, 40 pixels bottom, 10 pixels left. And of course, we can also use margin minus top, like so. Let me save this. So now we have a margin top of 40 pixels, margin right, 40 pixels, margin bottom, should not change anything because we have enough space there, or margin minus left, like so. So this works pretty similar to padding. Let's now understand display block, display inline, and display inline block. Let's delete all of this for now, and let's also delete this right here, and let's just have a div. And you know, a div by default is a block level element, which means, let me just type something out, hello for example, and right here I have hello again. You can see this here is a block level element because it essentially takes up an entire row, so an entire block. On the other hand, I have a span right here that says hello from span again, and you can see they're sitting next to each other. So they're essentially sitting in line. That's why they are called inline elements. So what exactly is the difference? Let me, for example, now try to add a background to our div. So div will get a background of maybe green, doesn't matter. Let me also add a background to our span. So let's say our span has a background of blue, for example, like so. Now for our div, maybe I want to have a different height though. So let me say height 100 pixels. And you can see every single div now has a height of 100 pixels. And now it looks a little bit different. Now let me also try to add height to our span. So height 100 pixels. And you can see nothing changes. And the reason for this is that only block level elements can have height and width defined. Inline elements cannot have height and cannot have width. So that is something that only works on block level elements. By default, every element is either block or inline. To change that though, we can for example say that our div should have a display of inline, and this will turn our div into an inline element. Let me save this, and you can see width and height cannot be applied anymore. And I can do the exact opposite for our span. I could say our span should have a display of block. Now our span is a block level element. And now you can see our height gets applied to our element. But isn't it possible to also give them width or height, for example? So to essentially combine the best out of both. And in order to do so, we can use inline block, which essentially says you can sit in line, but now it's possible to define the width and the height. And let me actually make the text a little bit shorter so you really see how this works, like so. And you can see now they can sit next to each other, but they both have a height and a width defined. So to summarize, by saying display inline, you can turn an element into an inline element. By saying display block, you can turn an element into a block level element. And by saying display inline block, you can create an inline block element, which essentially behaves like an inline element, but can also have a width and a height. Let's now understand positioning in CSS. In order to do so, let's first of all create a normal div inside of our body, like so. And now let's style this div inside of CSS. So let's target our div, and let's give our div a width of 50 pixels, a height of 50 pixels, and a background of black, for example, so we can see it. To now use positioning inside of CSS, we use the position property like so. And now there exists a couple of different values for positioning. You can use position of relative, for example, you can use position of absolute, and you can use position of fixed, for example. And those are basically the most important values. Let's start by using position relative, like so. Once you give an element positioning, you get access to the properties top, left, bottom, and right. And let me show you how this works by using top of 50 pixels, like so. I'm going to save this, and you can see our box moved a little bit to the bottom. So why is that? By adding top of 50 pixels, we say, take our element and move it 50 pixels away from the top. So essentially, give it a gap of 50 pixels to the top. Now we can do the exact same for left, for example. So we can say left 30 pixels, for example, and this will take our element and move it 30 pixels away from the left. So position relative essentially means position the element relative to its own alt position. And the alt position of this element was essentially here. So by saying top 50, we say, take the alt top position and move it 50 pixels away from the top, and then take the alt left position and move it 30 pixels away from the left. So we land right here. So that is position relative. Now I can also use position absolute. And you will see that it will barely move at all once I save. So take a look at this, and you can see it slightly moved to the top left, but it barely changed at all. So what is the reason for this? Position absolute always positions relative to the nearest position parent element. But at the moment, we don't have a position parent element, because as you can see, no element in the tree has a position yet, because we didn't give any positioning to any other elements yet. So there does not exist a parent element that has any form of positioning. Under those circumstances, position absolute takes as a reference the screen, so essentially the window. So at the moment, our reference point is essentially the screen. But usually you want to have a position parent element if you use position absolute. So let's do this right now. Let's give this div an ID of child, for example, and let's create another div that has an ID of parent, for example. So we have a div that is our parent, and inside of it we have a div that is going to be the child. And let's say this here is our child div, like so. And now let's create a parent div. So hashtag parent, that one will have a width of 150 pixels, a height of 150 pixels, a background of yellow, green, for example, like so. And now I'm going to give it a position relative. So now our child element is going to position relative to its nearest position parent element, which is now our hashtag parent element, and will therefore take this container, the hashtag parent container, as a reference point. And you can see it's slightly moved. And I can show you that this works if I use bottom of 0, for example, and left of 0. And let me make this even clearer to you. Let's just use another div right here, and this one will have an ID of random container, like so. Let's also give this a random container. So hashtag random container, a width of 100 pixels and a height of 100 pixels, and a background of brown, like so. So you can see, even though we added a parent to our div, our child still takes our hashtag parent as a reference, because only hashtag parent has positioning, and it always takes the nearest positioned parent element. It does not just take a parent element, it takes the nearest positioned parent element. And our random container is not positioned yet. So as a reference point, hashtag child uses hashtag parent. But if I'm now going to add any form of positioning to our random container, you can see that it now takes our hashtag random container as a reference point, because now hashtag random container is the nearest positioned parent container. So if I now say write 0, for example, like so, like so, you can see it takes the random container as a reference and moves to its bottom right. So that is how position absolute actually works. And now there also exists position fixed, for example, and let me show you. You can see we move to the bottom right of the window. You will actually see how this looks once I give our body a little bit more height. So height 200 viewport height. And you can see right now we have a scroll bar because we have 200 viewport height, which is essentially more than the screen. So we are able to scroll right now. And once I start scrolling, you can see that our parent and our hashtag random container move out of the screen, whereas our hashtag child, which has a position of fixed, will stay at the exact same position. So fixed essentially just means pin this element to the screen and it will always stay at the exact same position on the screen. And this can be useful for navigation bars, for example. Because if you think about navigation bars, oftentimes even when you scroll, they stay at the top and you can always use them for navigation. So to summarize, position relative moves an element relative to its own old position. Position absolute moves an element relative to the nearest position parent element, and position fixed pins the element on a fixed position on the screen essentially. Let me introduce you to another concept that is called FlexBox in CSS. And that one is one of the most important concepts at all. Let me show you how this works by first of all creating a div. And that one is going to be our container div. So I call it hashtag container, like so. And inside of this container, I want to have a couple of divs. Let's have a div that has an ID of 1, for example. And then we'll have 2 more divs. The second one will have the ID 2. And the third one will have the ID 3, like so. So let's give every single container a background color. So for example, hashtag 1 will have a width of 40 pixels, height of 40 pixels, and a background of yellow-green. Let me just copy this. Let's paste this in here 2 more times. This here will be hashtag 2. This here will be hashtag 3, like so. And we'll have different colors. So right here, let's maybe use some form of blue, doesn't matter. And right here, let's have some form of whatever this is, like so. And as you can see, at the moment, all of those elements are right below each other. But maybe if you think about an image gallery, maybe you want to have those items next to each other. So that is something that would be pretty likely or totally possible at least. And under those circumstances, you can use a flexbox. A flexbox is essentially there to create one-dimensional layouts. So maybe you want to have all of those items in a row. Maybe you want to have all of those items in a column, but have a couple more options when it comes to arranging those items properly. And that is when you want to use a flexbox. In order to have a flexbox, you always want to have a container like this. And inside of this container, you want to have the items that you want to arrange properly. So you need container and children. That is usually your starting position when you work with a flexbox. And now you say that your container will be a flexbox. And inside of this box, essentially, flexbox, we will have a couple of items, flex items. That's what you call it. So we say for hashtag container, like so, we want to say display is equal to flex, like so. And this will activate the flexbox. And by default, the flex direction is row. So all items by default will get arranged next to each other. Most of the times, that is what you want. But from time to time, you maybe also want to have a flex direction of column. And you can also adjust the flex direction by using the flex minus direction property. And you can have column, column reverse, row, or row reverse. Let's start by taking a look at column. You can see this will just align the items in a column once again. You can have row, of course, which is just the default. You can have row, reverse, and now just take a look once I save at the order of those items. You can see this just reverses the order of the items. And of course, you can have, again, column, but also column minus reverse. Again, take a look at the order. I'm going to save, and the order just changed. But again, most of the times you will just use row. The nice thing about the FlexBox is that you can also control the spacing between the individual items. So I can use the gap property to create a gap between all of those flex items by just writing a single line of code. So I could say 10 pixels, for example, and this will add a gap of 10 pixels between all of the items once I save, as you can see. And this is super nice because now you do not have to define margin for every single element. You can just use one single property to define the gap between all of the items. And this makes aligning them super easy. Now there also exists the possibility that you maybe want to arrange all of those items to the center, or all of those items to the right, or you want to have some space between those items. So let me, for now, delete the gap property like so. And imagine we wanted to have all of those items arranged to the center. To arrange items within the FlexBox, we use justify content. And right now you can justify the content to the center, for example. And you see, this looks like this. We can also use justify content of flex start, for example, like so, or flex minus end, like so. This will arrange the items to the end or the start. Now you can also have space between the items by using space between, for example. And this will add space between the individual items. At the moment you see the left item is arranged to the left and the right item is arranged to the right. So I can also use space around, and this will add space around all of the items. So left and right will also have a little bit of spacing then. So you can use justify content, center, flex start, flex end, space between or space around to create spacing along the primary axis. But what exactly is the primary axis? Because that is something that is really important to understand when working with the FlexBox. At the moment, we have flex direction of row, which is also the default, so I could also leave this away. But right now it's pretty good to have it to understand what justify content does. Because at the moment, we have flex direction row, which means that our primary axis is the row. Justify content aligns our content along the primary axis, which is again the row at the moment. So it aligns our content along the row. If I now change flex direction to column though, you can see that it seems like space around does not work, but the reason for this is that we do not have a height defined yet. So once we say height, 100 viewport height for example, you can see that this here works properly. And now justify content arranges our content along the column because now the column is our primary axis. So justify content always refers to the primary axis, and the primary axis is always the flex direction. So now I could also say center, for example, right here. This will align them to the center. I can use flex start again, flex end again, or space between, of course. So all of this works. But again, most of the time, flex direction is going to be row for you. So this here is a more common use case. But nevertheless, it's really important to understand the difference, because there are of course scenarios where you want to have flex direction of column, and then you still need to be able to use justify content properly. If you want to align your items along the secondary axis is always the other axis, so a flex direction is row, the primary axis is the row, and the secondary axis is the column. If flex direction is column, then the primary axis of course is column, and the secondary axis is row. And to align the items along the secondary axis, you use align minus items. And again, we have properties like center and so on. So let me use center. And this will center our items along the secondary axis, which currently is the column because flex direction is row. So row is the primary axis, column is the secondary axis, and we aligned our items along the secondary axis to the center, so along the column. We can of course also use flex end again, flex start again, and all of those things of course work. So again, to summarize, flex direction to define the primary axis and the flex direction, justify content to align along the primary axis, align items to align along the secondary axis. And that is 99% of what you will ever need. But there exist a couple more properties that you might want to use from time to time, so I'll explain them to you as well. So for now, let's delete this. Now you can also align individual items by using a different property on one of the individual flex items. So use justify content and align items to align all of the elements at once, but maybe from time to time you only want to target a single element. And in order to align a single item, a flex item, you can use align minus self instead of align items, which you would use on a container. So align items for the entire container, align minus self for an individual item. And now I can of course say flex minus n, for example. And you can see this will move this item to the end. For hashtag 2 I could say align minus self of center, like so. And for this one I could say align minus self of flex start, which will not change anything, or of course flex end, like so. Now you might wonder, does there also exist something like justify self? But to be precise, in CSS you can only align the individual items along the secondary axis. So it's not possible to solo align an item along the primary axis. So justify self doesn't work. Let me delete all of them because we do not really need them anymore. And it's also, to be honest, a rare use case. But it's good to know that it is possible, theoretically. Now we can also define the width, for example, of an item by using flex minus grow. So let me show you. I'm going to use flex minus grow of 1. And you can see now hashtag 1 takes up all of the available space. By using flex minus grow, you can say that an item should grow if there is space available. And at the moment you can see if flex grow is 0, so essentially if flex grow is disabled, there is more than enough space to the right that is available, and nothing really uses the space. So I could, for example, say if there is space available, just use the space. And I can do so by using the flex grow property on an individual flex item. And now this item will take up all of the available space if there is space available. I can also use the exact same property on another flex item. And again, I could use the value 1. And now hashtag 1 and hashtag 2 will share the available space, as you can see. And now, of course, I could do the exact same with our flex item number 3, like so. So flex grow 1. And now all of those items will share the available space. And once more space becomes available, you can see all of those items take up the available space. But now I could also increase the flex grow factor for an element. So I could say 4, for example. And you can see now hashtag 1 takes up a little more space than the other elements. I could also say 10, for example. And now hashtag 1 takes up a lot more space than the other elements. If I now give hashtag 2 a flex grow of 20, for example, though, it will grow a lot faster. So the higher the flex grow factor, the more an element is going to grow in relation to the other elements. Now there also exists something that is called flex minus shrink. So let me show you. Let me add flex minus shrink of 1, for example. And in order to demonstrate, let me first of all delete flex grow for all of those items, because we will not need it anymore, like so. And now let's just say that hashtag 2 takes up 200 pixels of width, like so. Maybe hashtag 3 will also take up 100 pixels, like so. And you can see, now hashtag 1 got a little bit smaller. I can also say flex shrink is 0. And you can see our item now stays at a width of 40 pixels. So flex shrink of 0 means that the item is not going to shrink, even if other elements would like to have the space. Flex shrink 1 means that the element can essentially shrink. And now, of course, we could give all of those elements flex minus shrink of 1, for example, like so. And now let's give hashtag 3 a width of 300 pixels, for example. And you can see now the element can shrink if the other element needs that space. So if I give this one 400, you can see the blue one is going to shrink even further. 600, it will shrink even further, and so on. So I think you get the idea. If flex shrink is actually 0, this means you cannot shrink. If flex shrink is 1, it means you can shrink if another element needs the space. Flex grow is pretty similar. If flex grow is 1, it means you can grow if there is space available. And if flex grow is 0, it means you cannot grow even if there is space available. And by default, I think you can imagine, let me just remove all of this. You can see that by default, let me go back to the default values, 50 pixels or 40, I think, and 40 right here. So let's go back to the default values. And I think you can imagine that the default value for flex grow is 0. Because of course, by default, those elements are not growing. So flex grow of 1 is not going to be the default value, but you can set it if you like to. For flex shrink, it's the complete opposite. By default, an element can shrink if he needs to. So that is the default value, but you can set it to 0 if you need to. So flex shrink of 1 is going to be the default, and flex grow of 0 is going to be default. So if those are the values that you like, you don't have to set them explicitly. You only have to set them if you want to have flex grow of 1 or flex shrink of 0. Now, instead of width, you can also use flex minus basis for a flex item. And maybe the flex basis should be 50, for example. And now you could use again flex basis of 200. And let me actually delete flex minus grow, flex minus shrink, like so. So we see how this looks. And now you can see I have a flex basis of 200 pixels right here. So hashtag 2 takes up 200 pixels of space. And for hashtag 3, I will have flex basis of 60 pixels, like so. So flex basis for a flex item is essentially just the width. And there also exists a shortcut for those properties. So you can just use flex, like so, for an individual item. And then you can define flex grow, flex shrink, and flex basis. So we could, for example, say, let's start with a flex basis of 50 pixels, and let's save this. And now let's do the exact same for the other items. So let's just replace flex basis with our flex. And of course, I don't need it for the container. That was my bad. So let me delete it right here. And let me only apply it to our flex items, like so. And you can see now, for every single item, we have flex grow of 1, flex shrink of 1, and a flex basis of 50 pixels. I could also say flex grow of 0 for this one, and now only the other two elements would grow. And you can also just say flex of 1, flex of 1, and flex of 1. That is something that you might see from time to time. This essentially just means flex grow 1, flex shrink 1, and 0% is going to be the starting value. But since flex grow is 1 anyways, the element is just going to grow until it takes up the available space. So oftentimes you can just use flex of 1 to make it a little bit shorter, like so. Hey guys, it's me again, and I actually forgot to introduce you to one important concept regarding CSS FlexBox. And you can imagine that you could have a lot of containers right here. So maybe 1, 2, 3, 4, 5, and so on. So let's create a couple more containers right here. So let's also have 4 and 5 maybe. And I think let's also have 6, for example. We'll have ID 4, ID 5, and ID 6, for example. And now let's target those containers instead of CSS by saying hashtag 4. And now I will just copy those styles over to hashtag 4, like so. And I'll change the color. So let me maybe use a form of green, doesn't matter too much. I'm just going to paste it in here once again for hashtag 5, like so. And now for the color, let's use maybe a form of yellow, like this. And let's also have hashtag 6, like this. And for the color, let's just use maybe something like this. And now you can see that this here already starts to get smaller and smaller. But maybe I want those items to wrap into the next line. So isn't there a possibility to say the FlexBox that we want to allow items to wrap into the new line once there's not enough space available? And in order to do so, you can use the flex minus wrap property. And by default, the flex minus wrap property is set to no wrap, but we can just say that we want to allow wrap by typing out wrap, like so. And you can see now those two boxes just wrap into a new line. And all of those items keep the defined width and height. You can also use rep minus reverse, then you would have a reversed order, and of course the default, which would be no rep, and there's not too much sense in writing out no rep since that is the default, of course. And that is all you really need to know about the CSS FlexBox. Let me now introduce you to the CSS grid. We've already seen the FlexBox, and you usually use the FlexBox if you want to create one-dimensional layouts. So if you either want to align your items horizontally, so in a row, or vertically, so in a column. If you want to align your items in 2 dimensions, you usually use the grid. And a good example would be a photo gallery. So you would have a photo right here, then right here, then right here, and then you go to the next row and you have a couple of photos there, and so on. So that would be a classical use case for a grid. And I'm just going to use a couple of boxes again to show you how this works. First of all, for a grid, we also need a grid container. And inside of the grid container, we will again have the grid items. So that is pretty similar to the FlexBox. So let's start by creating hashtag grid minus container. So a div that has the ID grid minus container. This will be, of course, our container. And inside of this container, we will now have our grid items. So we create another div, and that one could have a class grid minus item, for example. Doesn't matter. Like so. And actually, let's just use an ID right here, and let's give this one an ID of 1. This makes it a little bit easier to target later on, because I want every single grid item to have a different color, so you understand how this looks. Now let me have a couple of grid items in there. Let me have 2, 3, 4, and maybe 5. That should be enough. So 2, 3, 4, and 5, like so. Now let's style all of those elements inside of CSS. First of all, let's have hashtag grid minus container, which will be responsible for creating our grid later on. And now let's start by creating the styles for all of our grid items. So hashtag 1 will have a background of brown, and I'm just going to copy this line and paste it in 4 more times. So 2, 3, 4, and 5. This is going to be 5, 4, 3, 2, and 1. And let me just use slightly different colors. It doesn't matter too much, to be honest. Like so, and like so. So now, of course, we cannot see our individual items because they do not have a width and a height yet. But we can use the grid container to define the width and the height for every single row and every single column. And then our individual items are going to take up the available space by default. You will see how this works in a second, so you don't need to understand this yet. But first of all, we need to say that we want to activate the grid for this entire container. So all of those items will turn into grid items. We can do so by again using display, and instead of using display flex, we just use display grid. And now we created a grid container. As I already mentioned, a grid is 2-dimensional. So let me show it to you. So we have the first dimension that includes all of the rows. So we have a couple of rows. We can define the amount of rows later on, like so. And we can also have a couple of columns. So we could have a column right here, another one right here, then maybe one right here, and so on. And every single square right here could be one grid item. It could be a photo, for example, or it could be one of our boxes, which has a specific background color. So that is up to you. So now, first of all, we should define the number of rows. So right here we have 1, 2, 3, 4, 5, for example, and the number of columns. So right here we would have 1, 2, 3, 4. So let's do this. We can do so by saying grid minus template minus rows to define the amount of rows, and grid minus template minus columns to define the amount of columns. So let's start by defining the amount of rows, like so. And now I can define the height of each row by just using a pixel value. So I could say the first row should have a height of 200 pixels, and the second row should have a height of 400 pixels, like so. And you can see we're already seeing 2 of our elements. Why are we only seeing 2 of our elements? Because we defined 2 rows and we did not define any columns, so by default we only have a single column. Therefore we have enough space for our first 2 elements, so #1 and #2. And if you take a look at the colors, you also see that this is correct. So those are indeed those 2 items. So now we also need a couple of columns. So we can define columns by saying grid minus template minus columns. And it works the exact same way. We can also just define the column width by using pixel values. So maybe 100 pixels, 100 pixels, and maybe 100 pixels. So now we have 2 rows and 3 columns. So 2 times 3, so we can have 6 items in total inside of this grid. And you can see we have enough space for all of our items since we have 5 items in total. And there would also be enough space for 1 more item. Now, of course, it would be cooler if we could just say take up a fraction of the available space. And now I want to have 2 rows and I want those 2 rows to automatically take up the available space. How can I do that? And I can do that by using fractions. So in total, right now, this is the available space right here. And now I can say grid template rows 1fr, 1fr, which means the first row takes up 1 fraction of the available space, and the second row takes up 1 fraction of the available space as well. And that was actually my bad because, of course, rows are the height right here. So this here takes up 1 fraction of the available space, and this here. I'll save this, and this disappears because we don't have a height defined yet for this entire container. So for this entire container, let's say we want to have a height of 60 viewport height. So now the first row takes up 1 fraction of the available space and the second row as well. And we can do the exact same for our columns. So first column should take up 1 fraction of the available space. If I save this, you can say it essentially just takes up all of the available space, whereas the other 2 take up 100 pixels. Now I can also say 1 fraction for the second column, like so, and now they share the available space, whereas the third column still takes up 100 pixels, and the last one can also take up 1 fraction of the available space, and now they essentially just share the space. There's also a shortcut for this, so I can just say, repeat this right here, maybe 3 times for example, and each column should maybe take up 100 pixels, like so, or 200 pixels, like so, or 1 fraction, for example. So all of this works. So repeat essentially just means repeat whatever we have right here for the defined amount of times, in our case 3 times, and this here defines the width of each column in this case. We can do the exact same for our rows, so we could also say repeat, let's maybe say 4 times, and we want to have rows that have a height of maybe 200 pixels, like so. Let me also show you a cool trick for doing responsive layouts, and that is essentially just using repeat together with auto minus fit, like so. And now this will automatically detect essentially how many rows there are needed, for example. So if I would have 6 columns right here, you can see it will automatically detect that we only need a single row. But now we can also do something that is called min-max right here, like so. And we can define a minimal height for each individual row and a maximum height for each individual row. So I could say I want to have a minimum height of 100 pixels and a maximum height for every single row of 300 pixels, like this. And you can see now the row takes up a maximum height of 300 pixels, like so. And that is something that you might want to use pretty often when you do responsive layouts that should work on a mobile phone and on a desktop computer, for example, and tablets, of course, as well. And the same also works for columns, and it is much more common for columns because it's really great for columns for responsive layouts again. So you can just say, repeat, I want to use autofit, and now we can also use min, max, and as a minimum value, we can, for example, say we want to have 100 pixels, but as a maximum value, 250 pixels, like so. And I could also use something like 1000, for example. And now you can see, if I go to a pretty big device, like a normal desktop computer, it takes up a lot of space. On a small device though, it will shrink and it will still take up at least 100 pixels. So that is pretty cool about using repeat together with AutoFit and min-max. You can also create a gap between those items. But first of all, let's say we want to repeat over 2 rows, 1 FR for example. And let's do the same for the column. So we again have a slightly better grid like so, but we want to have 3 columns like so. So that is our look. And now we want to create a gap between those items. We can do so again by just using the gap property. So that is pretty similar to the FlexBox. And now we can have a gap of 10 pixels between those items. And now for the grid, you maybe also want to use row gap or column gap. So maybe you only want to have a gap between the rows or the columns. So instead of gap, you can also say row minus gap of 10 pixels. Now you only have the gap between the rows, or you can use column minus gap. And now you only have the gap between the columns. And now let me also show you how to range the container properly. So imagine our container takes up 100% of the viewport height. So essentially the entire viewport. And the width is 100% of the viewport width. But now imagine our rows and columns have fixed values, like 100 pixels, for example, for every single row, and 100 pixels for every single column. So now can we somehow center this grid inside of the entire container that currently takes up 100% of the available height and 100% of the available width, so essentially the entire screen. And we can do so by using justify content to align the items on the horizontal axis, and this works pretty similar to before. So you can use center, for example, to center the items. So I centered them along the horizontal axis. You can also use different values and you can just test them out yourself. So I could also use something like end, start, and so on. So I think you get the idea. And to align the items vertically, you can again use align, but when using a grid, you don't use align minus items, you use align minus content, like so. And right here, again, you can also use something like center, start, and so on. So let's do center, center, for example. So now our entire grid would be centered. So now let's remove this here once again, and let me show you another example. So imagine every single row takes up one fraction of the available space, and every single column as well. But now it is not necessary that every single grid item takes up all of the available space. It's also possible that a grid item only has a width of 50 pixels and a height of 50 pixels. But now I also want this item to be centered right here. Maybe I don't want this item to be at the left top. So previously we've used justify content and align content to align the entire grid. To align the individual items though, we use justify minus items because of course we are aligning items and not the entire content. So justify items, center, will center the item inside of its grid cell, and align items the exact same. So I see how this works. And now let's also define a width and a height for the other items, because we should do so if we want to have the effect like so, and so, and so. And I think you understand how this works. You could now also align every individual container on its own by using align minus self and justify minus self. So justify minus self to align horizontally, align minus self to align vertically. So justify minus self could be start, for example, for the first one, and this will override the general property right here. And I can also say align minus self of start, for example. So start like this, and this will align this item inside of its container. For now, let's just remove all of this. So all of the width and height properties for the individual items. So they just take up the entire columns and rows again, like so. So let me save this. Let me also remove this right here. And let's also remove justify items and align items, like so. So now we have the same result we had previously, like this. But now I can of course also say that I want this container, for example, so #1, to span over maybe 2 or 3 columns. So that is up to us. And we can do so by saying grid minus column, for example, on the child element, so on the grid item. And now we can define how many columns this item should span, for example. So I could say span 2 like this. So this means just take up 2 columns of width. I can also say span 3, for example. And you can do the exact same for rows by using grid minus row. And now you could also say span 2, for example. So now it spans over 2 rows. And we can also let this automatically decide how many rows we need by just saying auto right here. And now we'll just display all of the items. Instead of just using span, we can also define a starting and an end position. And let me show you how this works by drawing it out for you again. So you gotta visualize it like that. This here is essentially point number 1. This here is point number 2. This is point number 3. And this is point number 4. So every column is essentially 1 point. And of course the same works for the rows. So this here is point number 1 for the rows. This is point number 2 for the rows. This is point number 3 for the rows. And this is point number 4. So that is how you have to think about it right now. And now you can also just say that #1 should start in column number 1 and should maybe go up to point number 3. So 1 from 1 to 2 to 3. So up to this point. So 1, 3, and we get this result. And now I could say for #2, for example, go from point number 3 to point number 4. So I can say grid minus column 3/4 like this. So I get the exact same result. And of course for the row I can do the exact same. So grid minus row. And maybe I want to go from 1 to 2 to 3. So 1/3. And now it spans from 1 to 3. And of course I can do the exact same for item number 3. So maybe I want to go from column 1 to 2 to 3 to 4. So up to the end. So I can do grid minus column 1/4. So now it takes up the entire row. And I know the grid can be a little bit confusing, but I just recommend you to try it out once or twice, and I'm sure you will get the hang of it. Let's now understand pseudo classes in CSS. In order to do so, let's first of all create a button. And inside of this button, we could, for example, have the text click me. Doesn't really matter for now. And now let's just do some basic styling for this button. Let's target the button with an element selector. Let's give it a background of maybe white for now, but let me actually use a slightly darker version of white, like so. Maybe a little bit brighter. I think this is okay. Now I'm going to say for the border, I want to have a border of 0 pixels. So the border is essentially gone. And I want to have padding top bottom of maybe 10 pixels and left right of maybe 25 pixels. So this is just a basic button. Something that you can also do if you want to style a button is use the cursor property. So I can say cursor, and if you then say pointer, so property cursor, value pointer, then your mouse will turn into a cursor once you go over the button. So that is something that is pretty useful if you work with buttons. But now let's take a look at the pseudo classes. What is a pseudo class? Usually you use a pseudo class by using the selector, followed by a colon, followed by the pseudo class. So 1 colon followed by the pseudo class. And one of the pseudo classes that we're going to look at is the hover pseudo class. And this one essentially means target this element once we hover over it and apply the styles that we'll now define inside of those braces to that element. So once we hover over this element, maybe we want to have a slightly different background. So maybe yellow-green. Doesn't need to look good for now, but you will see the difference. So I'm going to hover over this element, and you can see it becomes green. I can also say that the color should be white, for example, like so. And now you can see we have a white text color and a yellow-green background. Now there exist all kinds of pseudo classes. Another pseudo class would be colon active, for example, like so. And now you see when I hover, nothing really happens. But once I click on this element, so once the element is active, we are getting those styles. So hover targets an element once we hover over it, and active targets an element once we click the element. And that's something that you might want to use from time to time for buttons, for example. Now, there also exists the focus pseudo class. Let me show you. Let's first of all delete all of those styles, and let's just create a basic input field of type text, for example, like so. Now, let's target this input field, and let's target it once we focus the input element. And let's say once we focus the input element, we want to have a background of yellow, green, for example, again. What does focus mean? Focus essentially means when we select the input element, apply those styles. And you can see once selected, so once the cursor is inside of this input element, we're having a background of yellow-green. Let me now introduce you to the visited pseudo class. Let's delete this. And in order to do so, let me now add an anchor tag right here. And that one says, go to this site, for example. I'll also add an href attribute that goes to a random baseball site, I guess. I'm going to use target equals underline blank to open it in a new tab. And now I'm going to go to my style sheet. I target an anchor tag that has been visited, essentially, like so. And I say once the site has been visited, I want to have a color of yellow-green, like so. You can see by default, this link right here looks pretty normal. Now I can click on the site. I'm going to go back, and you can see now our link is green. So the text is essentially yellow-green. And the reason for this is because we have now visited this website. So the visited pseudo class will select an element once it has been visited. So once a user has been on the page, for example. Now let's take a look at the checked pseudo class. So let's just delete this right here. And let's add an input of type checkbox, like so. Let's target this input. And let's check whether it has been checked, for example. And when this input is checked, I want to give it a width of 50 pixels and a height of 50 pixels. Now I'm going to check it, and you can see it gets a lot bigger. So the check pseudo class will target an element once it has been checked. Now let's delete this, and let's take a look at a couple more pseudo classes. Let me, for example, have a div, or an unordered list to be precise. And inside of this unordered list, I want to have a couple of li items. This is going to be item 1, 2, and 3, like so. So now I have 3 items, and maybe I only want to target the first list item. So I can do so by saying li colon first minus child, like so. And the first child will have a background of yellow-green. And you can see only the first list item will have a background of yellow-green. Why is that? The reason for this is that colon first child will only target the first child element that is a list. And only this here is the first child element, because this here is the second child and this here is the third child. Therefore, we're only going to target this one. We can also, instead of using colon first child, use colon last child. Now we will target the last one. And we can also use nth child, like so. And right here we can, for example, say inside of brackets 2n, for example, which will target every second child element. So let me duplicate this here a couple more times. And you can see every second element will get targeted. You can also do 3n, like so, 4n, or 1n. So I think you get the idea. I could also use odd for all of the odd elements, or even for all of the even elements. Let me introduce you to pseudo elements, and there exist 2 important pseudo elements, before and after. In order to show them to you, let me first create a paragraph that says hello, for example. And now let me target this paragraph inside of CSS, and now I can use a pseudo element by using colon, so 2 colons. And now, as mentioned, there exists colon after or colon before, for example. So let me show you colon before first of all. When using colon before, you have access to the content property right here, like so. And now, as a string, you can define some content, for example. So I could say, I am saying, for example. I'm going to save this, and you can see we are having I'm saying hello. So colon before add some content before a certain element. So for example, before this p tag. And now you can just style this content the way you would style any other element. So you could give it a background of brown, you could give it a color of white, and so on. So I think you get the idea. And now, as I mentioned, there exists another pseudo element, and that would be : after. It is pretty much the exact same. The only difference is that after, of course, adds something after a certain element. Something that you might want to do from time to time is set display to block, because now it behaves like a block level element. Because you've seen by default, it more or less behaved like an inline element. But that is of course up to you. And under our circumstances, this is probably even what we want. So we could say hello bro, like so. And this here would be totally valid, like so. So : before to add something before an element, : after to add something after an element. Let me now introduce you to box shadow and text shadow. Imagine you have a box, a div for example, and let's give this div a certain width of 50 pixels and a certain height of maybe 50 pixels, as well as a background of brown. So this is our div right now. But now maybe we want to have a slight shadow around this div, so around this box. In order to create a shadow in CSS, you can use the box minus shadow property. And now we have to define a couple of values for box minus shadow. The first value is x offset, the second one is y offset, the third one is the blur, and the last one is the color. Let me show you. We can define the x offset by using an amount of pixels, for example, so 10 pixels, y offset as well, so maybe 10 pixels as well. Let's use for the blur 40 pixels, and for the color, let's use black. And you can see we now have this shadow right here. So let me demonstrate all of those properties in detail. The blur defines how blurry the shadow is, so how soft the shadow is. If I use blur of 0 pixels, you can see that we have a hard shadow right here. Let me also remove the y offset, so I see what the y offset is essentially, like so. And you can see the y offset defines the offset in the y direction, so top and bottom essentially. So I can say minus 10 pixels, for example, 10 pixels, and so on. So this moves the shadow from top to bottom, or from bottom to top. And the x offset does the exact opposite. It moves the shadow from left to right, or from right to left. So that is up to you. So I can say 0 pixels right here. And now we have 0 offset on the x-axis. And I can also say minus 10 pixels or 10 pixels. So I think you get the idea. We can also use RGBA values for the shadow, or for the color to be precise. And that is something that you might want to do pretty often, because then you also have transparency and you can define how strong the shadow should be essentially. So 0.3, for example, is not that strong, whereas 1 is of course a stronger shadow. So let me show you 0.3 and let's use 10 pixels for the blur. So this is how you can create a box shadow. And of course you can also do 0, 0, 10 pixels, and then you just have a soft shadow of 40 pixels. Let me do this one a little bit stronger so you see it. So you have a lot of possibilities when using a box shadow. But how can you actually add a shadow to text? Let me just add a random text, hello bro, for example. And now let me target this paragraph and let me just try to paste over this box minus shadow property. And you can see this looks pretty weird, because by default, of course, you can also represent a paragraph as a box, because everything in HTML gets represented as a box. But under those circumstances, it would be a little bit better if the shadow would only be around the text. And in order to do so, we can use the text minus shadow property, like so. And now the text shadow property also expects 4 values. Again, x offset, y offset, blur, and color. So it's pretty much the exact same. The only difference is that you have text shadow instead of box shadow. So let's use black as a color, blur of 0 for now, y offset of 0 pixels, and let's use x offset of 0 pixels. So right now we're not seeing anything. Let me add some x offset. So now we have some offset on the x-axis. Let me also add y offset. Now we have X and Y offset. Let me add some blur of 10 pixels maybe. Now it's a little bit blurry. And now let me also change the color to yellow, for example. So now we have a yellow shadow. So I think you get the idea. Only difference is that you have text minus shadow instead of box minus shadow. Let's now understand media queries. In order to do so, let me first create a div right here. And let me now target this div inside of CSS and give it a width of maybe 1000 pixels and maybe a height of 400 pixels. I also want to have a background of brown. And once I save this, you can see that we have this box right here. And while this might look kind of right on a big device, it is definitely not looking good on a small device. Let me show you. Let's right-click the page, let's inspect, and once you click this icon right here, you can change to a mobile device. So let me click it, and now you can drag those bars right here and change the device size. And you can also change to an iPhone, for example, to an iPhone XR, to an iPad mini, and so on. So you can see this on all kinds of devices. And maybe this looks kind of right on a big device and you still have a little bit of space to the right, but on a small device or on a small screen size, it looks kind of weird. So isn't there a possibility to adapt or adjust this container or elements in general to the screen size? So it looks good on pretty much every single device. And in fact, there is something like that, and that is called a media query. You can create a media query by using @media. Now you can define the type of media. Usually it is going to be screen. Screen just means this media query will affect screens. So essentially a screen on a tablet, a screen on a phone, a screen in a browser window, so any type of screen. You could also do something like print if you want to write a media query when printing something on paper, for example, but that is something that you usually don't do. So usually you say @media screen. And afterwards, instead of brackets, you can define your rule. This can be something like max minus width, min minus width, and so on. So all of this stuff works. We want to say that we want to have a max minus width. And now let's define 1000 pixels, for example. So as long as our width is less than 1000 pixels, I want to apply something to our div. So now I can target our div inside of this media query, and I can say our width should only be 40 pixels. And maybe our height should also only be 40 pixels. And let me actually change this to 100 so we see it a little bit better. And you can see for a device that has a max width of 1000 pixels, we will get those effects or those styles. Otherwise, we should get those styles. Let me show you. Let me maximize the window, and you can see on a big device, we have the super big box again. But if I'm now going to go to responsive and I'll make this smaller and smaller, at a certain point, we will get the small box right here. So depending on the device size, we get a different result. And we can do the exact same for pretty much any element. So I could also write some text right here. Hello, guys. And now I want to say that usually I want to have a color of black, which is also the default. But otherwise, I want to have a color of yellow-green, for example. And you can see currently we have color yellow-green. But let me resize this and you can see now we have black. So once we reach 1000 pixels, which you can also see right here, once we hit that point, we're going to switch overlay essentially. And you can see once I get below 1000, we're having green and a small box. And now once I hit 1000, we're having a big box and black. So I think you get the idea. By using a media query, you can write rules for your design. And of course, you could also do something like this. Now it would be pretty small above 1000 pixels and below it would get pretty big, which wouldn't make too much sense, but I think you understand how this works. And something like this might seem unnecessary for a lot of you at first, but writing media queries is probably the most important thing out of this course. Today, a lot of people will click your websites on a mobile phone, for example, on a tablet, or on something else. Not all of the traffic will come from your browser. And in the future, it is likely that even more people will visit your websites using a phone. And if a website looks completely ugly on a mobile device, no one will really watch your website. And if people leave your websites instantly, Google will also think that your website is bad and therefore not recommend your website as much. Therefore, having a website that looks good on mobile and desktop is really, really important. And you always want to make sure, by using those media queries, that your website looks good on all kind of devices. Let me now introduce you to transform. In order to do so, let's first of all, as always, create a div. And let's target this div in CSS, give it a width of 50 pixels, or let's say 100 pixels. Let's give it a height of 100 pixels, and let's give it a background of, again, yellow, green, like so. So now we have our div. And now there exists a property that allows us to transform this div. Let me show you. We can use transform right here. And now we can use a lot of different properties or a lot of different functions to be precise. We can use the scale function, for example, which allows us to scale this rectangle. So we could say we want to scale by the factor 1.5, for example. And this will just scale our square. We can also use 0.5, for example, and this will shrink our rectangle. We can also use 2 to double the size, and so on. Now we can stack a lot of different functions right here to transform our square. So we could also use rotate, for example. And right here we could do something like 30 degrees, for example, and this will just rotate our square. We can also use 360, which is a full rotation, so we're not seeing a difference, 45, and so on. So scale scales the rectangle, rotate rotates it. Now we can also use skew, for example, which will just shift it a little bit, maybe 10 degrees. And let me actually delete the other two so we see it a little bit better. You can see we can skew it by 10 degrees, minus 10 degrees, and so on. That is something that you probably won't use that often, at least I've never used it. But in case you want, you can of course also skew it. This here is actually the angle on the x-axis, but you can also skew on the y-axis by using a second value right here. And now this skews on the y-axis. Let me delete this. And now you can also translate it. So move it to the left, right, bottom, whatsoever. So we can use translate x to move it on the y-axis. For example, 50 pixels to the right, minus 50 to the left. So translate x moves on the x-axis. And now we can also use translate y to move on the y-axis. So minus 50, which means to the top, or 50 pixels, which means we move to the bottom. So to summarize, we can use transform together with the function scale, like so, rotate, like so, skew, like so, and translate if we wanted to do that, like so. And it might seem kind of useless at first, but you will see in a second a scenario where this can be really, really useful. So let's just remember it for now. Let me introduce you to transitions. Imagine the scenario previously. We have a button right here, and inside of this button, we have a text, click me, for example. Let me actually make this a little bit bigger for you so you see what is going on. And now I'm going to style this button. So let me give this button a background of maybe white, but I want to have a slightly darker version of white again, like so. I will use a color of maybe black and a border of 0, like this. Now I want to have padding, top bottom, 10 pixels and 30 pixels left right. And this here should be padding, of course. And now we have this button. Maybe I want to have a cursor pointer so I can hover over it and it looks clickable. And a property that you might want to use from time to time as well is going to be the border minus radius property, because that one allows you to create a border radius. And you can define it by using pixels. So 5 pixels, for example. And you see we have slightly rounded borders right now. So I think that looks pretty cool always. And I use it a lot on buttons. But that's not the point of this video. I want to show you how we can create a smooth transition between two states. So imagine we have the button hover state right here, and now we want to have a background of yellow, green, for example. You can see once we hover, we have this background of yellow, green, and maybe also a color of white, as you can see. But the transition is really abrupt, and I want to have a smooth transition. So how can I do it? I can create transitions between two states by using the transition property right here. As the first argument, I have to define the properties I want to apply this transition to. So I could say I want to apply it for our color, for example, like so. Second argument is going to be the transition. This could be 2 seconds, for example, so the transition time to be precise. And the third one is going to be a timing function. This can be something like ease in out, ease out, step end, and so on. Most of the times I just use ease, and essentially the timing function just means how does the animation play? Does the animation start slow and end fast? Does it start slow, become fast, end slow, and so on? And you can just take a look at all of the timing functions by just saying CSS timing functions, for example. And now you go over there and you can see a couple of different examples. So animation timing function linear, for example. Let's play it. And you can say linear just means play the animation at a constant speed. Let's use ease in out. So let's use this one. And you can see it starts slow, gets faster, and slow. Let's take a look at steps. So steps actually just has a couple of steps. So I think you get the idea. And you can just test those functions out if you want to know more about them or just read a little bit about them. But again, usually you can just use ease, for example. Let me save this. Let me hover over this. And you can see our color gets animated slowly. We can also animate our background like so. And you can see our background gets animated. But usually I just do all most of the time, which means just animate all of them. Now I'm going to hover over this and you can see we have a smooth transition. And actually this here is a little bit too much, so I'll use 0.5. And you can see now we have a cool transition when hovering over this button. You can also add a delay, which I barely ever use, but in case you want to do it, you can do it. Maybe 2 seconds. And you can see now after 2 seconds we get a transition. But again, I usually don't use this, so it doesn't matter too much. And again, in case you only want to specify different properties but multiple at a time, you just do it like this. Background 0.5 ease, for example. Color 0.5 ease, for example. So you can just specify one property after another. And now you get this effect essentially. So that is up to you. Let me now introduce you to animations, which is in my opinion one of the coolest things in CSS, because you can literally animate anything. Let me show you. Let's for now just create a div, and let's start by creating a basic animation. Let's style this div by giving it a width of 50 pixels, a height of 50 pixels, and a background of brown, for example. Let's save this one, let's save this one, and now we should have this square right here. And now we can create an animation by first defining it. So first of all, we have to define an animation, and we can do so by using add keyframes, like so. So this here just says we want to create an animation. After that add keyframe statement, we have to define a name for our animation. And this can be pretty much anything. This can just be cool, for example. So now I create an animation that has the name cool. Now you have those opening and closing brackets once again. And inside of this animation definition, you use the from keyword with those brackets. And afterwards, you use a to keyword with those brackets. So you're going from one state to another state, essentially. Right here, you define the first state, so the starting state, and right here, you define the ending state. So I could, for example, say, I want to start with the color brown, for example, and I want to end with the color yellow, for example, like so. So that is possible. So now we already defined an animation that will animate the background. To be precise, the background color from brown to yellow. How can we now apply this animation that we defined right here to this element, to this div? And that one is pretty easy. We can just use animation. In the VS Code, we already get this predefined property essentially. And you can see we have to fill out a lot of stuff right here. So the first thing we have to define right here for the animation property is our name. So we can just say name is going to be cool, because that is our animation name. So right here we want to play the animation cool. Now we can define a duration. How long should it take to go from this state to this state? In our case, maybe 4 seconds. We also have to define a timing function again. Again, we looked at timing functions previously. Oftentimes you can just use is, you can use linear, and so on. So let's try linear, for example. Delay, I don't really want to have a delay, so I'm just going to delete that one. Iteration count, right here you can, for example, define a number, or you could say infinite if you wanted to loop forever. But for now, let's just use 3. For the direction, you can just have normal, for example, which is essentially just forward, or you can say reverse, alternate reverse, and so on. I don't think that this is useful pretty often, because usually if you want an animation to run backwards, why wouldn't you just define it backwards in the first place? But of course, if you have multiple elements and you want to have it go forward for one element and backward for another one, then it might be useful. So you can use reverse right here, or you can just leave it away. That's up to you. I'll just leave it away. And fill mode, you'll see what that one does in a second. But for now, let me just save this, and you can see now our animation is playing. So it's going from brown to yellow essentially, jumps back to brown, goes to yellow, jumps back to brown, and now after 3 iterations, it jumps back to brown and stays there. So we also had fill mode, as already said. And now for the fill mode, you could, for example, say this animation should play forward and therefore stay at the end, so stay at the last frame, by saying forward. And now you can see we're going from brown to yellow, from brown to yellow, and we go one more time from brown to yellow, and then since we're playing forward, we'll stay at the last frame right here. So this time it will be yellow at the end. And the opposite would essentially be backwards. So now it would go from brown to yellow, but the last frame is going to be brown. And I actually barely ever used it. I actually never used it. But in case you want to do it for whatever reason, then you can do it like this. Something that you might want to use pretty often though is infinite for the animation duration, because now this here will loop forever and ever and ever. Let me just use 1 second. And you can see it will just loop forever and it will never stop. This animation here is pretty boring though. So let me show you something cooler. We can also use percentages right here. So you can say 0% to 50%, for example, to 100%. And now I can just say for the background, I want to end at brown in the end, and now it loops and it looks a little bit better already. Now we can also use things like transforms, for example. So we can say transform, we can scale it, we can start with a scale of 1, for example. We can go to a scale of 1.1, and we can go back to a scale of 1 at the end. And you can see, like this, we can create more complex animations. We could also use translate X, for example, 50 pixels. And let's actually use 0 in the beginning. Let's go to 50 pixels. And let's go back to 0 pixels. And of course, I need pixels right here. And now you can see, it looks pretty weird, but you can see that you can do a lot of cool stuff by using those transforms. You could, for example, make the square go top to bottom, left to right, or create all forms of cool animations by doing so. Let me introduce you to variables. Imagine we are having a div right here. And as always, we just want to target our div. We want to give it a width of 50 pixels, a height of maybe 50 pixels as well, and a background of yellow, green. So just our normal div. But now there also exist variables in CSS. And I'll actually just show them to you because it's probably a little bit easier. And afterwards, I'll explain them. We're going to target :root. What is :root? :root is essentially our HTML element right here. So that is the root element. And usually you want to define your variables for the root element, so for our HTML element, because then you can access them instead of your entire document. Like so. Then you use opening and closing brackets, just the normal way. And now you define a variable by using dash dash followed by the variable name. And something that is pretty normal in CSS is, for example, using primary minus color for your primary color. So for the color that you want to use most often inside of your document. And now we can, for example, just use yellow green right here as our primary color, like so. And now for the background, instead of saying yellow green, I can use the var function and can just access -- primary color. And we're still getting the exact same effect, but the difference is, imagine I would use this primary color here 1,000 times. So maybe I also have a paragraph, hello, and now I will use the exact same color for the paragraph color. So I use var primary color. Now this paragraph has the exact same color. Maybe I also have this background somewhere else, this color somewhere else, and so on. So I think you get the idea. Maybe I want to use this color across the entire document. But now if I want to change this color, I would have to go to every single spot and change the color, which is of course pretty annoying and not really time efficient. So I can just use a variable. And now if I want to change the color of this variable for all of the elements where I've used this variable, I can just go to one place, change it to blue, for example. I'm going to save this, and you can see everything else now changes to blue. So a variable essentially allows you to define a value at one single spot and then reuse it across an entire document and change all of the colors with one single click. And that's the power of variables. Again, you define a variable inside the :root element, so inside the HTML element essentially. A variable starts with -- followed by the variable name, and then you can just define the value. You can use the variable by using the var function, and inside of the brackets, you just access the variable name. So it's pretty easy. But variables are not limited to colors. Of course, you can also define a variable for the border width, for example, if you wanted to. And that one could be 10 pixels. Now imagine I want to have a border right here. I'm going to access var of border width right here. Oops, border width. Then I want to have a solid border. And for the color, I want to use var primary color, for example. So now I have this border that has as a color the primary color and as a width the border minus width. So I think you get the idea. Now 10 is maybe too much, so I'll change that to 1. And again, only one single spot where I have to change the value. So this is really efficient. At this point, you know pretty much all you really need to create a cool website. But you've probably realized a couple of weird things. So I want to explain them to you. Let's start by creating a div again. Let me give this div a width of 50 pixels, a height of 50 pixels, and a background of brown. As you can see, we have a lot of space right here to the left and to the top, even though we've never really set a margin, for example. So why is that? And the reason for this is that HTML by default adds a little bit of margin to the body. So let me just inspect this right here. Let's go back to the desktop view. And once you hover over the body and click the body, you can see that the web browser by default adds a margin of 8 pixels right here. And for most websites, that is something that you do not want to have. And to fix this, usually you use the universal selector, which is an asterisk, which just means everything. And you're going to reset margin to 0. This will reset the margin for the entire document to 0. And you can see now this looks clean. The second thing is, you will also oftentimes just set padding to 0 to get a clean starting point. So now everything should have margin 0, padding 0. If I'm now going to create a paragraph as well, that says hello, for example, previously we've seen that a paragraph usually has a little bit of margin top bottom, but that margin is now gone as well. So this here is a lot cleaner and a lot better to work with, because otherwise you would have to look at a lot of elements, would have to reset margins or paddings that the browser adds by default and so on. And that is something that you do not want. So those are things that you always add when you start creating a new website. And something that you also do is add box sizing of border box. So those 3 things will usually be added when you start a new project. But what is box sizing border box? Let me show you. Let me remove this first of all. And let me just add a little bit of padding right here. Let me minimize this window right here. And let me just add padding of 50 pixels or 40 pixels. And you can see this box got a lot bigger. So usually when you don't have box sizing border box, padding always gets added to the content. Even though I defined a width of 50 pixels and a height of 50 pixels, my box is now a lot bigger because it also added padding of 40 pixels to the content. To avoid this, I can use box sizing of border box. And this will fix this problem. This will say 50 pixels width, 50 pixels height, and nothing more than that. And padding now gets added inside essentially. So now this here is probably the content, and this here is padding. And this also gives you a lot more control over how your layout looks, because you never want padding to break your layout. So to sum up, even if you don't understand what this does, even though I think you will, just add this in the beginning when you start a new project and you should be good to go. And this is all you really need to know about CSS. I really hope you enjoyed this course, and if you've understood a lot of this, I recommend you to do a couple of practice projects and then go on and learn JavaScript. It's your favorite NPC, and today I will turn you from a JavaScript beginner to a JavaScript pro. The job market is splitting right now. On one side, developers who understand JavaScript fundamentally, who can read AI code and spot bugs immediately, and who can direct AI to solve real problems. On the other side, developers who just prompt and hope. You know something is shifting. You see developers using AI. You are using AI, but you can feel the gap. You don't understand deeply enough to really control it. You can't evaluate what AI gives you. You're just hoping it works. This course teaches you the JavaScript knowledge to stay competitive in today's world. And here's how we are going to build that understanding. We start with the fundamentals, how JavaScript executes, what variables are, and how types work. Then we cover functions, loops, and if statements. Afterwards, we go over control flow, objects, classes, and how they all connect. Then we understand the browser, so the DOM, events, async, await, and a lot more. By the end, you won't just write code. You will understand the code deeply. Most courses teach syntax. This course teaches you how JavaScript actually works underneath, so you can evaluate any code, whether you wrote it, AI wrote it, or a senior developer wrote it. And if that sounds good to you, then let's get started, guys. JavaScript is a programming language that adds functionality and interactivity to websites. It was created in 1995 by Brendan Eich to solve a key problem, making web pages dynamic instead of static. HTML defines the structure of a website, and CSS controls how it looks. But without JavaScript, everything stays static. JavaScript lets you respond to user actions and control what happens on a page. For example, when a user clicks a button and something happens instantly without reloading the page, that's JavaScript. It can update text, show or hide elements, or load new content in real time. Instead of reloading the entire page, JavaScript can update parts of it instantly, making websites faster and more interactive. It also powers things like animations, forms, APIs, and full applications. Today, JavaScript is used in almost every website. It's not limited to websites either. You can use it to build games, apps, and even run code on servers. You should learn JavaScript because it gives you control over how a website behaves and is essential for building modern, interactive applications. Let's get started by understanding the absolute basics of JavaScript. JavaScript works together with HTML and CSS and allows us to add interactivity to a website. So ideally, you're able to code a little bit in HTML and a little bit in CSS before you learn JavaScript for web development. JavaScript can run in every single browser. Let me show you. We can just right-click any website, even Google, and then press Inspect right here. And this will likely open this tab right here for you. And right now, we are inside of the Elements tab. So now let's click the console right here. And you will use the console a lot when working with JavaScript. And the reason for this is that you can, for example, write JavaScript code inside of the console. Probably the easiest JavaScript statement would be console.log followed by opening and closing brackets. And inside of these brackets, you can use a string. You don't need to understand any of this, but this here is essentially a string, so a text. And right here, you can just write anything you like. So I could have hello guys, like so. Now I can press enter, and this will execute JavaScript code. So now we get inside of the console, hello guys. And of course, the console is the tab where we are currently in. So this here is the console. And this statement essentially just says, inside of the console, output the string hello guys. And again, you don't need to understand this statement yet, but why is it even possible to execute JavaScript code in the browser? And the reason for this is that every single browser, so Google, Firefox, Microsoft Edge, and so on, so all of those browsers have their own JavaScript engine. So an engine that essentially takes your JavaScript code, interprets the JavaScript code, and then executes the JavaScript code. And therefore, it is possible to execute JavaScript code in the browser. So without those engines, it wouldn't be possible. But since every browser has this engine that is able to execute JavaScript code, we can just use JavaScript code right here, for example. So inside of the browser. So inside of this course, I could show you pretty much all of the JavaScript basics inside of this console, but I'm not going to do this because there is a better and cleaner way. And that is a development environment. In our case, we are going to use Visual Studio Code. You can use pretty much anything you like, but Visual Studio Code is pretty common, and if you want to follow this course, I recommend you to install it as well. So let's first of all install it before I further explain it to you. So we're going to enter Visual Studio Code into Google. We're going to press the first link. We're going to press Download for Windows right here. This will start the download, and we're going to wait for this to finish. Once done, we can press the setup. This will open this window. We have to accept the agreement. Then we're going to press Next. Those two checkboxes need to be checked. Then we're going to press Next again. And now we're going to press Install. So essentially, you just follow the setup steps and always press Next. Then we're going to wait for this installation right here to finish. And once done, we can, in a couple of seconds, just press Finish right here. So now we can press Finish, like so, and this should open Visual Studio Code for you. So now this open Visual Studio Code. Alternatively, you can always just go to your search bar and just enter Visual Studio Code, press Visual Studio Code, and this will also open Visual Studio Code for you. Then you will have this welcome screen. And for those of you who already used HTML, you know that you can create a new file by going to the Explorer tab right here. Then, first of all, you have to open a folder. This folder will be your root directory. So essentially the folder where you have your entire project. So all of the files that belong to your project. So we can just press Open Folder. And if you're going to create a new project, you usually also create a new folder because, of course, the project is inside of this folder. So I'm going to go to my desktop. I'm going to right-click my desktop. I'm going to press New, Folder, and now I'm going to give this folder a name. And this can literally be anything you like. But since this is a JavaScript course, I'm probably going to say JavaScript course. I'm going to select this folder, like so. And now this will open Visual Studio Code within this folder, so within our project folder. Everything that belongs to our project should of course be inside of this folder later on. Let me also close this right here so we see a little more. And now, when you work with HTML, CSS, and JavaScript to create your websites, you usually create HTML, CSS, and JavaScript files inside of your root directory. So in our case, inside of JavaScript course, inside of this folder. And for those of you who already know HTML, you can, for example, create an HTML file by using index.html. And the .html extension will say that this here is going to be an HTML file. So this later on tells the browser that this should be interpreted as an HTML file. The same works with the CSS file. So style.css, for example. And again, the .css extension tells the browser that this should be interpreted as a CSS file. And now you can already imagine that you can do the exact same for JavaScript. So you can, for example, use an index.js file. And by using the .js extension, you will later on tell the browser that this here is a JavaScript file and should therefore be interpreted as a JavaScript file. And of course, the name index, and style is up to you. That is just a convention that a lot of programmers use. But you can pretty much, again, use anything you like. So you could also use something like this. And this would work as well. Let me close the Welcome tab. And let me again rename this to index.js, like so. And now you can also write JavaScript code inside of this index.js file right here. So I could also say console.log hello guys, for example. Usually every JavaScript statement ends with a semicolon, like so. And now this here is valid JavaScript code as well. The only difference is that this time we are not writing it inside of the browser, so inside of the console right here, but instead we are writing it within an IDE, so an integrated development environment. And the name is really complex, but an IDE is essentially just a place where you can write your code. And in our case, it's Visual Studio Code. So an IDE gives you auto-completion, gives you some suggestions, shows you when you have an error, and so on. So an IDE just makes your life a little bit easier. So let me show you. When you write console, for example, this here is auto-completion, for example. So now I can just press enter or click console, doesn't matter. And this will automatically auto-complete the statement for me. Now, once I use a dot, and you don't need to understand this yet, but now I get a couple more suggestions. So those are things that I could want to do. And right here, you also see the log suggestion. So now I could also just press this one, and this will automatically use console.log right now. And that's the benefit of an IDE. It just makes your life a little bit easier. Now, to really execute this JavaScript code in the browser though, you have to link it to your HTML file. Because in the end, every website starts with an HTML entry file. You will open this HTML file. This index.html file then loads a couple of styles from a CSS file, and it can also load some logic from a JavaScript file. So to sum up, the HTML file is your entry point, and only the HTML file then, once it's loaded, loads the CSS code and the JavaScript code. So we somehow need to link our JavaScript to our HTML code. In Visual Studio Code, we can create a basic HTML template by using an exclamation mark and then pressing enter, like so. So now we have this basic HTML template. Now there exist three ways to execute JavaScript code, or to include JavaScript code to be precise, inside of HTML. The first one, and the most important one, is just linking an external style sheet. And in order to link an external style sheet, you can just use the script tag in the head in VS Code, and then you use :src, like so, and then you press enter, and this will automatically create the script tag for you. And now, inside of the source attribute, you can define a path to your JavaScript file. In our case, the JavaScript file is inside of the exact same folder, so it's enough to just define a name like so. So index.js, and now we link this JavaScript file to our HTML file. But every time you use the script tag to link a JavaScript file inside of the head right here, so inside of this head tag right here, you also need to use the defer attribute. And the reason for this is that usually HTML gets executed from top to bottom. So first of all, this line gets executed, then this line, then this line, then this line, and so on. So from top to bottom. And usually you first of all want to execute your entire HTML code. So maybe you have an H1 right here that says npc codes, like so. Then you might have a paragraph right below that includes a little bit of text and so on. So I think you get the idea. And only after all of this has been executed, only then you usually want to execute your script. Because the script only adds functionality to the elements on your page. But it would be kind of useless to add functionality to something that hasn't even been loaded yet. Therefore, you first want to load all of the elements, and then you want to include your script tag right here to add the functionality to all of the elements that have been loaded. So something that you did a couple of years ago was to always take the script tag and put it at the end of the body tag. So script::source, and then you would link your index.js file like so. And this here is completely valid. But a modern way to achieve the exact same is to just take the script tag, put it into the head like so, so script source. Then you're going to link your index.js file, and then you use the defer attribute, and the defer attribute essentially says execute the entire HTML code, and only after you've finished executing all of this, only then execute this line of code. So only once everything has been loaded, we're going to include our script, so our JavaScript file. And now everything we write inside of this index.js file will also be executed on our website. So let me show you. Most of you who know a little bit about HTML know that there exist a couple of methods to open an HTML page. So this HTML page right here. The first one is to simply open our folder right here, so our project, and then you can just double click the index.html file, like so. And now this here is our website. At the moment, we are not seeing anything on this website. So let me take a look at the website. And actually, I need to save this. And now, every time I reload, the changes will appear on this page, like so. So now we have this text right here and this paragraph that we included previously on our index.html page right here. But this is not an HTML course. We also want to see that our JavaScript has been successfully included into our project. In order to do so, we have to right-click our page and we have to inspect our page. Now we have to go to the console tab because currently we are saying inside of the console we want to log hello guys. So we are going to go to the console, and if everything worked, then we should see hello guys in the console. And you can see we are seeing hello guys in the console. So this code right here has been executed. I could also say console.log hello again, like so. I'm going to end the statement by using a semicolon. And now let's go back to the page. We need to reload the page. And now we're having hello guys, hello again. So our JavaScript code right here has been executed successfully. So this here is the most common way to include a script, so a JavaScript file, into your HTML code. And that is the way that you should definitely remember. And we will use this throughout the entire course, so we'll definitely remember this. But there exist two more ways to achieve the exact same result. Now let's delete this line right here and let's save this. Let me go back to the browser. I'm going to reload, and you can see once we remove the script tag that links our index.js file to our HTML file, we are not seeing this output on our page anymore. But now there exists another way to use JavaScript code inside of an HTML file, and that is by using the script tag. Usually, you will use the script tag at the bottom for the same reason that I've previously explained. You always want your JavaScript code to execute after all of the HTML code has been parsed. So now I'm going to use the script tag right here. And now we have an opening script tag and a closing script tag, like so. And in between of those tags, so in between opening and closing tag, we can now write JavaScript code. So we could, for example, say console.log hello from the script tag, like so. I'm going to save this. I also add a semicolon. Let me go back to the page. Again, I have to reload the page, like so. And you can see we're getting in the console hello from the script tag. So this seems to work as well. And usually this method is not really that great. And the next method is probably even worse. You can use it if you're just testing or want to get things done very quickly, but it's not the recommended way. The recommended way is to always link an external JavaScript file. But let me show you how inline JavaScript code works. Imagine you have a button, for example, like so, and this one could say, click me bro, like this. And now let me reload the page. So we now have this button. We don't have any output in the console. And now I can say, on click, for example, I want to execute a little bit of JavaScript code. So now I could just add the JavaScript code right here. So I can say console.log, like so. And now I'm just going to use single quotes in order to make this work, because you can't use double quotes instead of double quotes. This will not work properly. You will later on understand why. But for now, just accept this. And now I could just say, hey, for example. I'm going to save this. I will open my page. I'm going to reload this. I'm going to click this button, click me bro. And you can see we're having hey in the console. Every time I click this button now, you can see this number here increases and we add a hey as an output. So the more I click, the more often we're going to output hey. And let's go back to our code. Let me delete this line. And just remember that there exists a couple of ways to include JavaScript code into your HTML, but the method that we are going to use, and the one that you should use as well, is always to use a script tag and define a source attribute that points to your JavaScript file. If you define it in the head, you always want to add the def attribute that tells our browser that JavaScript, so this line right here, should be executed after all of the HTML code has been parsed. And that is how you include JavaScript into your HTML code. Up to this point, you saw that I always had to reload the page right here. And I also had to click the page inside of our folder to open it inside of our browser. Of course, this is a way to do it, but this here is kind of annoying because every time I make a change, I have to reload. And every time I want to open my page, I have to double click it. And in order to fix this, Visual Studio Code, so our IDE, provides extensions. And this here is the Extensions tab. We can go to the Extensions tab and we can search for a lot of different extensions. There exist extensions for JavaScript, for HTML, for CSS, for all kinds of purposes. And of course also for Python, for React, for pretty much all kinds of programming languages. And one that you will use very, very often together with HTML, CSS, and JavaScript is the live server. Because the live server solves exactly the problem that I have been talking about. So we're going to go and press on live server. I already have it installed, but in case you do not have it installed, you're just going to see an install button right here. You will press this install button and wait for the installation to finish. And once you have the live server installed, you can go back to your Explorer tab right here. You can right-click your index.html file like so, and then you can open it with the live server by just pressing open with live server like so. And you can see this here now also opened our page inside of the browser. But now let me go to inspect like so. Let me write a little bit of JavaScript code. So I'm going to go to our index.js file. I'm going to save this. Let's go back. Let's open the console. You can see we're having hello guys, hello again. Let me reload this. So all of this here is gone like so. We're only seeing hello guys, hello again. And now I can just say console.log updated, for example, like this. I'm going to save this. Once I save, you can see our server restarted essentially. And now we're getting hello guys, hello again, and updated. And I did not have to reload the entire page. And the same also works for our HTML code. So if I'm going to write something else right here, so maybe a paragraph, updated, and once I'm going to save this, I can go back to my page and I have updated right here. So no matter what change occurs, once we use the live server will immediately detect the change and will immediately update our website. So whether it's JavaScript code, whether it's CSS, whether it's HTML, that doesn't matter. The live server will always make sure that we're seeing the newest version. And now that we've set everything up, we are ready to really understand CSS. So let's close our style.css because we are not using CSS at the moment. We can actually also close our index.html file because now our JavaScript file is essentially included into our HTML file. So we do not have to touch this here anymore. And now we purely want to focus on JavaScript. So from this point on, let's really understand how JavaScript works. So let me delete this and let's start by taking a look at the first topic. Let's now really understand the basics of JavaScript. And let me first of all get rid of this text right here, because this is probably a little bit distracting and we do not need it for now, like so. Let me close this tab and let's go to our index.js. Let me also minimize this right here. And now this here is the console and this is the website. And every time you want to clear the console, you can just press this clear console icon right here to get a clear overview. You've already seen the probably most basic statement, and that is the console.log statement that essentially allows you to just output something in the console. So this could be text, for example. Every time you have text in JavaScript, you use quotation marks. So you usually write text inside of quotation marks like so. So this could be NPC codes, for example, like this. Every single statement in JavaScript ends with a semicolon, like so. And now I can save this, and you can see we're getting NPC codes in the console right here. So let me clear the console again. You can also use the console.log statement to output numbers, for example. So you could also say console.log, like so. And now I can just enter a number like this. Again, I have to end the line by using a semicolon like this. I'm going to save this, and we're getting NPC codes in the console right here, and we're getting 10 right here. And let me also make the console a little bit bigger for you, so you really see what is going on right here. And now you can see we're having NPC codes and 10 right here. And let me actually also just resize the console for you, so you see it a little bit better, like this probably. You could also use basic addition like this, so 10 plus 10 for example. I'm going to save this, and you can see we're getting 20 in the console right now. But we'll understand more about this when we get to arithmetic operators. So this right here is a line of code. You always have your code right here, and you end the statement by using a semicolon. The code in JavaScript will get executed from top to bottom. So first of all, JavaScript, or the browser to be precise, will execute this line. Once this line has been executed, the browser is going on to this line and will therefore execute this line. And you can see that this happens if you take a look at the console. First of all, we are seeing NPC codes, and only after that we are seeing 20 in the console. Now, there also exist comments in JavaScript. You can write a comment by using a double slash, so slash slash. And now you can write pretty much any text you like. So, hey guys, what's up, for example. Like this. I'm going to save this. And you can see, even though I wrote something right here, nothing really happened. And the reason for this is that comments are only there for you or other developers. So comments really exist to document your code. So maybe you want to explain something to other developers. Maybe you want to add a note for yourself so you remember something later on, and so on. So for all of those reasons, you could use comments. So comments will never get executed. They just exist to add a little note for you or someone else. So that is the purpose of comments. Let's now understand variables in JavaScript. A variable is used to store a value. So what do I mean by that? In order to explain it properly to you, let me just use a console.log statement. And let's just output my channel name, for example. So NPC codes like this. We end this by using a semicolon. I'm going to save this. And you can see we get NPC codes in the console. But isn't there a way to store this value somewhere else, for example, and then just reference the place where we stored this value? And in order to do so, we can use a variable. You can create a variable by using the let keyword. So using let always says that we are going to create a variable. After the let keyword, you always define a variable name. So this one could be channel name, for example. Now for the channel name, I can say that my channel name is equal to NPC codes like this. And now I can use this variable channel name and just replace this text right here with the variable name. So now I'm referencing this variable name right here, and we are getting the exact same result. Now I can change the value right here to NPC, for example. I'm going to save this, and you can see we're now only getting NPC in the console. So what is even the benefit of having a variable? And our programs at the moment are really, really simple. But later on, you might want to use a variable over and over again. And let me create a basic example that doesn't really show the reality, but I think you will get the idea. So maybe I have this variable right here twice. And inside of a real app, I might have this variable and use it somewhere like maybe 10 times, maybe 20 times, maybe 100 times. If I now would have the value right here instead of the variable name, like so, I still get the exact same result. But now imagine I wanted to have NPC codes instead of NPC right here. Now you can imagine I would have to take this value and paste this value in here, in here, in here, and in here. And for a small app like this one, you could argue that it's not that bad, but as apps grow, this gets worse and worse. So it is much smarter to just use a variable, define this value once. Now we can just use this variable name right here and essentially reference our variable. And every time we want to change our variable, we only have to do this change in one single place. So now I could say I want to have NPC codes instead of NPC. I'm going to save this, and you can see it updated every single console.log statement. So this is much more efficient. If you take a look at the naming convention, for variables, this here is the naming convention. So this is called camel case. Let me write this out for you. So this is what you call camel case. And the reason for this is that this is pretty similar to a camel. A camel also starts kind of low, and then you have a peak, a low, a peak, a low. And the same works for naming essentially. So you always start with a lowercase letter, and every new word has an uppercase letter. So channel name of my YouTube channel, really a bad variable name, but that is how you would use this convention to define this variable name. So every new word has a capital letter and the rest is always lowercase. Something that is important for variables in JavaScript and in pretty much any programming language is that variable names should be descriptive. So from time to time you might see developers that will just use something like X, Y, Z, and so on. And technically, of course, this works. So you can also say console.log Z, for example, but it doesn't really make any sense. And later on, if you open this code or another developer opens your code, no one will really understand what you were doing right here. Instead, if I'm giving this variable the name, channel name, for example, like so, everyone will understand, so you and even other developers will understand that this here is going to be the channel name. So this here is much more descriptive. And when writing code and defining variables, you always want to use descriptive names. So to summarize, a variable allows you to store a value inside of the variable. And this is pretty similar to a package in the real world, for example. If you think about a package, you also have this package, and then you can put something into this package, and it is essentially stored there. And later on, when you want to know what is inside of this package, you can always take a look at this package. So a variable is pretty similar. It allows you to store something inside of it. And when defining a variable using let, you always have the possibility to change the variable later on. When defining the variable, so when defining it for the first time, you always have to use the let keyword. When modifying the variable later on though, you can just use the variable name, so channel name, and say this one is equal to NPC, for example, like this. So I could also say channel name is equal to NPC after you've used console.log for the first time. And now you can see for the first line, channel name is NPC codes. Now we are changing our channel name to NPC. So every console.log statement that comes after this change will now use NPC instead. And of course, the reason for this is again that JavaScript code executes from top to bottom. So just remember, You can always modify a variable that you define by using let later on. Something that is important though is that you do not have to assign this value immediately when declaring the variable. So you could also just declare this variable, so let channel name. Now this variable channel name exists. You can already see that now our first one right here is undefined. We will understand what this means later on, but for now, this essentially just means that this variable does not have a value yet. But now I could also say channel name is equal to npc codes, for example, like this. So this here is what you call the variable declaration, and this is what you call the assignment. Because right here, you declare that this variable exists, and right here, you assign the value to this variable. And of course, you can do both of those steps in one single step by using the equal sign right away, like this. So this works as well, and is a lot shorter. So most of the times you will see this. Now you can define a variable by using the let keyword, but you can also define a variable by using the const keyword. And when using the let keyword, this essentially means that you can modify this variable later on. When you use the const keyword, this means the variable is constant. So this variable cannot change its value after the declaration. And a good example is pi, for example. So pi is a constant because pi, of course, is always the exact same and it should never change. So pi is 3.14, and I don't really know more numbers, but that is enough for now. And now I can, for example, console.log pi right here and pi right here. Let me delete all of this because we do not need this anymore, like so. And you can see we're getting 3.14. So this works just the normal way. But if I now want to modify pi and say this here is 4, for example, you can see that we're getting an uncaught type error, assignment to constant variable at index.js84. So at this line essentially. So it is not possible to reassign another value to a constant variable. And a convention for constant variables is that you use capital letters. So everything is essentially capital. So to summarize, a variable is essentially a placeholder for a value that you can later on use to reference this value. You can define a variable by using let or const. When using let, you can modify this variable later on. When you use const, this variable is constant and the value cannot change after the first assignment. And that is all you need to know about variables in JavaScript. Let's now understand all of the primitive data types. Whenever you have a value in JavaScript, under the hood, JavaScript will assign a data type to this value. And knowing those data types is really important. So let's take a look at a couple of them. And the first one we are going to look at is the data type string. A string is essentially just a text. Imagine we wanted to define a first name. So let first name be equal to maybe npc codes, like this. So now we're defining the variable first name, and that one is equal to a string, so essentially a text, npc codes. Every single string is inside of those quotation marks. You don't have to use those quotation marks though. You can also use single quotation marks like so. This here works as well. And you can also use backtick characters, for example. So all kind of quotation marks work, like so. So this here is what you call a string in JavaScript. And the next data type we're going to take a look at is the data type number. And as you can already imagine, a number is just a number. For example, if we have a power level like so, that is likely going to be a number. So that one could be 9,000, for example, like this. When you define a number, you essentially just type out the number. You don't need quotation marks, you don't need anything like that. Just typing out the number is enough. The next important data type is the Boolean. And the Boolean is similar to a light switch. A light switch can be turned on or off, and the Boolean can either be true or false. So imagine we wanted to define whether someone has a big biceps or not. So you can either have a big biceps or you don't have a big biceps. It's as simple as that. And now you could define a variable. Let has big biceps, for example, be equal to, and now possible values would be true, like so, or false, like so. So a Boolean can either be true or false. And if someone has a big biceps, it might make sense to say let has big biceps be equal to true, like so. The next important data type is undefined. And we've already seen undefined. If you define a variable, so maybe the variable age, but don't assign a value to that variable, like so, so you only declare the variable but never assign a value to this variable, then the variable is going to be undefined because there's no value defined yet. And now there also exists the value null essentially. In case you want to say that a variable does not have a value, then it might make sense to say that this variable is equal to null. So I could say let empty value be equal to null. And by explicitly setting this equal to null, we are saying that empty value does not have a value. So the difference to undefined is that a variable that is undefined is just not defined yet, whereas a variable that has the value null should not have a value. So we're explicitly saying this one should not have a value at this point in time. The behavior is pretty similar, as you will see later on, but nevertheless, it's important and good to understand the difference. And those ones were the most important primitive data types that you need to know. Let's now understand the Typeof operator. And the Typeof operator returns the data type of a value. Let me show you. Imagine we're having a first name, for example. And first name is again going to be equal to NPC codes like this. Now I want to find out what the data type of first name is. Of course, right here we know that the data type is string, but oftentimes you will use the Typeof operator when you do not know in advance what the data type is going to be. And now we can use the Typeof operator by using type of first name. And let me just console.log the result of this. So I'm going to console.log the type of first name. I'm going to save this, and you can see we're getting string. Because of course, first name at the moment is a string. Let me also replace this and use a number like 1000. You can see we're getting number as a data type. If I would use something like a Boolean, so true, I would get the data type Boolean. If I'm not going to assign a value at all, I'm getting the data type undefined. And if I'm going to set this equal to null, we are getting an object. And you do not need to understand objects yet. We will get to that later on. And that is all you really need to know about the Typeof operator. So the Typeof operator just allows you to return the data type. Let's take a look at the plus operator. And the plus operator can be used to add numbers or join strings. Let me show you. For now, let me just console.log something. And now I could, for example, have a string that says hello right here. If I'm going to save this, you can see that I'm getting hello in the console. And now I could use the plus operator to concatenate strings, for example. So I could say hello guys, like so. And you can see I'm getting hello guys, but I'm not having a space in between those words. In order to do so, I would have to add a space right here in front of this character, like so. Instead, I could also add a space to the end of this word, like so. And I can do this as often as I like. So I could also say hello plus. Now I could add a space right here inside of another string. And I can use another plus right here. And this would have the exact same result. I could also add an exclamation mark like this. So I can use the plus as often as you like together with strings, and then you can concatenate them using the plus. But you can also use the plus for numbers, and the behavior for numbers is completely different. So if I'm now going to console.log 10 plus 5, for example, we are getting 15 in the console, whereas adding 10 as a string to 5 as a string, for example, would give us 105. Because right here, JavaScript interprets this as a text. And if you add the text 5 to the text 10, you will of course get the text 105. If you add the number 10 to the number 5 though, you will of course get the number 15. So right here, it just concatenates text, whereas right here, it adds one number to the other number. So this here is the mathematical operation, whereas this is text concatenation. So when using the plus operator, it depends whether you're working with text or with numbers. So to summarize, you can use the plus operator to add numbers or join strings. And that's all you need to know about the plus operator. Let's now take a look at arithmetic operators in JavaScript. You use arithmetic operators for math. And you will probably know most of them from basic school math, but some of them might be new to you. So let me introduce you to all of them. Let's start by taking a look at subtraction. Let me just console.log the result of this operation. And for now, let's use 10. For subtraction, we're just going to use the minus symbol. And let me subtract 5 from 10, like so. I'm going to end this by using a semicolon, like this. And you can see, as expected, we're getting 5 in the console. So this here is just a normal minus. You can also use addition. And addition is pretty similar. Again, I'm going to console.log the result of 10 plus 5. And as you can imagine, we're getting 15 in the console. There also exists multiplication in JavaScript, and you can just multiply one number by another number. So 10 times 5, for example, would result in 50. And of course, we also have division like this. And we can divide one number by another. So if I'm going to divide 10 by 5, we should get 2. And indeed, we do get 2. So those ones were the basic ones. But now there also exist a couple more confusing ones. The first one is the remainder. And that one is also not hard, but a couple of you might not know that one. So let's console.log the result of 10 remainder 3, like so. I'm going to end this by using a semicolon. And you can see we're getting 1 in the console. Why are we getting 1 in the console? This here essentially says divide 10 by 3. 10 divided by 3 is 3. But it doesn't really work. We will still have a rest of 1. And the remainder is essentially just the rest. Since the rest is 1 right here, we are having a remainder of 1. I would now use 5, for example. So 10 divided by 5. This works perfectly fine. So we don't have a rest. 10 divided by 5 is 2. Rest 0. So we are going to get 0 in the console, as you can see. If I would use 4, for example, we would have 10 divided by 4, which is 2, rest 2. We're going to get the rest again, so rest 2. And of course, you can also use 6, for example, then you would get rest 4, because 10 divided by 6 is 1, rest 4. So that is how the remainder works. There also exists an exponent in JavaScript. So let me console.log the result of 2 to the power of 2, for example, which is going to be 4. So we are getting 4 in the console right here. I can also raise 2 to the power of 3. So now we're getting 2 times 2 times 2, which is 8. I'm going to save this, and you can see we're getting 8. I can raise 2 to the power of 8, which should be 256. And we're getting 256, like so. Now let me delete all of this, and let's create a number. So imagine we have the number 10, for example. Let me now just console.log our number, like this. And now we could also say that number is equal to our number, so our old number, plus 10, for example. And now we're getting 20 in the console, because we assigned to our variable number the old number plus 10, like so. And of course, we could also say number plus 20. So that is up to you. But there's also a shorter syntax for writing number plus 20, for example. You can achieve the exact same by saying number plus equals 20. And this is essentially equivalent to saying number is equal to number plus 20. So this is just the shortest syntax in JavaScript. And again, we're getting 30. I could also say plus equals 50, and this would be equivalent to saying number is equal to number plus 50. Now we're getting 60, of course, and you can do the exact same with subtraction. So I could also say minus equals 50, and now you would get minus 40. You can also do that for multiplication, like so, and of course also for division, and of course also for the remainder, like so. So you see, all of this here works. Now, from time to time, you maybe only want to increment a number by 1, for example, like this. And this is actually something that happens pretty often in JavaScript. And under those circumstances, you could of course say number plus equals 1. You could also say number is equal to number plus 1, which would just be a little bit longer. So you would definitely prefer to say number plus equals 1. But there is actually an even shorter syntax, and that one would be to just type out plus plus. And saying plus plus in JavaScript just means that you're going to increment this number by 1. And now you could do the exact same once again. So number plus plus, and now we're incrementing once, and we are incrementing twice. So we are getting 12 right here. And the same also works for minus minus to decrement by 1, like so. I'm going to duplicate this twice. And now we're going to increment 10 to 11. And then we're going to decrement 11 to 10, 10 to 9, and 9 to 8. So we should get 8 in the console. And you can see we get 8 in the console. Now let me also show you a basic equation. So let equation be equal to 10 times 6 plus 3, for example. And now let me just show you the result by console.logging our equation. And you can see we are getting 63. So similar to normal math, multiplication comes before addition. The same, of course, also works for division. So division also comes before addition. And of course, division and multiplication also come before subtraction, like so. And let's use plus and multiplication right here. So we're getting 63. But now you can also use brackets, for example. And brackets will always come first. So now we're having 6 plus 3, so 9. And then 9 times 10, so 90. So the order in which operators get executed is pretty much the exact same that you have learned from school. You always have brackets first, then multiplication and division, and last addition and subtraction. So just the normal order you know from school essentially. And those were the most important things you need to know about arithmetic operators in JavaScript. Let's now understand escape characters. And escape characters are used to add special characters to a string. So imagine we are having the string NPC is the best, like so. And you can see inside of the console we are now having NPC is the best. But now maybe I want to have a new line after NPC. In order to do so, I can use a backslash like this, followed by NN. And this here is an example for an escape character. I'm going to save this, and you can see NPC is now in the first line, whereas is the best is in the second line. So an escape character adds a special character. Under those circumstances, it's a new line. I can also use /t to add a tab, so essentially a second spacebar. And now I could do this as often as I like so. And you can see we are adding tab over tab, like so. So you can also stack them right after another. Another example for an escape character would be a backslash, and then you need to use a double backslash. Because of course, the first backslash always says that I want to use an escape character. So for example, new line, a tab, or a backslash. And because a backslash has a special meaning, we also need to escape the backslash. So backslash says that I want to use one backslash, like so. And now the same goes for quotes. So since quotes have a special meaning inside of JavaScript, we cannot just use normal quotes. In order to use quotes, we need to escape them to tell JavaScript that I want to use a quote. So a quotation mark, like so. And now this here will work. But once I'm going to save this, VS Code is actually going to transform this, because you can also use double quotation marks instead of single quotation marks. So this here is valid. And therefore, you technically do not really need an escape character, but this would work. My IDE essentially just says that this here is a better solution, and once I save, it automatically replaces that. But remember, escaping quotes would work as well. So to summarize, an escape character allows you to add special characters, like a new line, a tab, or a backslash, for example. Let's take a look at the most important string functions. And you use string functions to work with text. So imagine we're having a text like channel name once again, which is going to be equal to NPC codes like this. And now maybe I want to know the length of the string, so the length of this text. So how many characters does this text have? And in order to do so, there exists something like a string function. There exist all kinds of string functions, and as mentioned, one is for outputting the length of a certain text. In order to do so, we're going to use the variable name that holds our string, so channel name, and you can always access those string functions by using a dot. So once you use this dot, VS Code will already show you a couple of those string functions. So one is length, and we have a lot of them, as you can see. So replace, repeat, and if you hover over them, you already see within those brackets that repeat or replace, for example, are methods, whereas length right here is a property. Every time you call a property, so something like length, for example, you can just do it like this, so dot length like this. Every time you call a method, so something like replace, for example, so this one, you always have to use opening and closing brackets. You will also understand methods and properties and the difference between them a lot better later on, but for now, all you really need to know is that once you hover over something, you will see whether it's a property or a method. And if it's a property, you can just type it out like this. If it's a method, you always need opening and closing brackets. But let's now take a look at the length property. We can output the length by console.logging that, of course, the way we've done up to this point. And you can see we're getting a length of 9. If I would add a couple more spaces, we're getting a length of 11, and so on. So everything counts as a character, even a space. Let me remove those spaces right here, and now we're getting 9 again, because we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 characters. So, like this, we can get the length. We can also transform a text to uppercase or lowercase. So, uppercase. In order to do so, let's again console.log the result, and let's access channel name. Again, we need to use the dot to access a property or method. And in this case, we want to get the to uppercase method. You can see that it's a method again by taking a look at those brackets right here. And we have method inside of them. So we're going to access the to uppercase method. Again, if we are accessing a method, we need opening and closing brackets like so. We're going to end the statement by using a semicolon. And I'm going to save this. And you can see we're getting NPC codes, but now everything is uppercase. Of course, we can do the exact opposite by using lowercase. So I'm going to console.log channel name dot to lowercase. Again, we have a method, so we need opening and closing brackets, and we end this by using a semicolon, like so. And now we have NPC codes, but this time everything is lowercase. We can also check whether our string, so NPC codes, includes a certain character sequence. So we're going to take a look at includes. Let me console.log whether our channel name dot includes. You can see it's a method right here. So we have to use opening and closing brackets. And right here, VS Code also suggests that inside of those brackets right here, we should enter a search string. And that parameter is of type string. For now, you do not need to understand this really in depth, but just remember that inside of those brackets, we can define what we're searching for. And you will understand why exactly we have to do this a lot better later on. But for now, let's just insert a search string. So what are we searching for? We are searching for a certain character sequence, so maybe for NPC. Let me save this. And you can see we're getting true because, of course, NPC is inside of our original string, NPC codes. I'm now going to search for NPC like this. So with a lowercase c, we're getting false because we're not matching the exact same character sequence anymore. Next up, let's take a look whether a text starts with a certain character sequence. In order to do so, we can again console.log the result of channel name dot, and now we can use the starts with method. Again, it's a method, as we can see right here. I'm going to use opening and closing brackets, and every time you use those opening and closing brackets, you can see that Visual Studio Code already suggests us that we can use a search string, for example. We could also use a position argument, but that's not really important. So for now, let's focus on the search string. What are we searching for? We want to check whether our string starts with NPC, for example, like so. I'm going to save this. We're getting true again. If I'm going to check for n, this is also true. If I would check for p though, this would be false because our string, so our channel name, NPC, does not start with a p. Of course, we can also check whether something ends with a certain character sequence. So I'm going to console.log our channel name again, and I'm going to check whether it ends with a certain character sequence. At the moment, it ends with an S, so let's search for this. I'm going to save this. We're getting true in the console, because of course this is true. If I would insert codes, I would also get true. If I would say pseudo, I'm getting false, because of course NPC codes ends with an S and not with a C. We can also search for a certain index, and that one is a new concept to you, but it's pretty simple. So I'm going to console.log channel name dot index of. It's again a method, so we need those brackets, and now we can search for a certain character or a certain character sequence. Let me, for example, use P like so. That one should be our second letter, so N is the first one, P is the second one. Let me save this, and we're getting 1. Why are we getting 1 even though it's the second character? Because in JavaScript, strings and a lot of stuff start counting at 0. So this here is position 0, this here is position 1, this is position 2, this is position 3, 4, 5, 6, 7, and 8. So instead of starting to count at 1, in JavaScript, you most of the time start to count at 0. And therefore, P has the index 1, because it's 0, 1, like so. If I would enter N, for example, you can see 0 in the console. So index of will essentially just return the index position, so the position of a certain character or character sequence. So I could also say NPC, and we would still get 0, because it outputs the starting position of a certain sequence. If I would enter codes, we would get something like 4. We can also trim a certain string. So imagine I had all of those white spaces right here. And you can see now this moved our text to the right because now we have those white spaces. Let's also add some at the end, like so. Even though you cannot see them right here, if I mark the entire string, you see that we now have white spaces in the beginning and at the end. So can I somehow get rid of those white spaces? In order to do so, I can again use console.log, and now I'm going to use channel name dot trim, like so. Again, this is a method, so I'm going to use that one or execute this one. I'm going to save this. I'll output the result, and you can see now our white spaces are gone. And you might think at first that this trim method is useless, but this here is actually one of the most important methods overall, because that one allows you to, for example, accept user input, for example, when a user registers on your website, and then remove all of the white spaces. For example, if a user goes to your website and enters something like hello@gmail.com, like this, it would be pretty useless to store those white spaces and those white spaces in the database. Therefore, you can then use this trim method and trim this and store the trimmed version in the database, which makes a lot more sense. So this here is something that you really want to do pretty often in the real world. So that is a method that you definitely want to remember. We can also split a string at a certain position. So let me just show you. I'm going to console.log channel name dot split, like so. And now right here I can define a character where we want to split our string. This can be anything. It could be an N, it could be a P, it could also be a white space. So a tab essentially. And that is something that you do pretty often. So I'm going to do it like this. And you can see for every single white space, it created one entry inside of this list. You do not need to understand this. This here is what you call an array in JavaScript. Again, you do not need to understand this, but it's essentially a list that stores everything for you. And every single comma essentially separates one item from another. So at the moment, we have 8 items inside of this array. Why do we have 8 items? Because I still have those white spaces right here. So let me remove them for you. So you really see how this works. I'm going to save this. And we only have 2 items left. Why do we have 2 items? Because we have one white space. So we separate this string from this string because that has been our splitter essentially. So we split this text whenever we have this white space inside of our sequence. And then we take the individual parts of our text and store the parts inside of a list. So inside of an array in JavaScript. And those were the most important string functions in JavaScript for now. So to summarize, you can use those string functions to, for example, get information about a string, to manipulate strings, and to work with them in general. Let's now take a look at template literals. Template literals allow us to insert variables into text. What do I mean by this? Imagine we are having something like first name. And the first name could be equal to NPC once again. And now in the console, maybe I want to output something like hello space plus first name, for example. So that is something that works. So now in the console, we are having hello NPC. And of course, you could also have something like an age. So I could define an age of 116, for example, because I'm probably kind of old already. And now I could say hello plus first name plus comma, for example, you are plus age plus years old, like so. Let me save this. Hello NPC, you are 116 years old, like so. But now, as you can see, this here looks kinda off, to be honest, and it's really confusing as well. So isn't there a better way to insert variables into text, for example? And that is where you can use template literals. So again, I'm going to use console.log, and when using template literals, you always have to use backtick characters. So 2 backtick characters. Besides that, there's not really a difference to a normal string. Instead of normal quotation marks, you just use those backtick characters. And now you can also say hello, followed by a spacebar. And now we can insert our first name variable, for example, by using a $sign and opening and closing curly braces. And instead of those braces, we can now define our variable name. So hello, first name, you are, again, $sign, opening and closing brackets, age, years old, like so. And we're getting the exact same result. The only difference is that this here is a lot more readable. So by using template literals, we can get a much cleaner version when inserting variables into text. Something that is also cool about template literals is that it will also recognize new lines. So if I'm going to do this, for example, you can see that your 116 years old now goes into the new line, like this, for example. So every time you want to use a variable together with text in JavaScript, it might make sense to use template literals. Let's now take a look at math functions. And math functions exist for mathematical calculations. For most math functions, use math dot. And again, you don't need to completely understand how this works, but by using the dot, we can again access properties or methods. And one of the properties, for example, is math.py. Again, you see that this is a property by looking at those brackets. And now I can, for example, console.log math.py, like so. And you can see we're getting the value of pi inside of the console. So by using math.py, we can always access the value of pi whenever we need it. And there exist a lot more math functions and properties. So let me demonstrate a couple of them to you. So let's console.log math.round, like so. And this will allow us to round a number. So maybe I want to round the number 2.5. And you probably know from school that 2.5 will be rounded up to 3, whereas 2.4, for example, will be rounded down to 2. But maybe I always want to round a number up. In order to do so, I can use math.ceil, like so. And this will always round the number up, so to the next higher whole number, so 2.1, for example. And this will be rounded up to 3. There, of course, also exists the opposite, so console.log math.floor, and this will always round a number down to the next whole number, so maybe 2.9, and this will get rounded down to 2. 2.4, of course, as well, and so on. So I think you understand how this works. You can also get the maximum value out of a couple of values by using math.max, and now you can define a couple of values. So we can use 5, 10, 20, like so. And we're getting 20 in the console because that is our maximum value. If this here would be 100, we would of course get 100. There also exists the opposite. So we can use console.log of math.min of 1, 0.4, and 1000, for example. Of course, we're getting 0.4. Let's add -1, and now we would get -1. So math.max will always return the biggest number, whereas math.min will always return the smallest number. We can also get the square root of a certain number by using math.sqrt, which stands for square root. And if you remember, the square root of 16 is 4. So we're getting 4 in the console. We can also raise one number to the power of another number by using math.pow, like so. And inside of the brackets, you can see that we need to define an x value of type number and a y value of type number. So the first one is going to be x, and the second one is going to be y. So let's raise 2 to the power of 4, for example. So 2 times 2 times 2 times 2, which should be 16. And as you can see, we're getting 16 in the console. If we would have 5 here, we would get 32, and so on. We can also get the absolute value of a certain value. So math.abs like this. And now we need to define the number. So the absolute value of 10, for example, is 10. And the absolute value of minus 10 is also 10. So absolute value will only return the value without taking the sign into consideration. So whether it's minus or plus, it doesn't matter. Math.abs will only return the value. We can also generate a random number, and that is actually something that is kind of important, by using math.random like this. And now this will output a random number between 0 and 1. And every time I press Ctrl S to save the file, we're generating a new number, like so. And now I could, for example, combine math.random together with math.round, for example, like so. So now I'm rounding the result of math.random. And I'm getting 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 1. You get the idea, I think. If it's above 0.5, we're getting 1. If it's below 0.5, we're getting 0. And now I'm going to remove this, and let me show you something else that is kind of cool. We can also multiply math.random by 100, and now we're getting a number between 0 and 1. And if the number is close to 1, we're going to be close to 100 because we are multiplying a number close to 1 by 100, which of course is going to be close to 100. And if the number is close to 0, we will still stay close to 0 because 0 times 100 will still be 0. So now we can create a number between 0 and 100 instead of only creating a number between 0 and 1. And that is something that you might want to do pretty often. Now we're getting 87, 39, 21. And now I can, of course, also combine that with math.round, for example. And now I'm getting 47, 44, 90, and so on. And there exist, of course, thousands of math functions, but those ones are the ones that are somewhat important. You don't have to memorize them as well. You can always look them up, and depending on what you're doing later on, you will probably not need any of them. So don't just memorize them, just know that they exist and look them up whenever you need them. Let's now have a simple practice project where we are going to store data for a user, so email, name, and age, for example, instead of variables. And later on, we are going to use the name and the age to welcome the user. So that is a simple practice project, but it helps you to repeat some of the stuff that we've learned up to this point. So let's get started. First of all, to store the email, let's create a variable by using the let keyword, and a good name for the email would of course be email, because it describes what an email is pretty good. Our email could be equal to a certain email, so maybe npc@gmail.com. We're going to end this by using a semicolon. Next up, we want to store the name inside of a variable, so let name be equal to npc codes, for example, like so. And for the last variable, we're going to create the variable age, like so, and maybe I have an age of 99. And now we are going to use those variables to console.log a welcome message to the user. So we are going to say console.log, and now we are going to use backtick characters, and inside of those backtick characters, we're now going to say hello. We have to access our name variable, so we'll use a $sign followed by opening and closing brackets, and inside of those brackets, we're now going to access the name variable. Instead of name for the variable, I'm actually going to use first name though, like so. So I'm going to say hello, npc codes. And now maybe I also want to output the age. So you are age years. old, like this. I'm going to have an exclamation mark right here, and we're going to end the statement by having a semicolon. I'm going to save this, and you can see we're getting hello NPC codes. You're 99 years old. So now we've stored all of the data for a certain user inside of variables, and we use the console.log statement to output that data later on. And even though this is a simple example, you now already know a lot of the stuff in a more minimalistic way that we will later on also use in real apps. Let's now take a look at arrays in JavaScript. And to make it simple, arrays are literally just lists. So I can store all kinds of values inside of an array. So let me show you. Imagine you wanted to store all of the numbers from 0 to 10 inside of a list, for example. You can do so by using an array. So let numbers. You always define an array by just defining a variable the normal way you would do it with any other value as well. So let numbers be equal, and then you define that you want to create an array by using those brackets, so those square brackets. You have opening and closing brackets, and inside of those brackets you then define your values. So maybe all of the numbers from 0 to 10, so 0. You separate each list item by using a comma, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And of course, you also end the statement by using a semicolon. And it's as simple as that to create an array in JavaScript. Now I can also console.log our numbers variable that currently holds our array, like this. And you can see, we see that we have 11 items inside of this array, and we see all of our items, all of our individual array items. I can also expand this array by using this drop-down icon right here, and you can see all of our items are listed right here. And every single item, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, also have corresponding indexes. And if you take a look at this, you also see that the index starts at number 0. So again, in JavaScript, we do not start to count at 1, but instead we start to count at the number 0. So if I want to access an individual item of this array, I could now, for example, use the index of this array, or to be precise, of this item. So if I want to access the first element inside of this array, I have to use numbers of 0. Again, to access an item inside of an array, you use the bracket notation once again. So you start by using the variable name, followed by opening and closing brackets. And inside of those brackets, you now specify the index that you want to access. In our case, we want to access the first element, so 0, that has the index 0. So numbers of 0. I'm going to console.log this, and we're getting 0 in the console. I could also access the item that has index number 4, for example, and we're getting 4. So I think you understand how this works. But arrays are not limited to numbers. We could also store strings, for example, inside of an array. So let fruits, for example, be equal to orange, apple, and banana, like so. And now again, I can console.log my fruits, for example, like this. And now we have an array that consists of fruits, and we can also access those fruits the same way we did before. We have those indices right here once again, so 0, 1, 2. And now if we want to access orange, for example, I could access my fruits of index or at index position 0, and we're getting orange. Fruits of 1 would be apple, and fruits of 2 would be banana, like so. And of course you can also store booleans, so let has high power level be equal to an array, and maybe the first character in our array has a high power level, and the other ones are probably kinda weak, like this. So now we also stored a boolean inside of an array. So you can store pretty much all kinds of data types inside of a boolean. And of course we could also access them once again. So has high power level of 0, for example, and of course this will output true. But now something that is cool about JavaScript is that you're not limited to a certain data type inside of an array. There are a lot of programming languages where you have to stick to only booleans, only strings, only numbers, and so on. So an array can only have one single data type. But in JavaScript, that is different. In JavaScript, you can have a couple of different data types. So I could also say, let whatever be equal to an array. And now the first value is probably a string, so maybe Goku. The second one could be a Boolean, so true. The third one could be a number, so 101. And I could also store a value like null in here, and so on. So I think you get the idea. And now I can console.log our array, whatever, like so. And you can see we have all of those items again stored inside of this array. And of course, I can also access those individual elements by using the bracket notation once again. So 0, 3, 2, and so on. So I think you understand what this is. So to summarize, arrays are essentially just lists that allow you to store all kinds of data types inside of them. Let's now understand nested arrays. And nested arrays are arrays inside of other arrays. So imagine we have a numbers array. So const numbers, for example, is equal to this array. And inside of this array, we can have other arrays right now. So essentially arrays inside of arrays. So the first array could hold the numbers 1, 2, and 3, for example. The second one could be 4, 5, and 6. And the third one could be 7, 8, and 9, for example, like this. So now this here is the outer array, whereas those ones are the individual elements inside of this array. So first element, second element, and third element, like this. And now I can again access those individual elements the way I would do usually. So let me just console.log numbers. And now I want to access my array right here. And let's imagine I want to access the first element, so this array. In order to do so, I'm going to say numbers of 0, because again, we start counting at number 0. So this here has index number 0, this here has index number 1, and this one has index number 2. So to access the first element inside of this array, we're going to use numbers of 0. I'm going to save this, and we're getting our first array, so 1, 2, and 3 right here. And now imagine I wanted to access this element right here, so maybe the number 2. In order to do so, I can again just use an index after this index right here. So I'm just going to use another index, and this one has index position 0, index position 1. So I'm going to access index position 1, like so, and now I'm getting number 2. If I wanted to get 6, for example, I would have to access index position 0, 1. So index position 1 right here. And right inside of this array, it would be 0, 1, 2. So I have to access 1, 2 essentially. And this is a multi-dimensional array. And of course, you could also have arrays inside of arrays inside of arrays. So this here could also be 0.1, 0.2, 0.3, like this. Now I could duplicate this and have 0.4, 0.5, 0.6, 0.9, 0.8, 0.7. Now I could, for example, access number 0, so 0, number 1, for example, like this. And now I will get this array. And now number 1 again, for example, like this. And now we're getting 0.5. So this is a multi-dimensional array. And of course, as always, you can store all kinds of things inside of this array. This here could also be a stuff array, for example, or let's say things, for example. And now we are having numbers, we can also have booleans, we can also have an orange as a string, for example, and maybe an apple as a string. And now, of course, we need to access things of 0, 1, 1, which would be false. And we can also access 0 to 2, for example. So let's do this, which should be apple. We're getting apple, and so on. So I think you get the idea. You can create multi-dimensional arrays by just using arrays instead of arrays. And it's up to you how many arrays you nest inside of other arrays. So to summarize, nested arrays are just arrays instead of other arrays. Let's now take a look at the important array functions. And array functions allow you to manipulate arrays or get more information about a certain array. So let's start by creating a simple array. And maybe we want to create an array that consists of all of our favorite characters, for example. So right here, we might have something like Goku, maybe Jin Woo, Ruffy or Luffy, whatever you call it, and so on. So I think you get the idea. And now maybe I want to get the length of my array. So how many items does this array include? And I can do so by console.logging characters, so my array name, so the name of my variable, dot length. And you can see length is a property again. So we exit it without brackets, like so. I'm going to save this. And you can see we get the number 3 because currently we have 3 items inside of our array. So 1, 2, 3. We are also able to push elements to the end of our array. So essentially to add elements to this array. So maybe we define this array right here. We output the length, but later on we probably decide that we want to add a certain character. In order to do so, we can use our variable name, so characters, dot. And now we can access a certain method to push an element to the end of this array. And that is the push method right here. Again, this here is a method, so we need to use brackets right here. And now we can just define as a string an item that we want to add to the end of our array. And maybe that one is going to be Vegeta, like so. I'm going to end the statement by using a semicolon. I'm going to save this. And now I'm going to console.log my characters array once again. And if you take a look at it, we now have 4 items inside of it. So we have Goku, Jinwoo, Luffy, and Vegeta. Our length, as you can see right here, is also 4. We're outputting the length right here before adding the character to the end. Therefore, length right here is 3. And if I'm going to console.log characters.length right afterwards, it is 4 because now we have 4 items inside of this array. Let me delete all of this. And now we can also add an item to the beginning of an array. In order to do so, we can again use the variable name. And instead of push, we are now going to use unshift, like so. And now again, we have to add our item as a string inside of the brackets. And maybe I want to have the character. I'm not really creative, so I'm just going to use Piccolo. I don't even know if that is written properly, but I think you get the idea. I'm going to save this. I'm again going to console.log my characters array. And now we have Piccolo at position number 0, so index number 0. So we can use unshift to add an item to the beginning. And we can use push to add an item to the end. So this here could again be Vegeta, like so. Now we have this array right here. So Piccolo, Goku, Jinwoo, Luffy, and Vegeta. Now we can also remove an item from the end or an item from the beginning. To remove an item from the beginning, we are just going to use the characters.shift method. So instead of using unshift to add an item to the beginning, we use shift to remove an item from the beginning. Right here, we do not need to specify anything inside of the brackets because we're just removing the first item. So there's not really anything we need to specify. And now you can see Piccolo is gone. So now we only have 4 items inside of this array at this point. To remove an item from the end, we are going to use the pop method. So characters.pop, like so. And this will now remove the last item. In our case, this will be Vegeta. I'm going to save this. And you can see again, we now have 3 items inside of this array. So Goku, Jinwoo, and Luffy. And Piccolo and Vegeta are now gone. So to summarize those methods, unshift adds an item to the beginning of an array. Push adds an item to the end of an array. Shift removes an item from the beginning of an array. And pop removes an item from the end of an array. Now we can get rid of them. And maybe we want to know if our array includes a certain item, for example. In order to do so, we can console.log the result of characters dot includes. Again, this is a method, and this method expects a search element. So what are we looking for? Maybe we are looking for Luffy, like so. I'm going to save this, and we're getting true in the console because obviously our characters array includes the item Luffy. If I would now say this here is Ruffy, for example, we're getting false because Ruffy, of course, isn't Luffy. So I think you get the idea. The includes method just checks whether an array has a certain item or not, and then returns a boolean, so true or false. We can also find the index of a certain item by using the dot index of method right here. Again, opening and closing brackets, and now we need to define a search element once again. Let's use Jinwoo this time, like this, and we're getting 1 because the index position of Jinwoo is 1, so 0, 1. If I'm going to enter Luffy, for example, we would get 2, and if I would enter some random stuff, we would get -1. So -1 pretty much says that this item is not inside of this array, so it doesn't exist. Now, we've previously already seen that you can turn a string, for example, into an array. So if we have the string, for example, let text be equal to hello guys, how are you? Then I can turn this string into an array by saying text dot split, and now I have to define a splitter right here. This could be, again, a space, for example, like this. I'm going to save this. And now let me just console.log the result of text.split, for example, like so. And you can see we're getting an array that includes all of our individual words splitted every time we have a space, essentially. So here, 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 and so on. So I think you get the idea. So by doing so, we can turn a text into an array. But it also works from array to text. So we can also turn this characters array into a text. In order to do so, we can use, again, the variable name characters dot, and now we can use the join method, like so, for example. And as a separator, we are going to use a spacebar, for example, like so. And now we're getting our individual items as plain text separated by a spacebar. Of course, I could also use a comma, spacebar, and now it would look like this. So you can either turn a text into an array, or you can turn an array into a text. We can also reverse the order of an array by using dot reverse, like this. And this will now output this right here. So now we have the reversed order. So instead of Goku, Jinwoo, Luffy, we have Luffy, Jinwoo, Goku. And we can also use the slice method to get a certain part of an array. Right here, you have to define a starting number, an ending number, and that's about it. Maybe we want to only extract Goku and Jinwoo right here. So we're going to start at index number 0, like this. And we want to go up to index number 1, 2. Why am I specifying 2? Because the last index, so the ending index, is excluded. So the starting index is included. This item will be included. This one will be included because this one has index number 1. And this one has index number 2. We're going up to index number 2. Index number 2, so the ending number, will be excluded though. So this item will not be part of the sliced version. And therefore we will only get Goku and Jinwoo, as you can see. If I would say 0 to 1, for example, we would not see Jinwoo because, again, the item that is on the position of the ending index will always be excluded. So that is something that you have to remember. And now let me also show you how to change the value of an item at a certain position. Maybe I want to change Goku to something else. In order to do so, I can use bracket notation like this. So now I'm accessing characters at index position number 0, so Goku, and I can just say that characters of 0 is going to be equal to Goku. Maybe I just have a couple more U's, like this. I'm going to save this. I'm going to console.log our characters right here. And now you can see we have Goku with 3 U's and Jinwoo and Luffy. I could of course also completely change it. So characters of 1 is, for example, equal to Buggy, for example, like this. And now I'm having Goku, Buggy, and Luffy. And those were the most important array functions to manipulate arrays. And again, you don't have to remember all of them. The important thing is that you really understand what an array is and how it works. So to summarize, an array function allows you to manipulate an array or get more information about it. Let me now introduce you to functions. And functions let us reuse code. So we use functions whenever we want to do a certain task multiple times and we don't want to type it out over and over again. So let me show you. Imagine we wanted to greet a dump user, for example. So we could say console.log, hey, NPC, you are dumb for whatever reason. So that might make sense. And now in the console, we are getting, hey, NPC, you are dumb. And now maybe I want to split this into 2 lines. So I'm going to say, hey, NPC, console.log, you are dumb, like so, for example. And now afterwards, maybe I also want to have a console.log statement that says your IQ is below 50. This could be everything I want to output. But now maybe every time NPC, for example, in a real world, accesses a page on our website, I want to say the exact same thing. So I want to greet him essentially. So every time I wanted to do that, I would have to copy those lines and paste them to the position where I want to execute this code, like so. And at a certain point, you can see that this here is not really the best way to write code, because I'm simply copy and pasting this over and over again. And if I now wanted to change the name, for example, so NPC codes right here, I would have to change it over and over again. So at every single position. And not only does this get really repetitive, but this also increases the amount of errors that occur on your page drastically. Because of course, a normal developer, so a normal human, will for example miss to correct an error at a certain position and so on. So this is a terrible way of writing code. And by using functions, we can only define this code here once, and then we can use it over and over again. Let me show you. You define a function by first of all using the function keyword. After the function keyword, we have to define a name for our function. This name can be pretty much anything we like, so we can just make up anything. This could be greet dump user, for example. Again, it might make sense to use descriptive names. And since we want to greet a dump user, this might be pretty descriptive. Again, we are also using camel case right here. So the first letter is lowercase and every new word starts with a capital letter, like so. Now you have those opening and closing brackets right here. Those ones are responsible for parameters, but we'll get to them later on. So they're not that important at the moment. And now you have opening and closing curly braces, like so. And inside of those braces, you essentially define what your function should do. So now let me write something in between those brackets right here. I'm going to copy this code and I'm just going to paste it in here like this. And now this here is our function definition. So function keyword followed by the name definition, followed by those brackets that are responsible for our parameters later on, and the function body. That includes all of the code that we want to execute when calling this function. How can we call a function? We can now call this function by using the function name followed by brackets. Without calling the function, you see, even though I saved this, we're not seeing anything in the console. Because right here, we're only declaring the function. We're not executing the function yet. To execute the function, we call it by again using the function name, so greet dump user. Now I'm going to use opening and closing brackets, and I end the statement by using a semicolon, like so. I'm going to save this, and now you can see in the console, I'm getting, hey, NPC codes, you're dumb, your IQ is below 50. And if I now wanted to do the exact same, once again, for example, I could just copy this line, paste it in, and do the exact same again. And now I only have to use this single line of code to execute this function over and over again, as you can see. And this here is a much cleaner way than before, Because now, if I wanted to go from NPC, for example, so from NPC code to NPC, I can just do it like this, and you can see everything changed at once. So hey NPC, and so on. I could also change the IQ, of course, to below 40, and so on. But at the moment, this is still pretty static. Maybe I also want to have the username or the user dynamically, because maybe I want to use this greet dump user function for a lot of users, because maybe a lot of users are pretty dumb, and not only the NPC. And in order to do so, we can use parameters. And parameters are somewhat similar to variables. There are also placeholders that will get filled once we call the function. Let me show you, because that is probably easier. So right here, I can just define a parameter by typing out the parameter name. And again, the parameter name is up to us. So I can make pretty much anything up. This here would be valid. This here would be valid. But again, it makes sense to use descriptive ones. So I could also say username. And now I can say, hey, plus username. So I can use this here like a normal variable essentially. And I'm going to save this like so. I'm again going to call the greet dump user function. But this time, instead of those brackets, I need to define a specific value for our username. So this could be NPC, for example, like so. And again, we're getting, hey, NPC, you're dumb. Your IQ is below 40. Of course, I can also turn this here into template literals. So hello, username, for example. And this works as well. So this here is pretty similar to a variable. The only difference is pretty much that it's inside of a function. So you define a placeholder, and when executing the function, you essentially fill this placeholder with a specific value, and then you use this value to execute this body right here. And now I could use the exact same function, so greet dump user, but I could greet another dump user. So maybe Jonas is also pretty dumb. And now we're getting hello NPC, you're dumb. Hello Jonas, you're dumb. And I can use this for pretty much anyone I like. But I'm not limited to one single parameter. I could also use multiple parameters of different types. So now at this point we're getting a string. I could also use this as a number though. Let me show you. So let me delete this. And this here works also for a number, for example. So hello 40, you're dumb. So I can use pretty much anything at this point in time. But now we can also accept multiple parameters. So I could also say that I want to get an IQ, for example. And now I'm going to replace this line. And I'm instead going to say, your IQ is at around IQ. So now I'm defining an IQ right here. And now I can also define a second argument right here. So I could say NPC has an IQ of 40 and Jonas has an IQ of 39, like so. And now we're getting hello NPC, your IQ is at around 40. Hello Jonas, your IQ is at around 39. So you can define as many parameters right here as you like. And if you have them right here, you call them parameters. If you have them right here, you call them arguments. And actually, this is just a naming convention. It's not really that important to know the difference. But when you declare it essentially, so right here in the function declaration, you call it a parameter. And when you use the specific value for a parameter, so you assign the value to the parameter, then it's called an argument. So in here, it's an argument. In here, it's a parameter. So it's as simple as that. But that is, in my opinion, not that important. As long as it works, it works. And of course, this here is not limited to greeting a dump user. You could also use this to do math calculations, for example. So I could add numbers, for example. Let's imagine we have num1, num2, and now we just want to console.log num1 plus num2. Also pretty simple example, but probably a little bit more likely than the previous one. And now I can just call add number or add numbers. And I can add two numbers, so maybe 10 and 20, and I'm getting 30. And I can also add 100 to 20, and I'm getting 120. So now I can use the exact same logic, but with different arguments, so different values. and I get a different result depending on the arguments that I'm using. So to summarize, a function just lets us reuse code and therefore reduce redundant code. Let's now understand the return keyword. And return sends a value back from a function. Let me show you what I mean by this. Imagine, again, we have a function that calculates the sum, for example. And maybe the sum of a number 1 and a number 2, like so. And now, up to this point, we always console.log the sum, essentially. So num1 plus num2. And then we would call this function like so, and maybe pass an argument 1 and a second argument to this function. And then we would execute this function. So now we're console.logging 40. But what if we wanted to store this value inside of a variable, for example? So let sum or calculated sum be equal to sum of 10 and 40, for example. And later on, we maybe want to use this calculated sum for something else. Now, if I'm going to do this, this is not really going to work because we're just going to console.log this, but console.logging this will not store the value inside of this calculated sum variable. Let me show you. I'm going to console.log our calculated sum, and you can see we're getting undefined. So we're calling our sum function right here. The sum function will console.log num1 plus num2, so it will output 50 first right here. And afterwards, I'm console.logging calculated sum, so the variable, and the variable is still undefined because right here, we only console.log the number, the sum to be precise, but we were not able to store this number. And in order to do so, we have to use the return keyword because the return keyword sends a value back from a function. So we're sending this value back by using return right here of num1 plus num2. And now we're returning the value of this addition and we're returning it to this calculated sum variable. And now I'm going to console.log the calculated sum. And as you can see, the calculated sum is now 50. So now we were able to successfully store this value, so the sum, inside of our variable. So return essentially just returns a value to whoever calls this function. And this is really useful when storing values inside of a variable, for example. So most of the times, you will use the return keyword and not a console.log statement. A console.log statement is primarily there for testing and debugging your code. But in real applications, you will more often use the return keyword. Let's now understand default values. And default values are used when no argument is passed to a function. Let me show you what I mean by this. Imagine we have the function greetUser, for example. And right here, we're expecting to get a parameter, for example, a username, like this. And now, instead of this function, we're just going to console.log, let's use backtick characters, and let's say, hello, we're going to access our username variable like this, and we're essentially saying hello followed by the username. So we're greeting the user. So let's call this function by using greetUser right here once again. And for now, let me pass NPC. I'm going to save this, and in the console, we're now seeing hello NPC. But what would happen if I would actually not pass an argument at all? So right here, we're essentially expecting to get this as a parameter, but since I'm not passing any value as an argument, we are seeing hello undefined. So isn't there a way to use a default value in case the user, so in case we do not pass an argument right here? And in order to do so, we can just use an equal sign, and then we can assign any value right here. So I could say guest, for example. And now, if I'm going to execute the same function, we're getting hello guest in the console. And of course, if I also have something like you are age years, so age years old, I can also have a default value for age. So first of all, I of course need to accept the age as a parameter. And now I can also assign a default value of 100, for example. I'm going to save this. And at the moment, we're getting, hello guest, you are 100 years old. But of course, I can also define or specifically define a value. So once I say NPC right here, for example, we're getting, instead of hello guest, hello NPC. You're 100 years old. And I can also override the default value for age. So maybe I'm 10 years old. And now I'm getting hello NPC, you're 10 years old. So this is how this works. You can always define a default value. You will use this default value if no argument is specified. But once you specify an argument for the corresponding parameter, you will use the specified argument instead. So to summarize, default values are used when no argument is passed to a function. Let's now have another practice project, and let's try to generate a random quote generator. So first of all, we need to have a way to store all of our quotes somewhere. And in order to do so, I will create an array. So quotes, for example. Instead of this array, I'm going to store all of my quotes. So the first one, I don't really know any quotes. So I'm just going to use something like, this is the first quote, this is the second quote, and let me just add 2 more, like so. And this here is going to be the third quote and the fourth, like so. So now we have 4 quotes. But now we somehow need to be able to access one of those quotes. And it should be random, but for now, let's focus on accessing those quotes. And if you remember, we can access one of those elements by using the bracket syntax. So we could, for example, access quotes of 0, and we would get this element. We could access quotes of 1, and we would get this element. We could access quotes of 2, and we would get this one, and quotes of 3, and we would get this one. So we somehow need to be able to get a random number, ideally, between 0 and the length of our array. So let me for now console.log quotes.length. So this array function essentially calculates or gets us the length of this array. I'm going to save this, and we're getting 4. We need to get a number between 0 and 3. So now I want to get a random number. So let me have a variable let random number be equal to, and if you remember correctly from our math section, you can get a random number by using math.random, like so. Let me for now console.log our random number, and you can see we're getting 0.9. But now I want to have a number between 0 and 3. So if you remember from the previous lectures, if I calculate it or multiply it by 100, we will get a number between 0 and 100. So now I can also just multiply it by the length of our quotes, like so. And now I have to subtract 1 from the length because we want to get a number between 0 and 3, like so. Now let me save this. And you can see for the number, we are now getting 1.5, 0.7, 2.9, 2.6, 1, 2, 2, and I think you get the idea. And now we somehow need to round this. So we can just take all of this right here and use math.round and round whatever we have inside of those brackets. So we're going to round math.random times quote.length minus 1. I'm going to save this. And now let me delete this here. We're getting a number between 0 and 3. So 1, 1, 2, 1, 1, 2, 3, and so on. So I think you get the idea. And now we can use this random number to get a random quote. So we can just access our quotes of random number, for example, like this. And now we are having, this is the third quote, this is the third quote, second quote, third quote, first quote, and so on. So I think you understand how this works. And that is how you can create a random quote generator inside of JavaScript. Let's now understand arrow functions. And arrow functions are just a shorter way to write functions. So imagine we have a function that is responsible for greeting the user. So function greet user. We are getting the username, and inside of the function body, we're just going to console.log hello username, for example, like so. So this would be the normal function syntax. But now, as mentioned, you can do the exact same by using an arrow function, and it's just a shorter way to do the exact same. Usually, you store the arrow function inside of a variable. So, const greet user arrow, for example, for now. And this is going to be the function name. So the variable name will be the function name essentially. And that is going to be equal. And now for an arrow function, you have this syntax right here. So you have the parameters right here. So instead of having them here, you just have them here. So I could have my username right here. Then you have this arrow right here. That's also why you call it arrow function. And then you have the method body. So it's just a different syntax essentially. How it works is pretty much the exact same. And instead of this body right here, I can now also console.log something like hello username, for example. And now I can also call this greet user arrow function the same way I would call a normal function. So I would say greet user arrow like so. And then I would insert my argument right here. So maybe NPC like this. And now I'm getting hello NPC inside of the console. And this would be similar for the normal function. So greet user, maybe NPC codes for greet user. And we're getting hello NPC codes, hello NPC. So an arrow function does pretty much the exact same. The syntax is just a little bit different. And from time to time, this here can be kind of beneficial. So imagine we wanted to have a function that calculates the sum again for num1 and num2. And we just want to return num1 plus num2, like so. Now I'm going to have const num or sum calculated, which is equal to our sum of maybe 10 and 20. If I'm now going to console.log our sum calculated, you can see that we are getting 30 in the console. How could we write the exact same by using an arrow function now? We can do so by saying const sum arrow, for example, is equal to those brackets. We again have a num1 and a num2, and we want to calculate num1 plus num2. If I now only have a single line, the benefit of using an arrow function is that you can also write it into a single line, and you don't even need to use those brackets right here. So you can just write it like this. And when you have a single line like this arrow right here will also automatically return whatever we have to the right. So this here will be returned automatically without having to explicitly write the return keyword. So this is not necessary. Let me show you. I can now have const sum calculated, and instead of using my sum function, I'm going to use my sum arrow function, and we're still getting 30 in the console. So now we're having the exact same result with one single line of code compared to right here 3 lines of code. So this here is just a shorter and more efficient way to write the exact same code essentially, or to be precise, to write the exact same functionality. And this here is just one scenario. You will use arrow functions a lot, especially when we get to callback functions. But for now, just remember, you can use a normal function and you can use an arrow function right here. And that is all you need to know about arrow functions. Let's now understand if statements in JavaScript. And if statements run only if a condition is true. If the condition is not true, they are not going to run. And I think it's easiest to understand when I show it to you. Imagine we have a variable age, for example. And age can be equal to, let's say, 10 for now. Now, we only want to allow a user to enter the page if the age is at least 18. And this already explains how an if statement works. If the age is greater than 18, then we want to allow the user to access the page. Otherwise, we don't want to allow the user to access the page. And this is exactly how it works in JavaScript. If something is true, In our case, if the age is greater than 18, then we do something, and otherwise we do something else. So let me show you. If age greater 18, like so, then do something else, do something else. So that is the structure that we want to recreate in JavaScript. And in JavaScript, you use an if statement by using the if keyword. Then you have brackets, and inside of those brackets, you have a condition. And then again, you have a body. And inside of this body, you define what you want to do. So that is the basic structure in JavaScript. So first off, after the if keyword, we have to define the condition inside of those brackets. And the condition in our case is that the age should be greater or equal to 18. And if that is the case, so if this condition is equal to true, then we want to execute whatever we define within those brackets. And in our case, let's just console.log you can enter, like so. So this has been this block right here. If the age is greater than 18, we're going to let the user in. Else, so now we're going to use the else keyword. Right here, we do not need a condition, because if this condition is false, this here is obviously the only condition left that's possible. So else, we're going to do something else. And we're going to do whatever we define within this body right here. In our case, we're going to console.log you cannot enter kid, like so. And now we're getting you cannot enter kid because our age is currently 10. If the age would now be 18 at least though, you would see you can enter. But now let's add a second condition. For example, the person can only enter if he's at least 18 but below 50, because if he is above 50, he's probably too old. And under those circumstances, we can also say, or we can add an else if condition. So else if the age is, for example, greater than 50, do something else. So when using an if statement, you first of all want to have all of the conditions. If condition 1 is not true, then we're going to check for the second condition. If condition 2 is not true, then we could also add as many else if blocks as we like. So we could check for a third condition, fourth condition, and so on. And if all of those conditions do not meet essentially, then we're going to do whatever we have defined in the else block. So the else block gets executed if all of the conditions we're checking for are false. So let's now add the else if block. So else if we again need to define a condition. Every time we have to define a condition, we use those brackets right here. And now we want to check whether the age is less than 50. So 49 essentially is the maximum. And now we need this block right here again that defines what we want to do if this condition becomes true. And if that is the case, then I want to console.log you cannot enter kid, like so. And at the moment, you can enter 49, you can enter 50, you can enter, which is of course wrong. This here needs to be greater than 50, so that was my bad. Greater or equal to 50 to be precise. And now you can already see a problem of if, else if statements and else statements. So right here, when writing them, you really have to check which condition should become or which condition should be checked first. If you first of all check if the age is greater or equal to 18, this here obviously immediately becomes true. So we are never going to check for the second condition. And that is important to know about if, else statements. Once the first condition is evaluated to true, we will never check for any of the other conditions. And therefore, it makes sense to have the conditions ordered in the right order essentially. So it might make more sense to first of all check if the age is less than 18, like so. If that is the case, then we're not 18 yet, and we want to console.log you cannot enter kid. If this condition is false, then he is at least 18. So let's take a look at this. You cannot enter kid. And if this condition is false, then of course the user is at least 18. So next up, we should check for the next condition that will prevent our user from entering. So we're going to use else if. Now we're going to check if the age is greater than 50, because that is the second condition that prevents our user from entering. And now we're going to check, or we are going to output console.log you cannot enter row, like this. And now we're getting you cannot enter kid because he is still a kid. If I'm going to use 40, we are not getting anything. And if I'm going to use 50 though, let's say 51, because we need to be greater than 50 at this point, we're getting you cannot enter bro. And if this condition is false, so if he is not less than 18 and he's not greater than 50, so he's essentially between 18 and 50, then we can output console.log you can enter, like this. And now let's have a person that has an age of maybe 49. And now he can enter. If he is less than 18 though, or above 50, he cannot enter. So when writing an if statement, the order is always important. And that is something that is really, really important. So to summarize, you always have an if statement that checks for a condition. You can add as many else if statements to check for as many conditions as necessary. And then you can also use an else statement to define something that should happen if none of the if or else if blocks evaluate to true. So this is essentially the fallback if everything is false. And those were the basics about if statements in JavaScript. Let's take a look at comparison operators. And comparison operators compare two values. They are especially important when working with an if statement, for example, or loops, for example, but we will get to loops later on. For now, let's first of all take a look at comparison operators. And in order to do so, let me just console.log the result of 10 greater 5, for example, like so. I'll end this by using a semicolon. And in the console, we're getting true. And this right here is what you call a comparison operator, because it essentially compares two values. It compares the value to the left to the value to the right. And if the value to the left is greater than the value to the right, this will be equal to true. Otherwise, this will be equal to false, as you can see. And there exist a couple of different comparison operators. So let me introduce you to all of them. So the first one is greater than. Now, there also exists greater or equal to. And now, this of course is also true. But if I would check if 10 is greater than 10, for example, this would be false. But if I would check if 10 is greater or equal to 10, this will of course be true because it's equal to 10. Now you can of course do the exact same by using the less than operator. So is 10 less than 20, for example, like so. Of course, this is also true. And I can also check whether 10 is less than or equal to 20. And of course, this is also true. But if I would now check if 20 is less or equal to 20, this would still be true. But if right here I use 20 is less than 20, then I'm getting of course false, because 20 is not less than 20, it's equal to 20. You can also check for equality. Let me show you. So we can check whether 10 is equal to 10. So you use two equal signs to check for equality. One equal sign is the assignment operator. So you use that one to assign a value to a variable, for example. And two equal signs is the comparison operator. So this one compares two values. And if those values are equal, then we're going to get true in the console. And as you can see, we do get true in the console. I can also check whether 10, so the number 10, is equal to the string 10, so to the text 10. I'm going to save this. We are still getting true. Let me now use three equal signs. And now we are getting false. If I would check whether 10 is equal to the number 10 though, I'm going to get true again. And the reason for this is that this here is the equality comparison operator, and this one checks for strict equality. So when using two equal signs, it's only important that the value is the same. And the data type doesn't matter. So it doesn't matter whether this here is a number or a string. 2 equal signs will only check whether the value is the same. Once you use 3 equal signs though, this is the strict equality operator, and this one checks whether values are equal and data types are equal. And right here the value is equal, so 10 and 10, but the data type of number is not equal to the data type of string. Therefore, we are getting false in the console. There also exists not equal. Let me show you. So we can check whether 10 is not equal to 10. Not equal will be expressed by using this exclamation mark followed by an equal sign, like so. I'm going to save this. And you can see we're getting false because 10 is equal to 10. If I'm going to have 11 right here though, we are getting true because now 10 is not equal to 11. So this equals true right now. Again, we can also do something like this, and we can now use a different data type. We're again getting false because 10 is equal to 10 when only using a single equal sign right here. But once we use 2 equal signs, we're again getting true because the number 10 is not equal to the string 10, because now again the data type is different. So the same principle we had before when using 2 equal signs and 3 equal signs. And now you oftentimes, as already mentioned, use those comparison operators inside of if statements, for example. So if, for example, a value, so for example the value 100, is greater than the value 50, then you want to do something. And of course, this is not the best example. Oftentimes you will have a variable like age, for example, and so on, that you will compare to another value, but I think you get the idea. You will use those comparison operators a lot combined with if statements. And that is the most important stuff that you need to know about comparison operators. So to summarize, you use comparison operators to compare two values. And this comparison will then execute to either true or false. Let's now understand logical operators. And logical operators combine multiple conditions. What do I mean by that? Let me show you. In order to do so, let's for example have a variable, and let's say this variable is fast, for example. And that one is going to be equal to true. And that one essentially says whether a person is a fast runner, for example, or a slow runner. And if he is fast, of course, is going to be true. Now we can also have the variable let is strong be equal to true, for example. And now if a person is fast and is strong, is fast is going to be true and is strong is going to be true. If a person is only fast but not strong, then is fast is going to be true and is strong is going to be false. And now I can, for example, use an if statement and check if fast is equal to true, for example. And by using logical operators, I can now combine multiple conditions. So I can check if is fast is equal to true and is strong is equal to false or true, for example. And if those conditions are both true, then we can, for example, console.log you are fast and strong, like so. At the moment, we are not seeing anything because a strong is false. So I'm going to say a strong is true. And now in the console, you can see you are fast and strong. And this here is a logical operator. And in fact, this is the logical AND operator. This combines two conditions. And this here, so this entire expression is only going to be true if condition 1 and condition 2 is true. And of course, we could also use AND once again right here. And now we could also say let is smart be equal to true. And now we could check if is smart, like so, is also equal to true. And if all of those conditions are true, then we are going to consider log you're fast and strong and smart, for example. And if one of those conditions is false, this expression will not be equal to true anymore. So this entire expression will then be false. So by using the logical AND, and let me delete this here, like so. So by using the logical AND operator, you can combine multiple conditions that will only be equal to true if all of the individual conditions are equal to true. So this has to be true and this has to be true. Now, something that you can do in general is just get rid of this equal sign and this equal sign. And now this here is equivalent to saying is fast is true and is strong is true. So if he is fast and he is strong, then he is fast and strong, or we're going to console.log that. And if you take a look at this, if you write your code in a good and clean way, it's pretty much like reading normal English. If is fast and is strong, you are fast and strong. And let's get rid of the and smart, like this. So even a person who can't code would probably understand what this here means. And that is how you really write clean and descriptive code. Nevertheless, there exist a couple more logical operators. Another logical operator would be the OR operator, and you write it like this. So this is the logical OR operator. And now, if a person is fast or a person is strong, we're going to say you're fast or strong, like so. And this is also pretty self-explanatory, I would say, because if a person is either the first condition or the second condition, then this is going to be true. So this entire expression will then be true. If he is not fast and he's not strong, then of course this is going to be false. So if one of those conditions is false, essentially, you're fast or strong is still going to be true, because only one of those things need to be true. He only needs to be fast or strong for this entire expression to be true. If both of those conditions are false though, like so, then he's not fast and he's not strong, and therefore is fast or is strong is false, and we're not seeing anything in the console anymore. So when using the logical AND, both of those conditions need to be true. When using the logical OR, only one of those conditions need to be true for the entire condition to become true. And there also exists the logical NOT operator, and that one can be used by just using an exclamation mark, like so. And now this can be read as if not fast, then we are going to console log you are not fast, for example. And now you're not fast because is fast is false. So by using this exclamation mark, we're saying if this condition right here is false, then this entire condition is going to be equal to true. So this here essentially just inverts the value. So false will become true and true will become false. And those ones were the most important logical operators in JavaScript. So to summarize, you can use logical operators to combine multiple conditions or negate an existing one. Let's now understand switch statements. And switch statements run different code based on different values. They are somewhat similar to if statements, and you can write a lot of if statements using a switch statement. Let me show you. Imagine we're having a day, for example. So let day be equal to Monday, for example. So currently it's Monday. And depending on the day, we, for example, want to output a different message to a user. In order to do so, we can, for example, say if day is equal to Monday, and if that is the case, then I'm going to console.log hey bro, like so. Else if day is equal to Tuesday, for example, then I might have a bad day and I'm going to say you are dumb, bro, like so. So I think you get the idea. And now I can do the exact same for pretty much every single weekday, like this and like this. And now I'm having Monday, Tuesday, Wednesday, Thursday, Friday, and let's keep it like this. So I think you get the idea. And maybe else I'm just going to console.log, whatever, doesn't matter. And now I could have a couple of different sentences here, like you are slow, bro, you are big, you are, or I don't care. I think you get the idea. But writing all of this out is kind of repetitive, to be honest. And under those circumstances, a switch statement might make more sense. When writing a switch statement, you use the switch keyword like so, and inside of those brackets, you then have the expression. In our case, the expression is going to be the day, like so. After those brackets, we are going to have a body once again, and inside of this body, we are going to define all of the cases. And it's really good for something like the day, for example, where you have a lot of different cases. It could also be good for grades, for example, where you also have different grades, for example. So maybe A, B, C, D, E, and so on. So you have a case A, B, C, or under those circumstances, we have a case Monday, Tuesday, Wednesday, Thursday, Friday, and so on. So we define different cases inside of a switch statement. So you always have the case keyword, and afterwards, you define a case. In our case, it's case Monday, for example. And now, afterwards, we're going to have a colon right here. And now we can just say console.log, hey bro, for example. Doesn't matter. And now, let me delete this if statement for now, because we do not really need it. And now we can define all of our cases. So, case Tuesday, I'm going to console.log, it's Tuesday. It doesn't matter, to be honest. Like this. And of course, this here needs to be in quotation marks. Now I'm going to add case Wednesday with a capital W. And I'm going to console.log, it's Wednesday, my dudes. Like so. And I think you get the idea. I can just copy and paste this for all of the other days. So maybe Thursday and Friday. And now it's Thursday and it's Friday. Like so. At the moment, you can see that we're having the day Monday. And we're getting, hey bro, it's Tuesday, Wednesday, Thursday, Friday, and so on. So even though we should stop after Monday, we're getting all of them. And the reason for this is that it's going to check at the first condition, it's going to execute this one, and afterwards, it's just going on to the next condition, so to the next cases. And in order to prevent this from happening, we want to check, and once a condition becomes true, we want to break out of this loop essentially. So we don't want to check anything else after executing this console.log statement. So usually, under most circumstances, you always want to add a break statement after every single condition to break out of this switch statement essentially. Because without this break statement, we're just going to keep executing. But once a condition, or a case to be precise, becomes true, we don't want to keep executing or keep checking for anything else. We just want to break out of this switch statement. And now we're only getting hey bro. If I would have Wednesday though, we would now get it's Wednesday, my dudes. And of course, if we have some random stuff like this, we're not getting anything. And for those circumstances, we can use a default case. The default case will always be executed if nothing else matches the pattern. So please enter something valid, for example. And now we are seeing please enter something valid because we have just a random string. So let's have Tuesday again. And you can see now we're getting it's Tuesday. So to summarize, you always start a switch statement by using a switch. Inside of those brackets, you then have the case that you're checking for, in our case, the day. And within this body, you're defining all of your cases. So you can define a case for every single possible value. So a case for Monday, Tuesday, and so on. Afterwards, after a colon, you define what you want to do under those circumstances. So when this case becomes true, and afterwards, most of the times, you break out of this switch statement. Because most of the times, you only want to execute one single case. And when this case becomes true, you don't want to execute the other cases. In case you want to execute other cases afterwards, you can remove the break statement, and then you will also execute the next one. So if I would have Monday right here, we would execute Monday and Tuesday, because after Tuesday, we are breaking out. So the break keyword is really important most of the times. If none of those cases becomes true, Similar to an else statement, when using if statements, you can also define a default case. And this default case will always be executed if none of the cases is true, essentially. And that is how you can use a switch statement in JavaScript. So a switch statement can often be a good alternative to if-else statements. And again, another alternative would, for example, be a switch statement for grades. So if you have a grade A, B, C, D, you could also use it in a similar way. So switch, grade, and now we could check for grade A, B, C, D, or E, for example. And now we could just say great, good, okay, bad, you are dumb. And now we're getting great because we have an A, we have an E, we are getting you're dumb. And if we have a random letter, please enter something valid. So I think you get the idea. The switch statement is great if you just have a variable that accepts a couple of different values. Let's take a look at the ternary operator. And the ternary operator is just a short if-else statement. So let's take a look at the following example. Again, we have an age, and our age can, for example, be equal to 15. Now we want to check if our age is greater than 18. If that is the case, then we want to console.log you can enter like this. And let's check whether the person is greater or equal to 18. And if he is not greater or equal to 18, then we are going to console.log you cannot enter. And now you can see that we are writing probably 5 lines of code for a pretty simple task. In order to change that, we can also use a ternary operator. We can store the result inside of a variable, so let result be equal. And now we can check whether age is greater than 15. When using ternary operator, you first always have your condition, then you have a question mark like so. And after this question mark, you will define what you want to do if this here is going to be true. So if this expression is going to be equal to true. In our case, we want to return true or store the value true inside of the result variable. Then you usually use a colon. And after this colon, you essentially define what you want to do if this expression here is not equal to true. So if this expression is equal to false. In our case, we want to store the value false in the result variable, like so. And now let me just console.log the result for you. And you can see we're getting false. Because at the moment, age is not greater than 15. And let's say greater or equal to 18, because this makes more sense. So at the moment, we are 15, so we are not older than 18, or at least 18. And therefore, result is false. If I'm now going to say I'm 18 though, we are getting true. So you see, we were able to write this long if statement inside a single line. And that's the power of using a ternary operator. Of course, you can also stack a couple of conditions by using a ternary operator, but this can also get kind of confusing pretty quickly. So for example, if our age is greater or equal to 18, so if that is the case, then we're at least 18. And under those circumstances, we could now also check if our age is less than 50, for example. And right here, we could have another ternary operator. So I could again use a question mark. And I could say, under those circumstances, we are again going to return true. Otherwise, we are going to return false, like so. And we need those brackets for a second statement that VS Code added automatically for me. So now, if the age is greater or equal to 18, and our age is less than 50, so we're essentially between 18 and 50 years old, then we're going to return true. Otherwise, we're going to return false. Of course, I need to console.log the result again, like so. And we're getting true in the console because we are at least 18, but not 50 yet. If I'm going to say I'm 50 though, we're getting false because now we are 18, but we're not less than 50 essentially. So we have an age of 50 already. But as you can see, This here can look, to some people at least, a little bit confusing. And of course, it's also a matter of practice, but at a certain point, it is probably more readable to use if-else statements. But that's of course also personal preference. You can use whatever you like. And this is definitely the shorter way to write it. But again, for some people, probably also the more confusing way. Of course, you could add another ternary operator right here or right here. So that is up to you. But I think you get the point. So to summarize, the ternary operator is just a shorter way to write if-else statements. Let's now create a coin flip game. So we're essentially simulating to flip a coin, so it can either be heads or tails. And then we are going to output whether the result has been heads or tails. So feel free to try this on your own, and then you can take a look at my solution. In order to do so, I personally would first of all start to generate a random number. So let random number be equal. And now to generate a random number between 0 and 1, I'm going to use math.random like so. So let's console.log our random number. Currently we have 0.6, 0.01, 0.98, and so on. But since a coin can either be heads or tails, we should probably convert this random number to either 0 or 1. And then 0 could, for example, represent tails, and 1 could represent heads. In order to do so, I'm just going to use math.round for math.random. Now I'm getting 1, 0, 1, 0, 1, 1, 1, and so on. So I think you get the idea. But now I have to convert this number to an output, so to a text. In order to do so, I could use a ternary operator, I could use a switch statement, I could use an if statement, and so on. So let me show you an if statement, for example. So if random number is equal to 0, for example, I'm going to console.log tails like this. Else, I'm going to console.log heads like so. And now we're getting heads, 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 tails, heads, tails, and so on. So it's as simple as that. Let's also try to do the exact same by using a ternary expression. So maybe random number. If random number is equal to 0, then I want to console.log tails. Otherwise, I want to console.log heads, like so. I'm going to save this. We're getting heads, tails, heads, 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 tails, and so on. So this here works as well. And now we can of course also use a switch statement, even though it wouldn't make too much sense under those circumstances, but we could do so. So switch random number, like so. And now we're going to define a case 0. If that is the case, we're going to console.log tails. We're going to break out. And case 1, we're going to console.log heads. And we're going to break out. And we can also add a default statement, which we will probably not need in this case. But we could say console.log something went wrong, for example. I'm going to save this, and again we're getting tails, heads, heads, and so on. So I think you get the idea. So I could essentially implement this logic by either using a switch statement, by using an if statement, or by using a ternary operator. So I think you already see that you can get the same results by using different methods in JavaScript. And whatever method you use depends on the situation and from time to time also on your personal preference. Let's now take a look at scope in JavaScript. And the scope controls where a variable can be used. Imagine we have a function, for example, output message, like so. And now we could, for example, define a variable inside of this function. So this would be totally possible. So maybe let message be equal to hello guys. And now I can just console.log this message right here. If I'm now going to save this, nothing is going to happen because we also need to call this function. So output message like so. And now we're seeing hello guys in the console. What would happen if I would now try to access this message outside of this function? Let me try this. So console.log, and I'm going to access our message. As you can see, we're getting an uncaught reference error. Message is not defined. And the reason for this is scope, because this message is only available within its scope. So within the scope of this function right here. And that is what you call the local scope, because it's only locally available inside of this function. There also exists the global scope. So I could also define the message variable right here. So let message be equal to hey, like so. I'm going to save this, and you can see we're getting hey in the console. This variable is now defined in the global scope. Everything will have access to this variable. And scope essentially always goes from top to bottom. So let me show you. If I would now take this message and put it in here again, this of course works. And if I'm now going to have an if statement right here, so if 1 equals 1, for example, which of course is always going to be true, if that is the case, then I'm going to console.log the message once again. And you can see we're getting hey twice right now. Once right here, and the other time right here. From a higher level to a lower level, essentially, a variable will always be accessible, but not the other way around. If I would, for example, define this variable within this scope, then it will not be available right here, and we're getting an uncaught reference error. Otherwise, if I'm defining it right here, for example, it will be available. If I'm defining it right here, it will also be available, but it wouldn't be available if I define it right here outside of the scope. So the variable is always bound to its scope. If I define it within this scope right here, then it's everywhere inside of the scope available. If I define it within, for example, so right here, then it's everywhere available. So within the entire document. And if I only define it within the scope of this if statement, so within this scope, then it would only be available within this scope essentially, and it will not be accessible outside of the scope. Even if I would place this one right below. So this doesn't change anything. We're still getting this error for this line. So now let me show you what happens if I'm going to have this variable right here. At the moment, we are seeing hey in the console. But what would happen if I would have another variable called message? So let message be equal to hey guys, like so. So what would now happen? As you can see, once I save, I'm still seeing hey. What would happen if I would define a variable? So let message be equal to hello guys, for example, like so. And you can see we're still seeing hey. So when accessing a variable, for example, when using console.log of this variable, we will always, first of all, take a look within the closest scope. So within the own scope, essentially. So within this scope, if it can then not find this variable, for example, if I delete it, it will go one level higher. So now it will take a look at this scope right here. If it finds it, it will of course use it. Therefore, we are seeing hey guys. If I delete this variable right here as well, then there only exists the global scope. So it will take a look at the global scope. Message is defined right here. Therefore, it's going to use this message and will output the result. And if it cannot find the variable right there in the global scope, we're just getting an error, obviously. So when accessing a variable, we will always look at the closest scope first and then go higher and higher. And that is all you need to know about scope in JavaScript. So the scope essentially controls where a variable can be used. Let's now understand objects in JavaScript. And objects store related data using key value pairs. So how can you imagine an object? Think about the real world. Pretty much anything in the real world can be considered an object. If you have a person, in JavaScript you can consider this person an object. If you have a car, a car can be considered an object. If you have shoes, the shoes can be considered an object. So literally anything can be seen as an object. And usually an object is something where data is related. If you think about a person, for example, you have a lot of properties that are related to this person, for example. So a person has a certain height, a person has a certain amount of money, a person has a certain IQ, a person has a certain name, and so on. So a person has a lot of properties that belong to this person. And therefore, of course, you could go ahead and store all of those properties inside of different variables. But it might make more sense to group all of those properties together to an object. So you store all of those properties that essentially belong together inside of an object. So an object essentially helps you to logically group data that is related, like data that belongs to a person, for example. You can create an object by just creating a variable like so. And now we're going to use an equal sign. And now to define an object, you always use those brackets right here. So this here will tell JavaScript that this is going to be an object. And inside of those brackets, we can now define our key value pairs. A key is something that describes what this property essentially is. This can be something like age. It can be something like height. It can be something like income. So the key is essentially the description of what this property represents. So it could be a height, for example, in centimeters. And then you use a colon, and after the colon, you define a value for this property. And the height could be, for example, 180 centimeters. So I'm going to use the number 180. And now you can define as many key value pairs for this person as you like. So I could have another key value pair for the name, for example. So I could say first name like so. And that one can also be a string. So you're not limited to numbers right here. So the first name could be NPC, for example. I could also have a last name, which could be codes, for example. And now I could also have an income of 0 because I'm still broke. And I could have a variable is smart, that is probably false for me, and so on. So inside of this object, you can store as many key value pairs as you like. And of course, it makes sense to store all of those key value pairs together because all of those key value pairs in the end belong to a person. And you could also use a different name for this variable, so maybe NPC, because this is the variable or the person NPC. But that is up to you, of course. And now let me just console.log NPC, so myself essentially. And you can see we're getting this output right here. We have a first name, NPC, height 180 centimeters, income 0, and so on. So right here, we can see all of those key value pairs. But now, maybe I only want to access the height, or only the first name, or the last name, and so on. And I can do so by using the dot notation in JavaScript. So I can say npc dot, and now I can access the individual properties. And you can see that this is a property. That's what you call a key value pair in JavaScript of an object. If you take a look at those brackets, because right here we are seeing property. So we can access the is smart property, for example. And now we will see false in the console because the NPC is dumb. So is smart is false. You can also output the income like so, or maybe the first name. So that is up to me. An alternative way would be the bracket notation. So I can use brackets right here. And now I can use the height, for example. And I'm getting 180 in the console. I can also access the first name, so NPC, or the last name, for example. And what is the difference between bracket and dot notation? Technically, you can use pretty much both of those notations, but oftentimes, when using JavaScript, you want to dynamically access a certain property. And accessing a property dynamically often means that you want to access this property at runtime. And under those circumstances, when a property, for example, doesn't exist yet on this object, you might want to use bracket notation. But you will understand this later on. At this point in time, it's not really that important. Just remember that you can use the bracket notation to access a property, and you can also use the dot notation to access a property. Now we can also add property names to this object later on. So I could, for example, say that npc.biceps size is equal to 100. I'm now going to console.log our npc, and you can now see that we're getting this result. So now we also have a biceps size of 100. We can of course also add the same property by using the bracket notation, like so. And now we're also having a biceps size of 100. We could also have npc of strength, and this could be equal to 9,000, for example. And now npc has a strength of 9,000. We can also modify properties the exact same way. So I could, for example, say npc of height should be 250 instead. And right now I'm getting the error height is not defined because I need those quotation marks. And now we're getting a height of 250 centimeters. So we can also override existing properties. So you can add properties or override properties. And you can also delete certain properties. So I could also say delete npc of height, for example. So now overriding it might not even make too much because we're immediately deleting it afterwards. And now you can see we don't have the height property anymore. So this is how you can add properties, adjust properties, and delete certain properties of an object. It's me again, and I would like to add something to objects that I forgot to mention previously. So imagine we have an object like npc, for example. So const npc is equal to an object, the username is npc, for example, and the age is, for example, 28, like this. But now an object can also have objects inside of it. So I can also store objects inside of objects, for example. So maybe he has a street, for example, or an address, like so. And inside of this address, as an object, we store, for example, our street. So maybe this is a random street, doesn't matter, like so. And maybe you also have a city, so maybe Munich, and so on. So I think you get the idea. So by just using the property name followed by a colon, and then using the normal object syntax, you can store objects inside of objects. And you can also store arrays inside of objects. So maybe npc has a couple of favorite numbers, for example, and then he can store those numbers inside of an array inside of this object. So maybe 2, 4, 6, and 1 million, for example. And that is how this works. So inside of objects, you can store pretty much anything you like. You can store numbers, strings, booleans, arrays, objects, and so on. And that is all you need to know about objects in JavaScript. Let's now take a look at object functions. And object functions are functions inside objects. So essentially, they belong to an object. If you think about the functions that we created up to this point, they were mostly standalone functions. But if you think about a car in the real world, for example, or a person in the real world, then there exist things that only, for example, cars do, and things that only, for example, a person does. For example, a car can drive, and a person, for example, can eat. So it might make sense to assign those functions to the individual objects. For example, only a person should be able to eat, so it might make sense to assign the eating function to the object person. On the other hand, it might only make sense for a car to drive, therefore it might make sense to assign the driving function to the car object. And for us, let's for example create an object Goku, for example. So of course you can also represent Son Goku as an object, like so. So Goku is an object. He probably has the property power level, like so, and he maybe has a power level of 9,000 for now. So now this here is a property, so a key value pair. This key value pair defines a certain property of an object. In this case, the power level of the object Goku. But now Goku can also do something. So maybe he can punch, maybe he can fight, and so on. So I think you get the idea. And in order to define a property, we use key value pairs. And in order to define functionality of a certain object, like driving, eating, thinking, and so on, we use functions. And when we have those functions inside of objects, we also say that they are methods. So let's create, for example, a method punch, like so. And you can create that method by using the method name, like so, followed by a colon, and then we use the function keyword, like so. And now it's pretty similar to a normal function. We just use opening and closing brackets, and now we use this body right here. So the syntax is just slightly different. Instead of having the function name right here, we define it right here. And now we can, for example, console.log Goku is punching, for example, like this. And now I can access this function by again accessing my object, so Goku. And now by using the dot notation, I can access my property, and I can also access my method, like so. And now when accessing a property, it's enough to just use dot notation followed by the property name. But if you are accessing a function and you want to call this function, you always have to use those brackets. So those brackets always say that we immediately want to execute a function or method. In this case, a method because it belongs to an object. I'm going to end the statement and I'm going to save this. And in the console, we are now getting Goku is punching. Now, an object can have as many functions as it wants. So we could also create a fight function. And this function could now, for example, just console.log Goku is fighting, for example, like so. I'm going to save this. Now I can also call Goku.fight right here. I'm going to save this, and you can see we're getting Goku's punching, and right below, Goku is fighting. Now imagine we wanted to increase the power level. In order to do so, we can create another function, increase power level, for example, like so. This is also going to be equal to a function like this. And now we somehow need to access this property that belongs to this object essentially. And in order to do so, we can use this dot power level plus equals 1000. And again, this here is just equivalent to using power level plus 1000. So this is just the shortest syntax to using this dot power level plus equals 1000. And now you might wonder, what exactly is this? And this is actually pretty simple. A lot of people make this really complicated, but this just points to this object. So this always points to the object inside which you use it. And at this point in time, it might not make too much sense to you, because you might wonder, why do I even have to point to this object if I'm already inside of this object? But you will understand why this becomes necessary later on. But for now, just remember, this points to the current object. So this, in this case, just points to Goku. And if you would now have a second object of Vegeta, for example, like so, inside of this object, this will just point to Vegeta. So if I'm going to use this right here, this points to Vegeta, while this points to Goku, because this is inside of Goku, and this is inside of Vegeta. And that was a lot of this, but I think you get the idea, guys. So that is really important. And now, at this point, we're pointing to the power level inside of this object. So this dot power level points to this power level right here. So to the power level inside of this object. And we're just increasing it by 1000 every time we are going to call the increase power level method. So now I can use Goku dot increase power level like this. And I'm going to console.log the property, so this property right here afterwards, by using console.log Goku.power level like this. Again, we don't need any brackets because we're only accessing a property. And you can see we're getting 10,000. Now I can call this method over and over again like this, and we're getting 14,000 right now. So we are just increasing this power level every time we call this method by 1000. Now let me delete all of this right here, and let me also show the shorter way to writing the exact same. So I can of course do it like this, and a lot of people do it like this, but the shorter syntax would be to just use the method name followed by those brackets. Inside of those brackets, we again have the parameters in case we want to define any parameters. And now I can just use those brackets like this. And inside of those brackets, I again define the functionality. So maybe this dot power level plus equals 1000. And this here is essentially equivalent. So this syntax is equivalent to this syntax. It's just a little bit shorter. And now again, we can call this a couple of times, and we're still getting the exact same result. We're increasing the power level by 1000 every time we call it. So every time we call this method. Now we can of course also accept parameters. So we could, inside of those brackets, for example, just define an enemy, for example. So a parameter enemy that we are expecting. And now we can say Goku's fighting against plus enemy, for example, like this. And now I can just say Goku.fight, and let's say he fights against Vegeta, for example. And now you can see we're getting Goku's fighting against Vegeta. And of course it should have a space right here. And we're getting Goku's fighting against Vegeta. So this is pretty similar to a normal function. And of course we could also use the shorthand syntax for this function. So we can just remove the function keyword right here and save this, and we're getting the exact same result. And of course the same works for this one right here. So the function keyword is essentially not really necessary. You can get the exact same result by using the shorthand syntax. And most people nowadays use this syntax, but a couple still use the old syntax, so I want you to know both forms. And that is all you need to know about object functions. So to summarize, object functions are functions inside of an object, and if you have an object function, you call it a method. So normal functions outside of objects are functions, and functions inside of objects are called method. But the difference is not really that important, it's just a naming convention. You can create a function by using the function keyword, followed by brackets inside which you can define the parameters, followed by the body, in which you define the functionality. And this always points to the current object. So under those circumstances, this, for example, points to the object that is currently calling this method right here, which is, in this case, of course, Goku. And that is all you need to know about object functions. Let's now understand classes. And classes are templates for creating objects. Up to this point, we, for example, were creating Goku, we were creating Vegeta, and so on. So we were creating all of those individual objects. But maybe, in the end, every single person, for example, so Goku, Vegeta, and so on, they're all humans. So you could argue that all of them belong to the class human. So I think you get the idea. In the end, you can always create individual objects, but it might make a little more sense to first of all, create a blueprint for all objects that could belong to this class, and then use this blueprint to create the individual objects. And it might sound a little more confusing than it really is, so let me show you. Imagine we have a lot of different superheroes. We might have Goku, we might have Saitama, we might have Spider-Man, and so on. So all of them are individual objects, all of them are individual superheroes. But you could argue that all of them belong to the class superhero. And in the end, every superhero is pretty similar. Every superhero has a specific name, for example, a specific power level, a specific strength, and so on. So I think you get the idea. And now we can create a blueprint for those superheroes by using a class. So we use the class keyword to create a class, followed by the class name. And for classes, we usually use capital letters. So class superhero, like so. Now, inside of this class, we use opening and closing brackets. And inside of those brackets, so inside of those brackets here, we define the class. Usually, every single class should have a constructor, like so, and like so. And if you take a look at the constructor, it's essentially just a normal function, so a normal method, because the syntax is just similar to a normal method like this. So we have the name, we have opening and closing brackets, and right here we have the method body. But the constructor is somewhat also special, because the constructor will under the hood be automatically called by JavaScript every time we create a specific object from this constructor. So of course, the class is the blueprint, and later on we use the constructor to create from this blueprint our individual objects. So maybe you will call the constructor for creating Vegeta, and then you will call the constructor once again to create Goku, and then you will call the constructor once again to create Spider-Man, and so on. So I think you get the idea. The constructor will be called every time we create an object from our blueprint, so the class blueprint. And usually you use the constructor to initiate every single object later on with different properties. Because every single superhero, for example, has a different superhero name, for example, and a different power level, and so on. And by using the constructor, we can use different superhero names for Goku, Saitama, Spider-Man, and so on, as well as different power levels under those circumstances. And now we're going to say this dot superhero name is equal to superhero name. I will explain what this means in a second, but for now, just stick with me. And this dot power level is equal to power level, like so. And now we can create a new superhero by using a variable. So maybe const Goku is equal to new superhero, like so. And now right here, we can, for example, say the superhero name is Goku and the power level is 9000. Now we can do the exact same for Spider-Man, for example. So Spider-Man is equal to new superhero and his name is Spider-Man and his power level is maybe 5000, like this. And now let me explain all of this to you. So we're just using a variable to store our superhero. And this can literally be anything, but again, a descriptive name might make sense. Since we want to store Goku inside of this variable, we use the variable name Goku. And now we say that Goku is equal to new superhero. By using the new keyword together with the class name, we always say that we're calling the constructor. So this syntax will automatically always call the constructor of this class, in this case of the superhero class. So right here, we're calling this constructor, and this constructor expects us to pass two arguments, since we define two parameters right here, to the constructor. The first parameter is the superhero name, so as an argument, we need to pass a name. The second argument right here is our power level, so to this parameter, we pass the power level. So up to this point, this is just a normal function, so a normal method inside of this class. So up to this point, it's actually as if we would have Goku right here and the power level 9000 right here, because we pass those values as arguments to those parameters. And now, right here, what are we doing right here? Right here, we are creating a new object. So when using the constructor right here, this points to this object right now, because we're calling new superhero for the variable Goku. So this will now point to the object Goku. And now we're saying that this .superhero name, so the superhero name of this object right here, is going to be equal to the superhero name that we passed as parameter, so as argument to this parameter. So actually, we are saying that this .superhero name, so the superhero name of this object, is essentially for Goku equal to Goku, because that is essentially what we're passing right here as a parameter. So this is how you have to think about it. This right here is the specific argument that we pass to the property superhero name later on of this specific object Goku, because this points to Goku. Let me get back to this one, like so. And now we're doing the exact same for power level, of course. We pass this power level right here as an argument to the parameter power level. So it is as if we would have 9000 right here. And now we're saying that this.powerLevel, so the power level again for the object Goku, is equal to 9000, because that is what we have passed as an argument to the constructor right here. And usually you just use the same names for the parameters right here as you use for the properties. But that is just a convention. This here could also be PL and SN, for example. And now, of course, you would have to say this.powerLevel. So the power level of this object Goku, so the property power level of this object Goku is equal to PL. And this.superhero name, so the property superhero name of this object Goku is equal to SN, for example. So this is the exact same. It doesn't really matter. A convention is just that you use the same names for the property as you use for the parameters right here. But that's just a convention. That's also up to you in the end. And now we're doing the exact same. We're creating the variable Spider-Man. Inside of this variable, we're storing a new object, which we say by using the new superhero constructor again. So this creates a new object, stores this object inside of the Spider-Man variable, and from this point on, for this variable, this points to this Spider-Man object. And now we're again saying that this.superhero name, so since we're calling the constructor right here for Spider-Man now, we're saying that this.superhero name for Spider-Man, so for the variable Spider-Man, is equal to superhero name. We pass the superhero name Spider-Man again to our constructor, so now it looks like this, and assign it to the property superhero name. And the exact same, of course, for the power level. So when calling the constructor right here, we are passing those values as arguments, and when calling the constructor right here, we pass those values as arguments to the constructor in the end. Let me get back right here. And I think you get the idea. If I now want to create 10 objects, for example, maybe I also have Saitama. His name is Saitama, and his power level is maybe 10,000, like so. I can use the exact same constructor. I just pass different values, so different arguments to this constructor, and by passing different arguments, the properties of this object in the end, so the properties, superhero name, and power level, will just have different values for Saitama than for Goku or Spider-Man, for example. So I think you get the idea. You call the constructor over and over again every time you use the new keyword together with the class name. And for every single constructor call, you will create a new object, and every new object has this pointing to the specific object. So for Goku, when using the constructor, this points to Goku. When creating Spider-Man using the constructor, this points to the variable Spider-Man. And when creating Saitama as an object, this points to the object Saitama. And now you could, of course, also create a method right here. So maybe print name, for example, like so. And now you could just console.log this.superhero name, for example. And now for Goku, this points to Goku. So this.superhero name is Goku right here. For Spider-Man, this.superhero name is Spider-Man. And for Saitama, this.superhero name is Saitama. So if I'm now going to say Goku.superhero name, and I'm going to call this method right here, and actually this needs to be print name, so that was my bad, because of course superhero name is a property, like so. We're getting Goku. If I'm going to call Spider-Man.print name, we're going to get Spider-Man. And if I'm going to call Saitama.print name, we're getting Saitama. And the reason for this is, of course, that for Goku, this again points to Goku. So to the superhero name Goku. For Spider-Man, it points to the superhero name Spider-Man. And for Saitama, this.superhero name points to the superhero name Saitama. So this always refers to the object that has been created using the new superhero constructor under those circumstances. And I know I explained this really a lot, but I really want to make sure that everyone understands this, because this can be confusing to a lot of beginners. But it's actually really, really simple. This always points to the object that has been created by using the constructor for this individual object, which you store inside of a variable, of course. Welcome to this mini project where we want to create a user profile system together. In this project, the user should have a username, he should have an age, he should maybe have a specific country, and he should have an Is logged in status that should be false by default. Later on, we will provide a function that logs the user in and a function that logs the user out, as well as a function that provides information about the user. And of course, I mean method, because all of this will be inside of an object. So to summarize, I want you to create a user class that essentially initializes the user by giving him a username, an age, a country, as well as a login status that should be false by default, and then provides methods to log in, log out, and provide information about the user. And logging the user in essentially just means that the Is logged in status should be true, whereas logging him out should set the login status to false. So you can try this on your own, and afterwards you can take a look at how I did it. So let me get started. First of all, we need to create a class user, and this will help us to create users later on. So we use opening and closing brackets, and inside of those brackets, we now define our user blueprint. We're going to construct the user by using the constructor like so, and inside of the brackets right here, we accept a couple of parameters. The first one is of course going to be the username. Second one should be the country, and the third one should be the age, like so. You're wondering why we're not accepting the login status, and I will show you in a second. But for now, let's say that this .username, so the username for the specific object later on, is going to be equal to the parameter username. So whatever we pass to our constructor later on. This .country is equal to country, and this .age is equal to age. Now we also need the login status. So this .login status, for example. But since we want to set it to false by default, we do not have to accept it as a parameter here, because we do not want to set this when initializing the user. The user will always be logged out by default. So login status is going to be false all of the time. Every time we construct a new object, a new user object, the login status will be false. So now we also need a method to log the user in. So let's create a login method right here. And for this method, we of course need to set the login status to true. So we're going to say this .login status is equal to true. And now we can also console.log, let's use backtick characters, and let's say the user $this .username is now logged in, like so. So this will be our message. And now we can also use or create a method logout like so. And that one just sets the login status to false, because then he's essentially not logged in anymore. And again, we can use console.log. Let's again use backtick characters like so. And let's say the user, this .username, is now logged out like so. So this is our success message essentially when the user logs in or logs out. And now we also want to provide information about the user. So maybe the username, the country, and the age. So we can say get user info like so. And now right here, we are just going to console.log, for example. Let's use backtick characters. Let's go into new line like this. And now let me just say that the username, for example, like so, is equal to this .username. Let me go into a new line. Now let's also print our age, and let's say this .age is our age, and of course the exact same for our country. And now we're going to say this .country, like so. So after a colon, we will always provide the actual information. And now let me save this. And let's create a new user by using the constructor. And let's say the first user, for example, is NPC. So const NPC is equal to new user like this. The username is NPC. Country might be Germany. Age might be 28. And now I'm going to save this. And now I can access npc.login, for example. Let's test this. The user NPC is now logged in. Let's also use npc.logout, for example, like this. The user NPC is now logged out. And let's also use npc.get user info, like so. Username NPC, age 28, country Germany. And of course, we could also format this a little bit better like this. And we could also output the login status. We're going to say login status colon. And now I want to access this dot login status like this. And you can see we're getting login status false. So currently we're not logged in because we logged out. If I'm going to remove logout though, we're getting login status true because now we're logged in. And this is how you can create a basic user that includes a couple of properties and has a login, logout, and get user info method. So I hope you enjoyed this little project and see you in the next lesson. Let's now understand keys, values, and entries. And keys, values, and entries are used to access object data. So what do I mean by this? Let me show you by first of all creating an object. So imagine we're having a user object like this. And this user object is equal to this object that has the property, or to be precise, the key username. And the username can be NPC. He also has an amount of subscribers, for example, currently 1,300, for example. And he has an amount of money, for example, currently probably around 0. So this is now our user. And now let me show you what keys, values, and entries are by just console.logging them, because that's probably the easiest way to understand it. And now we can access the keys by using object.keys, for example. And inside of those brackets, we can now define the object of which we want to get all of the keys. In our case, it's the user object. Like this. I'm going to save this. And you can see inside of an array, so inside of a list, we get all of our keys. So we're always getting the key. So username, subscriber, and money are the keys for our user. Now, instead of keys, we can also get the values by using object.values. And now, again, inside of an array, we're getting all of the values. So NPC, right here, 1,300, right here, and 0, right here. So by using object.keys, we're getting all of the keys. And by using object.values, we're getting all of the values. And now we can also use object.entries. And now we're getting an array of arrays. So inside of the first array, we have another array that includes key and value. So every single array inside of this array contains key value pairs, but this time as an array instead of key value pairs inside of an object. So we have the first array that includes username and NPC, the second one that includes subscribers and 1,300, and the last one which includes money and 0. And now, since this here essentially returns an array, we can of course also access those elements by using bracket notation. So I could access object.entries of user of 0, which gives us username and NPC. I can access number 1 like this, and number 2 like this. And of course I can also access 2, 0, for example, because this here is element number 0 and this here is element number 1. If I only want to get the key now, I could also get 2 of 0, for example, and this would give me money, and 2 of 1 would give me the actual value, like so. Of course, I can also do 0, 1, 0, 0, 1, 0, 1, 1. So I think you get the idea. you can access the values inside of this array just by using the bracket notation the normal way. So I think you get the idea. And that is how you can access keys, values, and entries of a certain object. Let's now understand object.freeze. And object.freeze prevents object values from being changed. So let me show you. Imagine we're having a user object. So const user is equal to this object right here. And now this user has a username of NPC, for example, once again, and an age of 28, for example, like so. And now I can freeze this object by using object.freeze, like so. And inside of the brackets, I need to pass my user object, like so. And now imagine I want to change this object, for example, object.username, and set this equal to npc codes, like so. Now let me just console.log the user for you. And now you can see for the username, we still have username npc and age is still 28, even though I changed it right here. So now once I remove object.freeze and I'm going to save this, you can see that username is now npc codes. So by using object.freeze, we essentially prevented our username, or the value to be precise, from being changed. And that is all you really need to know about object.freeze. It essentially prevents modifications of existing properties, and it is useful if you want to prevent anyone from changing an object at a certain point in time, for example. Let's take a look at the difference between primitive types and complex types. Primitive types usually store simple values, whereas complex types store multiple values. An example for a primitive type is a number, for example. So const score, for example, is equal to 100. So this right here is a primitive type. Now, a complex type is, for example, an object or an array. So const numbers is equal to this array, for example. And this here is a complex type. Another complex type is, of course, an object. So const user is equal to this user that has a username of npc and an age of 28, for example. So this is a complex type as well. And now let me show you the difference. Let me, for example, say const score copy is equal to score. So now we're saying that the score copy should have the same value that our score has, so 100. I'm now going to console.log our score, and I'm also going to console.log our score copy, for example, like this. And you can see we're getting 100 in the console both times. Now, what would happen if I would increase the score though? So if I would say score plus equals 100. And now, of course, I should use let right here because I'm modifying the value, so const doesn't work anymore. And now I'm saying score plus equals 100. So my score is now 200 for the first score. But since I'm first of all taking the value of score and assigning it to score copy, and only afterwards I'm incrementing the value of score, score will have a value of 200, whereas score copy will still have the value of 100. So you essentially just create a copy, and the copy from that point in time is completely independent from the original score. Now let me try to change the numbers array though. So let's say const numbers copy is equal to numbers. So we now have a copy, and now I'm going to say that numbers of 0, for example, is now 100. And now I'm going to console.log our numbers. And you can see, as expected, we're getting 100, 2, 3, and 4. So the first value has been modified. And now I'm also going to console.log our numbers copy, like this. And we're getting the exact same value. So even though we first of all took our numbers and copied them to our numbers copy, and only afterwards changed the value of the first element, we're still getting the exact same arrays. And the same would also happen for our object, so our user object. So why is that? And the reason for this is that simple types essentially have a value, and if you copy this value over to another variable, this variable will take the value, but from that point in time, it will be completely independent. And the reason for this is that score will get saved at a certain memory location, and the score copy later on will also get stored at a different memory location. So let me print this for you. So the storage of a computer looks somewhat like this. You have a lot of different cells. So you have a cell right here, a cell right here, a cell right here, and then you just have a lot of cells. And all of those cells allow you to store values. And essentially, if you take a primitive type, you essentially store the value inside of one of those cells, like so. And later on, every time you want to get the value of this primitive type, you're going to take a look at that cell and read the value from the cell. If you're now going to create a copy, you're going to take a look at this cell, you're going to create a copy and save the copy inside of another cell. So maybe this cell right here. So now the first value, so the original score, points to this cell, whereas the score copy, for example, could point to this cell. And if you now change the value of the score, you increment the value of this cell, but the value of this cell will of course stay untouched, whereas incrementing the value of this cell would of course increment the value right here, but keep this value untouched. So that is how this works. So now let me show you the difference to complex types. Imagine we are storing the value of our complex type, so maybe of our numbers array, inside of this cell right here. So now, whenever we want to get the value of our numbers array or increment the value, we are going to point towards this cell. So now we have a reference towards this cell. If we are now going to create a numbers copy though, we're essentially not going to take the value and copy that one into a new cell, but instead, we're just going to take a copy of the reference, so of the cell reference. So maybe this here is cell 1, this here is cell 2, 3, 4, 5, 6, and so on. And now we're just going to take the cell number essentially and copy that cell number to numbers copy. So now numbers copy will also point to the exact same cell. And every time numbers copy needs this value, it's going to take a look at cell number 2. And every time numbers needs to have the value of the cell, it's also going to take a look at the cell with the number 2. So essentially, for complex types, we're only going to paste the reference of the memory location. So for primitive types, you essentially copy-paste the value, and for complex types, you copy-paste the reference to the memory location where this value is stored. And of course, if one of those values of numbers or numbers copy now changes the value inside of the cell, it will essentially change the value for both of those variables because both variables are pointing to the exact same memory location. And if the value is now different, of course, both of those variables will read the adjusted value, so the new value. So the important difference between primitive and complex types is that primitive types only copy the value and store their values inside of different cells in the end, different memory cells on your computer. Whereas complex types don't copy the entire object. So for a complex type, like an object, you just copy the pointer, so the pointer to the corresponding memory cell. So even if you have 100 copies of this user object, for example, there will only be one single user object stored in a memory cell, and you will have 100 different pointers to this one exact same cell. And something that I also didn't mention up to this point, if you take a look at the difference between primitive types and complex types, if you use const, for example, for the score, and let me for now delete all of this, and I later on decide that I want to change the value of score, for example, by 100, and I'm now going to console.log the score, you can see that we're getting this error right here, assignment to constant variable. So for primitive types, you cannot adjust the value of a constant variable. Therefore, if you have to change the value of a variable later on, you always want to use let. If you are certain though that you don't have to change the value of this variable later on, you should use const, like so. So under those circumstances, we should of course use let because we want to change the variable of our score later on. Now, on the other hand, when using complex types like arrays or objects, even though you have a constant variable right here, you can change the value by using bracket notation, for example, for arrays. So this here is completely valid, like so. Let me console.log the numbers, and you can see this works. You could also add elements by using .push, for example, like so. So I could just push a new element to this array, so 100. So you can add or remove elements as well and modify this array in any way you like. The only thing that you cannot do is essentially saying numbers is equal to completely new array, for example. So this here is not valid, but using methods to modify the array is completely fine. So using pop, push, and so on is something that you can do. So even though the array has a constant variable, it's still possible to modify this array by using methods, for example. And the same also works for objects. So if you have a user, for example, and this user maybe has, again, the username NPC, even though this here is a constant variable again, you can still say that user.username should now be NPC codes, for example. And let me console.log the user. And you can see this here is still valid, so we can change it like this. The only thing that you cannot do is, again, reassign to the user variable a completely new object. So something like this here is, for example, not possible because now it's a different object. But modifying it using a method, for example, or using the dot notation, so user.username, is something that you can do all of the time, like this. So understanding this difference is also important, even though this has a little less to do with primitive and complex types, but it's an important difference to notice. So to summarize, primitive types store simple values and store their values always inside of their own memory address, so memory location on your PC. Complex types store multiple values and they point to the stored value inside of the memory address by using a pointer. So when copying a complex type, you don't copy the entire complex type to a new memory cell, but instead you copy the pointer to the new variable. And those are the most important differences between primitive types and complex types. Let's now take a look at probably one of the most important takeaways of this course. And that one is that almost everything in JavaScript is an object. If you remember a lot of the stuff that we did up to this point, it was probably a little confusing to a lot of you. So why did we, for example, say console.log hello, for example? So why did we use this dot, for example? What exactly is the console? And the same, of course, also works for math, for example. We used math.random, for example, like this. Again, we use this dot, and again, this name afterwards. So why is that? And the reason for this is that everything, again, is an object in JavaScript, or almost everything. So let me show you. Let's, for example, console.log the type of the console, for example, like so. And you can see the console is just an object. And we can also console.log the type of math, for example. Again, that is an object as well. And I can also show you how this works by creating something similar to the console. So the console is essentially just an object that has properties and methods. And if we would create a console ourselves, we could do so by, for example, saying const console1, for example, is equal to an object. And now this object, for example, has a log method like so. And now, instead of this log method, we could just define what we want to do. In our case, we maybe want to console.log, and maybe we expect a message right here. And now we can just console.log the message, like so. I'm going to save this. And now we could, for example, say console1.log. So now we're accessing our own log method right here. It expects a message. I could say hello guys, for example, and we're now printing hello guys. So in the end, this here is pretty similar. The console object is just a predefined object from the JavaScript team that provides us a method to log something in the console. And of course, it's a little more complex than this right here. Also, we're using the original console right here. So by default, the original method is of course slightly different, but the basic principle is exactly this one right here. You are having the object. You're going to access this object by using the object name. By using the dot notation, you say that you want to either access a property from this object or a method from this object. In our case, we want to access a method. Every time you want to access a method, you use opening and closing brackets. And in case this method expects a parameter, you pass a value as an argument to this method right here and then execute it. So those brackets right here always mean execute a method. And if you just have a property, so something like, I don't know, speed, for example, let's say we have a speed of 100, you can access this property pretty much the exact same way. You use the object name followed by a dot, and then you could just use the property name. If you access a property though, you don't have to use those braces right here. This here means you want to execute a method. This here means you want to access a property. So now we could just console.log console1.speed, for example, and we would get 100. And the important takeaway is that every time you do something like math.random, for example, like this, you're essentially just accessing a JavaScript object that the JavaScript team provided for us. In this case, the math object. You use the dot notation to access one of the properties or methods of this object that the JavaScript team provided. And then, in our case, we're going to access the random method from the math object. And we're going to execute it. So, if you would like to reconstruct this object, for example, you could just do something like const math1 is equal to an object. Then you would have the random method right here, for example. And now you could just create a random number, for example. So we could, for example, return some random number, and then you could do some calculations and so on. In my case, I would just use the math.random property that already exists. So of course it doesn't make too much sense, but I think you get the idea. You could also create something like an add function or method to be precise, except maybe two numbers like so. And now you could just return num1 plus num2. And now we could access our own math object right here and say math1 dot add, for example, we get number 100 and number 200. At the moment, we're only returning it, so we should also console.log the returned result, and we're getting 300 in the console. And the math object that the JavaScript team provided looks pretty similar. It's just a normal object that includes a lot of different functions or methods, to be precise. So add, subtract, multiply, pow, and so on. So they added all kinds of methods there to this object, and now we have access to those methods. And the same, of course, also applies to the console object and to all kinds of objects in JavaScript. So that is the important takeaway. Every time you use the dot operator, you under the hood essentially just access a JavaScript object and access a property or method of this object. And knowing this makes this dot notation a lot less confusing in JavaScript. So to summarize, almost everything in JavaScript is an object. Let's now understand the for loop in JavaScript. And a for loop repeats code multiple times. Let me show you what I mean by this. And I'm first of all going to write it out, and then I'll explain it to you. You start a for loop by using the for keyword. Afterwards, you always have opening and closing brackets. And inside of those brackets, the first thing you do is initialize a variable. So let I be equal to 0. And I is just a convention. This here can be anything you like. This could be A, B, something like this. And again, I is the convention, like so. Then you use a semicolon to end this statement right here. So this here is the initialization. You initialize a variable. The initialization could also be 10, 5, 0, and so on. Again, 0 is pretty common for a lot of tasks, but it also depends on the task. After the semicolon, you define a condition. So how long should this for loop run? This for loop can repeat as long as the condition is true. So in our case, maybe as long as I is less than 10. So now this for loop will run as long as the condition I is less than 10 is true. And the third one, so the third thing we have to add right here, after a semicolon again, is what we want to do after each single loop iteration. And in our case, we, for example, want to increase I by 1 every single time we loop. And now we have those opening and closing brackets. And inside of those brackets, so again, inside of the body, we define what we want to do for every single iteration. In our case, let's just console.log I, for example. And you can see in the console we are getting all the numbers from 0 to 9. So how does this work? Again, we are going to initialize our variable I with the value 0. We're going to run this as long as I is less than 10, and after every single iteration, we'll increment I by 1. So initialization, condition, and increment or decrement. So change after every single iteration. So in the first iteration, I is 0. Is I of 0 less than 10? So is 0 less than 10? 0 is less than 10. So we're going to start by doing the first iteration. We're going to console.log I, which is 0 during the first iteration. Therefore, we get 0 in the console. After we finished executing this statement, we get to the end of this loop. And since it's a loop, we will do it forever until the condition is essentially false. So now, since we finished executing, we are now going to increment I by 1. So we will do whatever we defined right here. In our case, increment I by 1. So now I is 1. We're going to check, is I, so it's 1, less than 10? I is still less than 10. Therefore, we are going to execute this code right here once again. So now we're going to console.log I. We're getting to the end of the iteration. We are going to increment I by 1. So now I is 2. Is 2 less than 10? 2 is less than 10. Therefore, we'll print 2. Again, we're at the end and we'll increment I by 1. We are going to do this forever until this condition here becomes false. So now after the last iteration, I is 9. We're going to increment I by 1. So 9 plus 1 is 10. So now is 10 less than 10? 10 is not less than 10 anymore. And therefore we're going to break out of this loop. So this loop here runs as long as the condition is true. So now what would happen if I would say as long as I is less than minus 1? So 0 is not less than minus 1. So this here should not run at all. And you can see it doesn't run at all. So this loop will only run if the condition is true. And right here, we could also do something else. So we could also say I plus equals 2, for example. And now we're going to get 0, 2, 4, 6, and 8. You could also say plus 5. So that is up to you. We can also say minus equals 5. And now we will get an infinite loop because this here will always be true. We're never going to break out of this loop. And you can see it goes on forever and ever. So I'm going to say plus equals 5 again. I'm going to save this, and probably my browser window crashed because I'm not really getting out of it. So maybe I have to reload this, and it doesn't work. So I think I have to close the entire window. So you can see an infinite loop can break your browser pretty fast. So I'm going to open this here once again, so the console. And now we can try this loop again, and we're getting 0 and 5. So to summarize, a for loop repeats code multiple times. You start by using the for keyword, then you initialize a variable. After the initialization, separated by a semicolon, you have your condition. And after another semicolon, you define what you want to do after every single iteration. And the block inside of the braces will run as long as the condition is true. And that is a for loop in JavaScript. Let's now understand while loops in JavaScript. And while loops run as long as a condition is true. Let me show you. Imagine we have a score, for example. So let score be equal to a certain number. And for now, let's say that this number is 0, for example. So by default, our score is 0. And now we can use a while loop to run a certain task as long as the score is less than 10, for example. In order to do so, we use the while keyword right here, followed by opening and closing brackets. And within those brackets, you define your condition. So right here, you have the condition. And this could be something like while score is less than 10, for example, like this. So this here is now our condition. So this while loop will run until the score is not less than 10 anymore. But as long as the score is less than 10, this while loop will run. Now we have a body again, so opening and closing brackets. And within this body, we again define what we want to do for every single iteration. So we could just console.log our score right here. If I'm now going to save this, you will see in the console that we will log the score. And this here is an infinite loop, because this here will never stop. We're going to run this code as long as this condition is true. So we are going to start with a score of 1, first iteration. We're going to console.log the current score, which is 0. We're going to get to the end of this loop. We'll check the condition right here once again. The score is still less than 10. So we run this code here once again. We get to the end. Therefore, we check the condition again. The score is still less than 10. So we are again going to console.log the score. And this will run forever and ever and ever. So in order to break out of this loop, we have to change our score in a way that will make this condition become false at a certain point. In order to do so, we could, for example, increment the score after every single iteration, like so, for example. Let me save this. And now you see that my browser window probably crashed. So I probably have to reload this. And I don't even know whether that is going to help. So yeah, as you can see, an infinite loop can probably break your browser. So now I have to close my browser like this. And I have to reopen my browser like this. And now we're back on our website. Let me inspect, console, and let me clear the console, and let me save this. And this is what we get in the console. So we get the numbers from 0 to 9. So what exactly happens right here? In the first iteration, our score is 0. Is a score of 0 less than 10? That is true. So we're going to console.log the score. And afterwards, we are going to increment the score by 1. So now our new score is 1. Is 1 less than 10? 1 is less than 10. So we're now going to console.log the score of 1. Therefore, we have 1 in the console right here. Again, we are going to increment the score afterwards. So now our score is 2. 2 is less than 10. So we're again going to console.log the score of 2. And now we repeat this here over and over again until our score is 9. We're going to console.log the score of 9 right here. We're going to increment the score of 9 to 10. So now our score is 10. Is 10 less than 10? 10 is not less than 10. And therefore we are going to break out of this loop. And once breaking out of this loop, we would just continue to execute whatever we have afterwards. So if we have hello, for example, right here, we would go through the entire loop, and afterwards we will print hello once breaking out of this loop. So this loop will essentially go from start to end to start to end, and only afterwards we will execute the code that comes afterwards. But now, of course, it can also happen that this condition here is never true. So maybe 11 right here, or 10, doesn't matter, like this, and we're only seeing hello in the console, which I can also delete, because you know how this works now. And you can see we're not getting anything in the console, because this condition here is not true. We're going to check, is our score of 10 less than 10? That's not true. Therefore, we will not execute this block of code right here. But if we want to run something once at least, we can use a do-while loop instead. Let me show you. A do-while loop is essentially a while loop. The only difference is that it will run once at least, even if the condition is not true. So for a do-while loop, you have do right here as a keyword. Then you have your opening and closing brackets. And right here, you define what you want to do inside of your while loop. So console.log score, for example. And now I want to increment score by 1. So score plus plus. And right here, after those brackets, I have my condition. So while this condition is true essentially. So while score is less than 10, for example. I'm going to save this, and you can see we're getting 10 in the console. And the reason for this is that we're first of all going to execute this code, since we're starting from top to bottom. Therefore, we'll execute this here first. And only after we've executed what we have in the do block, we're going to check for our condition. So now, this condition is of course immediately false. We even incremented our score right here. So now our score of 10 is 11. Is 11 less than 10? 11 is not less than 10. Therefore, at this point right here, we break out of this loop. So this here is also pretty logically, because as already mentioned, JavaScript executes code from top to bottom. So when we have a normal while loop, so score less than 10, for example, and let me just paste this here over, it makes sense that we first check the condition, because checking the condition right here comes first. And only after we check the condition, we execute this code right here. For a do-while loop, it also makes sense that we always execute it once, because again, we start from top to bottom. So we first of all execute this block of code, and only after executing this once, we check the condition. So only when checking the condition, we can break out of this loop. We can't break out of this loop when not checking the condition. Therefore, this here makes a lot of sense in my opinion. So to summarize, a while loop will run code as long as a condition is true, but it checks the condition before executing it for the first time. A do-while loop will also run as long as a condition is true, but the only difference is that it will run once at least, and only after running once, it will check the condition. And that is all you need to know about the while loop and the do-while loop in JavaScript. Let's take a look at the for-in loop in JavaScript. The for-in loop iterates over object keys. Imagine we have an object, for example, an object Goku that is equal to this. And let's use const right here because we do not plan to reassign the value later on. So this here is the clean way. And now, of course, the name is Goku and the power level is 9000 once again, like this. And now we can use a for-in loop to iterate over object keys. So over those keys right here. So again, we use the for keyword to define a for-in loop. Now, again, as a variable, we define a key. So we say let key. This here can be anything. This can also be this, or this. It doesn't matter. So you can have anything, but key is pretty common. But let me show you that it works like this as well. And now the name is for-in loop because we say in right here. And now we have to define the object over which we want to iterate. In our case, Goku. And now let me just console.log ASDAS for now, like so. And we're getting name and power level. And now let me use a more descriptive name. So let's use key, since you now know that this works. So a for-in loop allows us to get one of the keys for every single iteration. So for the first iteration, key is going to be name. We're going to console.log the key. We are going to reach this point where the iteration is essentially over. We're going to go on to the next iteration. For the next iteration, key will be power level. We're going to console.log the key power level and we'll end right here. We don't have any keys anymore, and therefore we are going to break out of the loop at this point. Now I can also, for example, access the individual values, but for example, accessing Goku of key. And this is going to be similar to accessing Goku of name for the first iteration and Goku of power level for the second iteration. And this is a point where you essentially access a value dynamically. And under those circumstances, when accessing a value dynamically, you cannot use the dot notation. You can only use the dot notation to access specific properties like name or power level. But you cannot use the dot notation to access a value dynamically by using a changing key, for example, like this. So this is undefined. Under those circumstances, you always need to use the bracket notation. So Goku of key works, because this here will at runtime always take a different key for every single loop iteration and then access the individual values. So this here works. So for the first iteration, we're getting Goku of name, which is Goku. And for the second iteration, we are getting Goku of power level, which is 9000. So this is how this works. So to summarize, a for in loop allows you to iterate over the keys of an object. And then you can use the key to access the individual values of those keys. And that is the power of the for in loop. Let's now take a look at the for of loop. A for of loop iterates over iterable values like arrays. We already had the for in loop, and you use the for in loop to iterate over keys instead of objects, and you use the for of loop essentially mostly to iterate over arrays. So for in for objects, because you are searching inside of an object, and for of for arrays, because you're getting individual values of an array. So that's how you can probably remember it. So imagine we're having a numbers array. So numbers is equal to maybe 10, 20, 30, 40, and so on. And now we want to iterate over those numbers. Again, to create a for of loop, we need to have the for keyword. Now, instead of brackets, we again define a placeholder for every single iteration. So maybe a number, like so, of numbers. And this variable that we defined right here will now hold the number or one of those numbers for every single iteration or during every single iteration. So during the first iteration, number will be 10. During the second iteration, number will be 20, then 30, and then 40. Let me show you. Let's for now just console.log the number, and we're getting 10, 20, 30, and 40. So for the first iteration, number of numbers will hold the value 10. We're going to console.log the number. We're reaching the end. We're going on to the next iteration, and number will now be set to 20. Now, 20 will be logged in the console. We go on to the next iteration. For the third iteration, the placeholder number, so our number variable, will hold the value 30, console.log that, and then go on to the last iteration. And that is how a for of loop works. So loops essentially always iterate over something. You can define those loops yourself by just using a normal for loop. You can iterate over objects, or you can iterate over arrays, for example, or iterable values in general. So that is up to you. But just remember that a for loop will run over and over again until a certain condition becomes false, essentially. For example, until a condition you defined becomes false, or, for example, once an object does not have any keys anymore, or, for example, once an array does not include any values anymore. So every time a specific condition becomes false, you're going to break out of the loop. But up to this point, the loop will iterate over and over again, one by one. And that is the basic principle of for loops. And a for in loop and a for of loop are essentially just specific implementations of for loops in the end. So you could also get the exact same result by using a normal for loop. Let me show you. So we could, for example, just say we're going to start at an I of 0. We're going to keep going until I, or as long as I, is less than numbers.length. Numbers.length should be 4. So as long as I is less than 4, we're going to keep going. And after every iteration, we're going to implement or increase I by 1. And now we'll access numbers of I. And let me just console.log this for you, so you really see how this works. And you can see we're still getting the exact same result, because during the first iteration, I0 will access numbers of 0, which is this value. We'll increment I by 1. We check is 1 less than 4, because numbers.length at the moment is 4. 1 is less than 4, so we'll again access numbers of 1, so 20. We'll increase I by 1 after the iteration. So we now have 2. We access numbers of 2. We increment I again. We now have numbers of 3. We are accessing this element, the last element. We are going to increment I. Now I becomes 4. Is 4 less than numbers.length? So 4. That is not the case. And therefore we'll break out of this loop. So as you can see, you can do the exact same by just using a normal for loop as well. A for-of loop would just be a little bit easier. But nevertheless, it's nothing that is really necessary if you know how to implement the exact same yourself. And of course, under normal circumstances, you would use the for-of loop because it's a little bit easier. But understanding that all of this essentially follows the exact same principle is really important. And that is all you need to know about for loops in JavaScript. Let's now understand nested loops. And nested loops are essentially just loops inside of other loops. Let me show you. Imagine we're having our loop that we already previously created. So for let I be equal to 0, we're going to do this loop as long as I is less than 3, for example. And after every single iteration, we're going to increment I by 1. And now inside of this for loop, we could also have another loop. So again for, and now we cannot use I again. So we should have another variable name. And a common name, so a convention, is to use j instead. So let j be equal to 0, for example. We're going to do this as long as j is less than 5, for example. And we are going to increment j by 1 after every single iteration. Now, let's always console.log I right here and j right here. So I'm going to say I is whatever we have for I, comma, and now I'm also going to log j right here for you. And j is, of course, our variable j, like so. And you can see we're getting this result. So we're getting I0, J0, I0, J1, I0, J2, and so on. So J3, 4, and so on. And then we're getting I1, J0, I1, J1, I1, J2, and so on. So how does this work? We're always going to start with the outer loop right here. So for the first iteration, I is going to be 0. We're going to go to the body and we'll execute this body right here. Instead of this body, we have our second for loop. So now I is 0 and j will now also be 0. We're going to do the inner loop as long as j is less than 5. And after every single iteration, we'll increment j by 1. So we're going to console log I of 0 and j of 0 for the first iteration. We're going to get to this end for the inner loop right here. And therefore, we're going to jump to the beginning of this loop after incrementing j, of course. So now j is 1. Is 1 less than 5? 1 is less than 5. Therefore, we'll execute this here once again. I is still 0, but j is now 1. We're going to console.log that. We're getting to the end. Therefore, we're going to increment j. J is now 2. 2 is still less than 5. We'll execute this again. Increment j. J is now 3. 3 is still less than 5. Therefore, we'll execute this again. We increment j. J becomes 4. 4 is still less than 5. We'll execute this again. And again, we increment j. J is now 5. 5 is not less than 5 anymore. Therefore, we'll break out of the inner loop and get to the end of the outer loop. So now we're going to increment I by 1. So now I is 1. We're going to check if 1 is less than 3 essentially, which is of course the case. And we're going to start to loop over this loop here once again. So to go over this loop once again. Therefore, j is again 0 because we start executing this loop here once again. And of course, we check is 0 less than 5, which is the case. Therefore, now we'll execute this here again. But now I is 1, while j is now 0 again. So we go over the entire loop once again until j becomes 5 again. Then we break out of this loop and go on to the next iteration. So we increase I by 1 once again. So now I is 2. So it's actually pretty simple. We are going to start with the first for loop. And inside of the first for loop, we have another for loop. And of course, we have to go over this for loop inside of the outer loop for as long as this condition here becomes true, because we can never break out of this loop unless this condition becomes false. So we will iterate and iterate over this loop over and over again until this condition becomes false. And once this condition becomes false, we're going to go to the end of this loop essentially, so to the end of the outer loop, and we're going to increment I again and then check the condition again. and then a new iteration for the outer loop starts. And it also makes sense because you execute the outer loop, and for every single iteration of the outer loop, you have to do everything that is defined within the outer loop. So you have to execute the entire for loop for every single iteration of the outer loop. So I hope you get the idea. And this is something that can also be useful when you have nested arrays. So imagine we have a numbers array, like so. And now inside of this numbers array, we have 1, 2, and 3 as the first array, and then maybe 4, 5, and 6 as the second array, and 7, 8, and 9 as the last array, like so. So now this here is the outer array, and this here is the inner array, like so. And now we can first of all go over the outer array by using a for of loop. So for let r for array of numbers, and now we're going to console.log r for now. And you can see we're getting one of those arrays for every single iteration. So we're getting an array, and now we can loop over this array once again by using a for of loop. So for let number of r, and we're just going to console.log each individual number. And now we're getting all of those individual numbers. So during the first iteration, so this for loop, we're essentially accessing each individual item inside of this for loop. So during the first iteration, this one, second iteration, this one, and third iteration, this one. And then during the first iteration, we are going to loop over every single item. So now during the first iteration, r holds this array right here. We're going to go to the second for loop, and during the second for loop, number will during the first iteration hold the number 1, during the second iteration, number 2, and during the third iteration, number 3. Then we are going to end this for loop because we don't have any items anymore inside of this array. Therefore, we're ending this, we're getting to this point, and now we're checking, does there exist another array inside of numbers? And indeed, we have this one. Therefore, r will now hold this one, so this array, as the next value. We're going to start this for loop again, and now number will hold 4 for the first iteration, 5 for the second iteration, and 6 for the third iteration. Once we finish doing this, we're again going to end this loop, going right here. We check, does there exist another array? And again, we have another array. So now r will hold this array, and we're going to do the exact same once again. So a nested for of loop can also be useful to loop over nested arrays. So to summarize, nested loops are just loops inside of other loops. And of course, you can also have loops inside of other loops inside of other loops. So I can nest loops as deeply as you like. Let's now understand how to convert strings into other data types. So imagine you have the string 10, for example. So just the text 10. But somehow you want to do an addition with a number, for example, the number 45. Doesn't matter. But at the moment, if you remember, this will not do a normal math operation. So if I'm going to add 10, so the string 10, to 45, we will get a different result. So we will get 1045. So how can I convert the string here to a number, for example? And in order to do so, we can parse this string to a number by using number like so, followed by opening and closing brackets. And inside of those brackets, we now need to define the value, as you can see. And in our case, it could be 10. And now we're getting 55. So this here converts this string, so this text, to a number. And now we can do mathematical operations with the string. We can also convert something to a float by using parse float. I'm going to save this. We're still getting the same result, but now I could also use 10.5, and we would now get 55.5. So this allows us to turn text into a decimal number, essentially. Now we can also convert a number to a string. So we could use string like so. And now as a value, let's use 10. And now again, we would get 1045. Because of course now this here is just a normal text, and we could of course also turn this into a text and it wouldn't change anything. Because once we have one string inside of a normal addition, everything will be converted to plain text. And adding the text 10 to the text 45 will always result in 1045, obviously. We can also convert something to a Boolean by using Boolean like so. And now you can see the number 10 gets converted to true, the number 5 gets converted to true, the number 4 or 3 gets converted to true, but the number 0 gets converted to false. Number -5 gets also converted to true, -10 as well, and so on. So only the number 0 will get converted to false, and that is something that is important to know. And for strings, it's pretty similar. If you have a normal string, this will be true. Doesn't matter what kind of string it is. If you have an empty string though, this will be converted to false. And this here is something that is important when working in web development, for example. Because by doing so, for example, when the user doesn't enter anything, you will always have an empty string. And now you can convert this empty string to a Boolean. The Boolean will be false. And therefore you can check whether the user entered something inside of an input field, for example. And if he did not enter anything, you can, for example, prompt the user to enter something. And knowing that an empty string will get converted to false essentially, and the number 0 will get converted to false as well, is something that is really important, especially if you work with if statements later on. Because now imagine you have a username, and that one is equal to an empty string, for example. You could now check if username, so if you have a username, and if you have a username, you can prompt or write, but else you can prompt or you can console.log username mandatory, for example. At the moment, the username is mandatory because we don't have a username. So this here is empty. This will get converted to false essentially, and therefore we will console.log username mandatory. Once I have NPC right here, this will be interpreted as true. Therefore, if username is going to be true, because username is now true or will be converted to true, and therefore we can console.log or write. And this is really good to later on check whether a user has entered something or not. If a user did not enter something, we can always prompt them to enter something. And of course, the same works for numbers like 0, for example. So 0 will always be false, so username mandatory, whereas any other number will be true, therefore we are getting all right. Of course, doesn't make too much sense for the username, but I think you get the idea. So when using if statements, those conversions that we did previously will happen under the hood. But if you need to explicitly convert something the way we needed to do it previously, you can use things like, for example, string followed by a number to convert something to a string, or, for example, of course, number to convert, for example, text into a string, or, for example, Boolean to convert text into a Boolean or numbers into a Boolean, and so on. So those ones are really important. So to summarize, you can use those conversions right here, so Boolean, string, number, and so on, to convert strings or other data types into any other type. Let's now understand the map method. And the map method creates a new array by changing each value of an existing array. So let me show you. Imagine we have a numbers array. So numbers is equal, and let's have the numbers 1, 2, 5, for example, like this. But now maybe I want to loop over all of those numbers and create a new array at the same time, and every number inside of the new array should be twice as big as the old number. And in order to do so, I can use the map method to essentially map each old number to a new number in the new array. Let me show you. We can, for example, say numbers, and now every single array has the map method. So by using dot on this variable right here, so on this array, followed by map, we can access the map method on any array in JavaScript. Now we have to call this method by using the opening and closing brackets. And right here, Visual Studio Code also indicates that we have to pass a callback function. So this function will be called back over and over again for every single element. And as you can see, this callback function has the following syntax. You have the value right here as a parameter for every single iteration, and then you can do anything you like. Let me just show you. That's a little bit easier. So when using map method, we have to pass another function to this method that will be called back for every single value. And that is a new concept for us, but it's easier than you think. So let me just do it and then I'll explain it to you. So num goes to num times 2, for example, like this. And now I'm just going to store the result in new numbers, for example. So new numbers is equal to numbers.map, like so. Let me console.log the new numbers for you. And you can see our new numbers are just an array, and every single number is just twice as big as the old one. So 2, 4, 6, 8, and 10, instead of 1, 2, 3, 4, and 5. So how does this work? As I already mentioned, a callback function is just a function passed to another function as an argument. So right here, on the numbers array, we are calling the map method. And this map method expects a callback function. So we have to pass another function to this map method. And usually when writing callback functions, you use the arrow syntax to create that function. And now, right here by default, when calling the map method, JavaScript will always give us one individual item of this array for every single iteration. So this is somehow similar to a for loop, for example. So for the first iteration, this number parameter will hold the value 1. For the second iteration, it will hold the number 2. For the third one, the number 3, and so on. So during the first iteration, this here will hold number 1, and we're going to execute this function right here. So right here, we are going to say that we want to multiply num times 2. So we're essentially taking the old number, which is 1, and returning number times 2, so 1 times 2, which of course is 2. Therefore, we return 2. And then, since numbers.map, so since the map method returns a new array, we can store this array, so this first number, inside of this new numbers array right here. Then we're going to do the exact same for the second number. So now, second iteration, num is 2. We're again going to do num times 2. So 2 times 2, which is 4. And we return 4 and store it inside of this array, inside of our new array. Something that is important is that if you would use multiple lines like so, then doing it the same way would not work. So now you can see we're getting undefined, because you always have to return the result after every single iteration. So like this, it works. If we get rid of the bracket and write everything into one line, we can also get rid of the return keyword, because having it inside of one line and then using the arrow syntax together with that, it will automatically add the return keyword for you. So let me get back to the original version like this, and now it should work. Let me create a second example so you really understand how this works. So const tripled numbers, for example. Now again, I'm going to call the map method on my numbers array, like so. To this map method, again, I need to pass a callback function. For every single iteration, so every time we call back this function, we're going to get one of those numbers right here. And now I can just say that I want to multiply num by 3, for example, like this. And now the map method, in the end, once done, returns a new array that consists of all of the numbers that we just generated right here. So now I can console.log the tripled numbers, and I would get all of the tripled numbers. Of course, I can also do num times num, for example, and so on. So I think you get the idea. To summarize, the map method just returns, so creates a new array by changing an existing one. Let's now understand the filter method. And the filter method creates a new array with matching values. So To say it in one sentence, it essentially allows you to filter an array. Imagine we have a couple of numbers again. So maybe the numbers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and maybe 10, like this. But now I only want to have the odd numbers, for example, or I only want to have the even numbers. So that is up to us. But I want to essentially filter out all of the numbers that do not fit this pattern. So if it is possible to divide a number by 2, for example, it's obviously an even number, and then I want to keep it. Otherwise, I, for example, want to remove it. So again, similar to the map method, the filter method always returns a new array. So const filtered numbers is equal to, now again, on the numbers array, we have to call this method. So I'm going to say numbers dot filter, like so. And similar to the map method, we also have to pass a callback function right here. Again, for every single iteration, the filter method will give us one of those numbers. So num might be a suitable parameter name, like so. And now, right here, we can create the filter condition. So now, what kind of circumstances do we want to return this value? So put this value into our new filtered numbers array. And under what circumstances do we want to filter it out? So we want to return this value if num divided by 2 is equal to 0. And in order to do so, we have to use the modulo operator, because that means there does not exist a rest. And if you can divide a number by 2 without having a rest, then this number is obviously even. Otherwise, it's odd. And now I can just console.log my filtered numbers, and you can see we're getting 2, 4, 6, 8, and 10. So let me show you how this works. During the first iteration, num will be 1, like so. And now we're going to say if 1 modulo 2 is equal to 0, but 1 divided by 2 is obviously 0 rest 1. Therefore, the rest is going to be 1, and the rest of 1 is not equal to 0. Therefore, we are not going to return this number and put it into our new array. For the second iteration, num is 2. 2 modulo 2 does not have a rest. Therefore, the rest is 0. 0 equals 0. So for that number, this condition becomes true, and we are going to put this number, so the number 2, into our new array, filtered numbers. Or to be precise, the array that we store within the variable filtered numbers. And now we're going to do the exact same for every single value inside of this array. And once we looped over all of those values, we essentially have our new array, so our filtered numbers array, that now only has our filtered numbers inside of it. Let me also show you what happens if I console.log the numbers. And you can see our numbers stay untouched. We still have the exact same numbers. So numbers.filter will not modify the original numbers array, but instead it will return a new array that we can store inside of a variable. And that is something that is really important. The map method as well as the filter method will never modify the original array. They will always create and return new arrays. So you use the map method to modify something inside of an array in a certain way, and you use the filter method to filter something inside of an array. Let's now take a look at the reduce method. And the reduce method reduces an array to a single value. So let me show you. Again, let's imagine we have a couple of numbers, like so. So maybe 1, 5, 10, 13, 2, 4, and maybe 29, like so. Doesn't really matter. And now imagine we wanted to create the sum of all of those values. In order to do so, we can use the reduce method to reduce all of those numbers to a single value. So again, we can use numbers.reduce. And reduce works similar to filter and map. You again have to pass a callback function. And for every single iteration, you now get a little more than just the current value. You get an accumulator, that's what you call it usually, later like so, and you get a current value. like this. And the accumulator is essentially the value that you have during every single iteration. So this will always hold your value. Whereas the current value will always hold one of those values for every single iteration. And I will explain this later on in a little more depth. But for now, this is enough. Again, we can use an arrow function. And now we can, for example, just use accumulator plus current value like this. And now right here, we also have to pass the initial value like so. Let me now store this result in a result variable, for example, and let me console.log the result for you. And you can see we're getting 64. So now let me explain all of this to you step by step. So right here, I'm calling the reduce method on the numbers object, so on the numbers array, which essentially is just an object in the end as well in JavaScript. Now, right here, I'm getting two parameters instead of only one parameter as previously for the map and filter method. The first value, so the accumulator, will always hold our value, so the total value, the value we want to reduce everything to in the end. So for the first iteration, accumulator will be whatever we define right here as a starting value. So the last value essentially is our starting value. And for us, this one is 0. So the accumulator during the first iteration is 0. Then we have the current value. The current value will always hold one of those values for every single iteration. So during the first iteration, current value is 1. Now we're going to return for the first iteration the value of our accumulator, which is 0 during the first iteration, plus our current value, which is 1. So after the first iteration, we will return 1. 1 will be stored inside of our accumulator, and now our accumulator value is 1. Let's keep going. Accumulator value for the second iteration is 1. Current value for the second iteration is now 5. Now again, we have our accumulator of 1, and to this accumulator of 1, we add our current value of 5, and therefore we will now return the value 6. So now the new accumulator value that we now store inside of our accumulator is 6. Now, for the third iteration, accumulator is now 6, current value is now going to be 10. We again add our accumulator to the current value, so 6 plus 10, and it will therefore be 16. So for the next iteration, we will add 13 to our accumulator, so we will have 29. Then we will add 2 to our new accumulator, 31, 4 to our accumulator, 35, and 29 to our accumulator, so 35 plus 29, which is 64. And this is essentially the result that we're getting right here. And since I know that to a lot of you this here looks a little bit confusing, I want to make this a little bit easier for you, because a lot of people under those circumstances use a slightly different version of brackets. But I will show you. So a lot of people just say numbers.reduce, then they call this method, of course, and for the first one they use an accumulator, so the previous value, and a current value. Then you can use the arrow syntax right here, like so, and then a lot of people just prefer to use those brackets because this here makes everything a little bit more readable. Because now you can always say that I want to return accumulator plus current value, like so. And now after those brackets, you have a comma and you initialize your accumulator with the value 0. I'm going to save this. And now you can see this here is probably a little more readable to a couple of you. So this here is the initial value. So the starting value for your accumulator. And for every single iteration, current value will hold one of those values. And now I could also have a different starting value for our accumulator. So maybe 100. And now let me console.log the result for you. And we're getting 164. Because now our accumulator will start at 100. And for the first iteration, our accumulator will get added to the current value of 1. Therefore, after one iteration, accumulator will be 101, then 106, and so on. So it works the exact same way, you just have a different starting value. So to summarize, you can always use the reduce method to reduce an array to a single value. Let me now introduce you to the Foreach method. And the Foreach method runs a function for each array item. So it's somewhat similar to the map method, but it's also slightly different. So imagine we have an array, so for example numbers right here, and that one is probably equal to the numbers 1, 2, 3, 4, and 5, like so. And now, similar to map and filter and reduce and so on, we can use Foreach by using the numbers array, so by accessing our array, followed by the dot notation, and then followed by the for each method name, like so. Now we use opening and closing brackets, and once again, we have to pass a callback function right here as an argument. Again, for every single iteration, we will get one number as a value right here. And now, when using the for each loop, we essentially can define what we want to do for each element. And therefore, the name is also for each. And something that we could do, for example, is just console.logging the number for each element. And now, once I save, you can see that we have all of those numbers in the console. Of course, I could also console.log num times 2, for example, or num times 10. So that is up to us. So I think you get the idea. For each just execute something for every single element inside of an array. So first of all, num will be 1 again. We're going to console.log the number times 10 for the number 1. So 1 times 10 is 10, and then the exact same for the other numbers. And that is all you need to know about the for each method. Let me now introduce you to the find method. And the find method returns the first matching value. Let me show you. Imagine we have an array of users. So const users is equal to this array right here. And inside of arrays, we can of course also store objects. So I'm going to store an object right here, like this. And now maybe the first object has a name, for example, or maybe a superhero name of Goku and a power level of 9000. Now we can duplicate this object twice. So every single object has the exact same structure. And the second one has the superhero name of Saitama, for example. That one has a power level of maybe 10,000. And for the last one, we have a superhero name of Spider-Man, for example. And here's a power level of 4,000, for example, like this. And now we can use the find method on arrays to find an individual item inside of this array, for example. So we can say users dot find like this. And now right here, it expects a callback function once again. And for every single iteration, it once again will give us one of the individual items inside of this array. So for the first iteration, we will get this object. Second iteration, we will get this object. And third iteration, we will get this object again as a parameter. And a common convention is that you call this parameter just user, for example. If you have users, or if you would have superheroes, this here would be superhero, because you get one individual item essentially out of all of the items. So user right here. And now I want to return a user. So I essentially found a user if user dot superhero name is equal to Saitama, for example. Oops, let me just copy that one. So Saitama. And of course I have to return this right here. And now we're essentially saying if the user dot superhero name, so the user superhero name of the current iteration is equal to Saitama, then we are going to return that one. Otherwise, we're not going to do anything. So for the first iteration, user will hold this object right here. So user.superhero_name is equal to Goku is user.superhero_name of Goku equal to Saitama. That is not the case. Therefore, we will not do anything. For the second iteration, superhero user will hold this object right here. User.superhero_name is therefore Saitama. is Saitama equal to Saitama? That is true. Therefore, we are going to return the second object. So we will return this entire object when using the find method. And now I'm going to save this, and I can store this inside of a variable. So this here will essentially return the found user. So the .find method returns the found item essentially. So const found user is equal to users.find. And now I can just console.log my found user, for example. And you can see we're getting the user that has the superhero named Saitama and a power level of 10,000. So this here seems to work. So the find method is really useful if you're searching inside an array for a certain object, for example. And that is something that you will do a lot in the real world when you work with a server, for example. So this is really, really important, even though it might not seem like that at first. So to summarize, the find method just returns the first matching value. And that is important. It's also important to know that it returns the first matching value. So even if I have Saitama right here once again, and here's a power level of 11,000 like this, or doesn't matter, you get the idea, it will only return the first match. So it will only return Saitama, who has a power level of 10,000. So afterwards, it will not even check anymore for the rest. Let me now introduce you to sum and every. And sum checks if at least one value matches, and every checks if all values match. So it's pretty self-explanatory. Imagine we have an array of numbers, for example. And maybe we have numbers 1, 10, 15, 35, 100. Doesn't matter. So I think you get the idea. And now, on this numbers array, I can use the sum method, for example. Again, I can use numbers like this, dot sum, for example. So this is a method. And this one again expects a callback function. And once again, for every single iteration, we will get one of those numbers. So num, for example. And now let's use an arrow function. And right here, it will return true if the following condition is true, for example. So right here, we can define a condition. So maybe num is greater than 15, for example, like this. And now let me just store the result. So const sum pass, for example, is equal to numbers.sum. And now let me just console.log sum passed right here. And we're getting true in the console. Let me get to 150 and we're getting false. So sum will always return true if at least one number fulfills this condition right here. And it will return false if none of the numbers fulfills this condition. So to summarize, sum takes a callback function right here. Again, for every single iteration, num will hold one of those values. So for the first iteration, this num right here will hold the number 1. It will check whether num, so number 1 right now, is greater than 15. That is not true. Therefore, we will return false essentially. And we will do this for every single number right here. And once this here matches for one number, so once one number is greater than 15, so it fulfills this condition, we are essentially having true right here, and sum passed will automatically be true at this point, because this condition only needs to be true for at least one number. So if I'm going to say greater than 30 or 40, for example, this here will still be true, because 100 is greater than 40. The other numbers don't fulfill this condition, but it's enough if 100 fulfills this condition. On the other hand, we can also check whether all passed by using the every method right here. So all passed is equal to numbers. So numbers.every, like so. Again, we will get one number for every single iteration. Of course, we again have to pass a callback function. So the syntax is pretty similar to sum, or pretty much the exact same. And again, we're going to return true if number, so num, is greater than, let's say, 100, for example. Now, let me console.log all passed right here. We're getting false, because not every single number passed. Let me also do something like 10, for example. We're still having false, because 1 didn't pass this condition, and 10 didn't pass this condition. So even if I'm going to do 9, for example, we are still having false because now 1 does not fulfill this condition. And once I go to 0, for example, we will get true because now every single number inside of this array is greater than 0. So 1 is greater than 0, 10, 15, 35, and 100. So I think you understand how this works. Sum will check if at least one value fulfills the defined condition right here, whereas every will check whether every single value inside of this array fulfills this condition right here. And that is important to understand. So to summarize, sum checks if at least one condition matches, every checks if all values match. Let me now introduce you to the sort method. And the sort method sorts array values. So imagine we have a couple of names, for example, inside of an array. So superheroes is equal to Goku, Vegeta, Saitama, and Spider-Man, like this. And now I can use the sort method to sort them. So superheroes dot sort, like this. And now let me console.log the result for you. So console.log of superheroes.sort. And you can see we're getting the superheroes sorted right here. So Goku comes first because G is first in the alphabet. Then we have Saitama, Spider-Man, and Vegeta last. So for names, it just sorts the names alphabetically. Now we can also sort numbers, and that is a little bit different. So let me, for example, create a numbers array. So numbers is equal to 1, 4, 10, 3, 2, 15, 100, and so on. Now let me console.log the result of numbers.sort, like this. And you can see it doesn't really work. So it somehow, first of all, takes everything that starts with a 1, 1, 1, 1, then 2, 3, 4. But maybe we only want to have the smaller values first, and then the bigger ones later on. And in order to do so, we can pass a callback function to the sort method. In order to do so, you often use a number A and a number B. And I will show you how this works in a second. But for now, let me just show you the result. And let's just return A minus B, for example. And you can see we're getting this order. So now it's ordered. So what is A and B? A and B are parameters. And every single parameter right here will hold one of those values for every single iteration. So during the first iteration, A will hold the number 1. So A is equal to 1, whereas B is equal to 4. Now we're going to subtract 4 from 1. So we essentially have minus 3 as a result. Because 1 minus 4 is minus 3. And since the result is negative, we know that 1, so parameter A, is less than B, and therefore this order is fine. And now, if this here would be positive, then we would know that the second number is bigger, so B is bigger than A, and therefore it would then change position of B and A. So it would essentially move B to the front and A right here to the back. And now we would go through this entire array and do this over and over again. So now for the next iteration, A is 4 and B is 10. Again, 4 minus 10 minus 6. Since we have a negative value as a result, A must be smaller than B, and the order is therefore correct. Now the same for 10 minus 3. This time we get a positive result. Therefore, A must be greater than B, and we should change order. So now 3 would be right here, and 10 would be right here. Now again, we would compare 10 to 2. 10 is greater than 2, so again the result would be positive. So we would have 2 right here and 10 right here. And this would go on and on. And now you see after one iteration, it's a little bit better. And at the end of the first iteration, the greatest number, so the biggest number, will be to the right. But this here is still not perfectly sorted. So you have to do this again and again. And after every iteration, you essentially can move one step further to the left. You don't have to understand this algorithm in depth, but it's important that by the end of this algorithm, all of those numbers will be sorted. So next iteration, this here is again fine, but this number here is less, so A will be 4, B will be 3, we get a positive number, and now 4 would move to the right, like so, and now this here would become 2, this here 4, and now this is ordered. So I think you get the idea of this algorithm. Again, you don't have to understand this perfectly. As long as you know this formula right here, this is perfectly fine. And if you want to have a reversed order, you just do B minus A, for example, like so. And now the greatest number is to the left, and the smallest number is to the right. So the exact algorithm that JavaScript uses right here to sort those numbers depends on the browser and the engine in the end. So the sorting method I showed to you is just an example, but that is something that allows you to visualize what is happening under the hood a little bit better. So the important takeaway is just that the sort method sorts array values. Let's now do a practice project together. And in this project, we will create a to-do list in the console. We first of all want to create a to-do class that allows us to create a to-do that has a title and a completion status. I also want you to add a function for adding, removing, and showing to-dos, as well as completing to-dos. We will store multiple to-dos inside of an array. Let's start by creating the to-do class that contains title and complete status. So we have a class, to-do for example, and we first of all have to define the constructor to construct our to-dos, like so. Inside of the brackets, we accept a title, like so. And now we want to say that this dot title is equal to our title, and this dot completed, for example, is by default equal to false. Later on, we also want to be able to set this dot completed to true. So we can create a function, or a method to be precise, that has the name complete to do, for example, like this. And inside of this method, we just say that this dot completed is equal to true, for example. So this is now the blueprint for our to-do. We now need to be able to create to-dos, so add to-dos. For example, to an array where we store all of our to-dos. So now we could say const to-dos is equal to an empty array by default, because by default we do not have any to-dos. And now we create a function to add to-dos to this array. So we have a function, for example, that has the name add to-do, opening and closing brackets, and those brackets for the body right here. And now to this to-dos array, we want to push a new to-do. In order to do so, we can say to-dos dot push, like so. And right here, we now need to pass our to-do. In order to do so, we could, for example, create a new to-do inside of the function by using the new to-do syntax right here. And now we need to have a title. We could accept this title as a parameter right here for the function. And now just pass this title right here that we accept as a parameter to our constructor method, which will then use this title to set this dot title to whatever we pass right here. So that is possible. And now we can just take this to do and push it to our to-dos array, so to this array, every time we call this function. And now let me just console.log to-dos right here. So to-dos, we are having an empty array at this point in time, but now I can call the add to-do function, and as a title, I could, for example, pass learn to code. I'm going to save this, and now we have one to do. That one is an object, and as you can see, completed is false, and the title is learn to code. So this seemed to work. We can also create multiple to-dos. So go gym, for example. Now we have two to-dos, and now the first one has a title of learn to code, and the second one has a title of go gym, for example. Next up, we want to add a function that adds the completion status of our to-do. In order to do so, we can, for example, use this complete to-do function on a specific index, for example. So function change completion status we expect to get a certain index. So at which index position inside of our to-dos array is the to-do that we want to modify. So we're going to use those brackets. We're now going to access to-dos of index. So if we pass, for example, 0 as an index, we will access the to-do at this index position right here that currently has the title learn to code and completed false. And now we are going to use the dot notation to access the complete to-do function right here that will essentially just set this dot completed to true, like so. I'm going to save this. Now let me use change completion status, and for the index I'm going to use 0, for example, so the first to do. Let me save this, and you can see now this one has a completed status of true, whereas this one should still have a completed status of false. I could also change the completed status for the second element by passing index number 1, and now we are having completed true and completed true. So change completion status now works as well. And now we also want to remove a to-do. So function remove to-do. Again, we have to accept an index. And for this, we need to learn about a method, an array method, that we didn't learn up to this point. And that one is the splice method. But it's actually not that hard. We, of course, have to access our to-dos array. And then on this to-dos array, we call the splice method. And right here, VS Code already gives you a suggestion what this method expects. It first of all expects a starting index and a delete count. As a starting index, we can of course use our index, so the index that we're expecting to get right here. And now, as the second argument, we have to define the delete count. And for us, the delete count will be 1 because we want to delete one element. Let me save this. And now, after adding those to-dos, let me, for example, just remove a to-do at index position number 0. This one should be learn to code. I'm also going to delete this here. And now we will delete the first to-do after we added that one. I'm going to save this one. And you can see we only have one to-do at this point. And that one is the go to gym to-do. So the second to-do that we've added. Because afterwards, we remove the first one, so learn to code. And I know this project can be a little bit confusing at this point, but I'm sure if you try it on your own, you will learn a little more about JavaScript in general and how everything works. And if you didn't understand everything up to this point, it's not that bad. You can just keep going and you will have a lot more time to practice and understand everything. Let's now understand the REST operator. And the REST operator collects multiple values into one single array. Let me show you how this works. So imagine we have a function, for example, to create the sum. So to add a couple of numbers, for example. So we have num1, num2, maybe num3, doesn't matter. And at the end, we're just going to return num1 plus num2 plus num3, for example, like this. And now I can always just use add numbers. I can pass my numbers, so maybe 10, 30, 45, and so on. Of course, I can now console.log the result of this function call. So console.log add numbers, and we're getting 85. But what if I now want to do the exact same, but I want to use 4 numbers maybe? As you can see, this doesn't work. It still prints 85 because it only expects 3 parameters. So isn't there the possibility to get a variable amount of parameters? And under those circumstances, we can use the REST operator. You can use the REST operator by using 3 dots, like so, followed by a parameter name. And that parameter name is up to us. So it could be this, could be this, it could be anything. But I'm going to use a descriptive one, so numbers. And now let me just console.log numbers for you once I call this function. So let's call add numbers like so, and let's, for example, use 10. You can see we're now getting an array that includes the number 10 right here. Let me add 10, 21, 30, or 24, for example, and so on. So now we have an array that contains those 3 numbers. So by using the REST operator, we can use as many numbers as we want, and all of those numbers will now be stored inside of an array. And of course, this here works for everything. This could also be fruits, this could be sports, and so on. So this doesn't need to be numbers. But then we would have to use sports, of course. And it might also make sense to then add, for example, sports, so basketball, football, and so on. But for us, let's stick with numbers. So numbers like so, because maybe we want to add a couple of numbers. So 20, 30, 40, and 50. And now we can use the REST operator together with the reduce method, for example, to add all of those numbers. So numbers dot reduce. Again, we need to pass a callback function. We'll have an accumulator and a current value. That one goes to, and if you see this symbol right here, this arrow symbol, you can also read it as goes to. So accumulator and current value goes to, and let's return accumulator plus current value, and let's initialize our accumulator with 0 like this. And this here has been formatted the wrong way, so it needs to be inside of a bracket like so. And now let me just print the result of add numbers like this. And of course, this function also needs to return the entire result. So there needs to be a return as well. And now we're getting 140, because 20 plus 30 is 50, plus 40 is 90, plus 50 is 140. So I think you get the idea. You can always use the REST operator to collect multiple values, especially if you don't know the exact amount of values that you want to collect, or have variable amounts of values every time you call this function. And then those values will be stored inside of an array, and you can access those values just the normal way you would access any array, essentially, in JavaScript. And then you can work with them the way you like. And that is all you need to know about the REST operator. Let me now introduce you to destructuring in JavaScript. And destructuring extracts values from arrays or objects, for example. So let me show you. Imagine we have an array that holds a couple of colors, for example. So const colors is equal to red, blue, and yellow, for example. But now I want to have those colors instead of individual variables. So I could, of course, say const red is equal to colors of 0, for example. Now I can console.log red, for example. And you can see we're getting red in the console. Now you would have to do the exact same for blue, for example. So colors of 1, like so. And now I could also console.log blue, for example. And we are getting blue in the console. And I think you get the idea. So this here would be kind of time consuming. And in order to fix this problem, we can use destructuring. So destructuring will extract the values in a much faster way from an array, for example. In order to destructure for arrays, we use those brackets right here instead of the variable name. And now we can just, inside of those brackets, define the variable names. So maybe red, blue, yellow. And now I'm going to use an equal sign. So again, pretty similar to a normal variable, I'm now assigning a value, and this value is equal to colors. And now it's essentially taking a look at colors. What is the first value? The first value is red. So we destructure this value into the first value that we have right here. So into the first variable that we have right here. So now red is going to be equal to red, blue is going to be equal to blue, and yellow is going to be equal to yellow right here. So the value yellow will be assigned to the variable yellow. Let me console.log red for you. So again, red is red, blue, and yellow. And now those variables right here have these values assigned to them. And of course, this could also be R, B, J, for example. So just a little bit shorter. Of course, this is bad practice because those names do not really express anything in a proper way. But I think you get the idea. So by destructuring, so by using this syntax, you can essentially extract the values of an array, for example, and store them inside of individual variables. And you can do the exact same for objects, for example. So I can have an object, so for example, a user object, which is equal to maybe a user that has a username of NPC and an age of 28 and an IQ of 40 and has big biceps of 100, for example, like this. And of course, I need a colon right here. Now, if I want to destructure an object, I have to use those brackets instead of those brackets. So now I can again define my variables, so const, and the rest is pretty similar. So again, instead of those brackets, I use these brackets to destructure an object. And now I just have to define the keys right here. So the keys need to match the keys right here. So for object destructuring, this here needs to be a username and cannot be something else. So it's really important that the key is the exact same. You can also destructure age and maybe has big biceps. And now this is equal to our user object, like so. Let me console.log has big biceps, for example. We're getting 100. I can also console.log the age, 28, and the username, and I'm having NPC. But maybe you want to rename those properties right here. So you first destructure, and then you can rename this by using a colon followed by the new name. So this can be anything. This could be this right here. And now let me console.log this right here, and we're having the same result. So if you want to rename, you use a colon followed by the new name. So this could be player name, for example. I'm going to console.log player name, and you can see this works. So you can just destructure it like this, and then the new variable name will be the property name that we used inside of our object, or you can define a new name after a colon, for example. So I think you understand how this works. So I can destructure arrays or objects in JavaScript and get the values from an array or an object and store it inside of an individual variable. And that is all you really need to know about destructuring in JavaScript. Let me now introduce you to the spread operator. And the spread operator expands arrays or objects. So let me show you. Imagine we have a numbers array like this. So 1, 2, 3, 4, 5, for example. And maybe now I want to create a copy of this numbers array. In order to do so, I can use the spread operator. So I'm going to say const new numbers is equal to, I'm again going to use an array, and now I can essentially spread those numbers right here from the numbers array into my new numbers array. So I'm essentially using 3 dots right here to access the spread operator, followed by the variable name. And this essentially says, take this array and spread this array right here. So essentially spread those numbers. So this syntax is equivalent to taking those numbers and spreading them in here like this. So this is what this essentially says. Like so. Let me now console.log the new numbers right here. And you can see this is the exact same array. So you can use the syntax to create a new array. But now you can also add other numbers. So I could say 100, 95, and so on. And now you have this result. So I first have 100, then 95, and then all of the numbers that you spread it right here. And you can also add some numbers right after, like so. And that is how this works. So the spread operator essentially takes something out of an array and spreads it at the position where you essentially use the spread operator. And now you can use the spread operator for objects as well. So imagine we have a user. So const user. Let's keep this simple again. So we have a username of NPC codes and an age of 28, like this. And now I have an updated user, for example, like so. And now I just want to copy or spread all of those key value pairs into my new object essentially. In order to do so, I can again use the spread operator like this. So 3 dots followed by the object name. I'm going to save this. I'm going to console.log the result of updated user. And you can see we essentially have the exact same object. The only difference is that it's of course a different object, but we have the same key value pairs. I can also add a biceps size, for example, right here. And you can see our new object now also has a biceps size, so our updated user. We could also add something like this smart, this is false, and so on. So I think you understand how this works. You can always use the spread operator, and then you essentially spread the properties or the values into a new object or into a new array. So that is how this works. So to summarize, the spread operator allows you to expand arrays or objects in JavaScript. Let's now understand error handling in JavaScript. When writing code, of course, there can always occur an error, and error handling prevents the code from crashing. Let me show you. Imagine you wanted to access a variable that doesn't even exist. So we're going to console.log npc, for example. npc shouldn't be part of this program because we didn't define npc anywhere. So we're getting an uncaught reference error. npc is not defined. And this error would now crash our program. Therefore, our program wouldn't execute anymore. So imagine afterwards, I wanted to say, or console.log, hello guys, for example. I'm going to save this, and we're never reaching this line, hello guys. So once the program crashes, nothing afterwards will be executed. But oftentimes, you want to execute some other code afterwards, even if there is an error. For example, if you try to connect to a server, essentially, it could happen that the server is currently down, for example, and then you will get an error. But under those circumstances, you, for example, don't want the entire program to crash. You maybe just want to output an error message and then do something afterwards. So a crashing program is never something that is good. You always want to handle errors in a controlled way. And in order to do so, you can just use a try catch block. Inside of the try block, you define what you want to try. And inside of the catch block, you define what you want to do in case there occurs an error. Let me show you. You always start the try block by using the try keyword. Then you have the body inside of opening and closing brackets again. And right here, I could, for example, try to console.log npc. I don't have npc right here. Therefore, this will not work. And in order to catch this error now, I should use a catch block right here. By default, JavaScript will always give us an error object that we can essentially accept right here as a parameter. And now I could, for example, just console.log the error like this. And now we're getting this reference error. Error is not defined. But you can see that the error message is already different. And the reason for this is that we're just console.logging the error object right here. We could also just say something went wrong. So wrong, like this. And now we're getting something went wrong in the console, but our program is not crashing anymore. And if I would now have another console.log statement afterwards, so hey guys, for example, we would see this statement in the console as well. So our program now tries to do this, but even if this doesn't work, we're just going to execute whatever we have in the catch block, and afterwards we are just going to keep executing our code the way we would do usually. So try catch blocks are really important to prevent your program from crashing. And now you can always, of course, also access this error object to get more information about the error, for example, as we've already seen, like so. And now something that you can also add to every try catch block, something that you don't have to add, but something that you can add, is a finally block, like this. And now you could always say, okay, it has been executed, for example. So this is just an example, but you will see how this works. So we're getting this error, but we're also getting, okay, it has been executed. And let me delete hey guys. So the finally block will always run. If this try block there is successful, this block will always run afterwards. And if you get an error, this block will also run afterwards. So finally will always run. Finally will always be executed. So in case you have something inside of your program that always has to be done, whether your code works or whether it doesn't, then it belongs into the finally block. So if I would now have, for example, const npc is equal to npc, for example, so now I have this variable, you can see we are now executing the try block and also the finally block. And of course, you can use try, catch for pretty much all sorts of things. But now let me also show you something else. Imagine, again, we have a try catch block. You can also, in VS Code, click on this try catch block right here, or statement to be precise, and then it will generate a basic try catch block for you, like so. I'm just going to delete all of this because I do not need it. I'll also delete this variable. And now imagine you're doing something where you have a couple of different possibilities. So maybe you have a number and that one can be equal to 10, for example. Now you're checking if number, for example, is not equal to 0. If that is the case, then you maybe want to say console.log 10 divided by number, for example. Because if the number is not 0, we can essentially divide 10 by our number. Otherwise, we, for example, want to throw a new error. Because usually, if I would just do it the normal way instead of JavaScript, like so, this division by 0 is not really an error. So let me show you. Right here, let me just console.log the error for now. Doesn't really matter. And at this point in time, we're getting 10 because 10 is our number, and 10 divided by 10 is of course 1. But now would say 0 though, we would now say 10 divided by 0, and we're getting infinity. So that is how this works in JavaScript. We're not really getting an error. And of course, this here is a pretty unnecessary example, but in the real world, from time to time, there exist things that will not really throw an error on their own, but maybe you want to throw an error under those circumstances. For example, if the user doesn't enter a password, for example, you want to execute whatever you define in the catch block. So you don't want to keep executing this try block. And under those circumstances, you could just say throw new error, and this will now create a new error, or create a new error object, and will immediately redirect to this catch block. And now you can also define an error message inside of those brackets. So this is wrong bro, for example. I'm going to save this, and now we are constantly logging the error, and as you can see, we're getting this is wrong bro inside of the console. So by using throw new error, you can immediately stop the code from executing and redirect to the catch block. So even if I would have something else right here, like this here will never get executed because throwing a new error will immediately redirect to the catch block. So from time to time, JavaScript will not throw errors on their own because probably the error is not predefined whatsoever. And then you can throw the errors yourself and therefore do whatever you have defined inside of the catch block. And this is something that is actually a lot more common than you might think. You could, for example, implement error handling, so maybe showing an error message to the user inside of the catch block, and every time the user tries to submit a form without having anything inside of the username field, for example, you could just throw a new error. You could, for example, say username is mandatory, and now right here you could, for example, inside of the catch block, just display the error message to the user, so username is mandatory, for example. Then you could do the exact same for maybe password is mandatory or required, and so on. So I think you get the idea. And of course, those are just examples. It always depends on the situation. So to summarize, error handling in general prevents code from crashing, and throwing a new error can always be helpful if you want to execute whatever you have defined inside of the catch block. Let me now explain JSON to you. And JSON is used to store and exchange data. If you think about data, so for example, about the data of a certain user. Imagine this user has a username, NPC, and a power level of 100,000, for example, and a sub count of maybe 1,300, like so. We now have this user object. But if you want to send data to a server, for example, so store data on a server, you will usually transform this data into something else and then store this data in a different way on a server. So later on, when you need this data again and receive it from the server, the data will of course also have a different format. So you somehow need to be able to transform this normal JavaScript object to something else that you can store on the server. So something that you can exchange with the server. And that is what JSON is used for. JSON stands for JavaScript Object Notation. And usually, before transferring data to a server, for example, you will turn this normal JavaScript code, so this JavaScript object, to JSON code essentially. Let me show you. We can create JSON data by using JSON.stringify. We have to pass as a value our object, and now this will transform normal JavaScript code, so a normal JavaScript object, to JSON data. I'm going to console.log the result of this for you, and you can see this is what we're getting. So this data looks really similar to a normal JavaScript object. But as you can see, it is also slightly different. If you take a look at our normal object, let me also console.log that one for you. So let's take a look at our normal user object. You can see we always have key value pairs. If we take a look at the JSON data, it also seems pretty much like key value pairs. So we always have username, NPC, power level, and so on. But if you take a close look at this right here, so at JSON data, the keys are always inside of quotation marks. So the keys are inside of quotation marks and the values are inside of quotation marks. So the text values are inside of quotation marks. Numbers, for example, aren't, but that always depends on the form of the value. But the keys are always inside of quotation marks. And that is a key difference to normal JavaScript objects. And JSON, of course, looks pretty similar to JavaScript, so to normal JavaScript code. And the reason for this is, of course, that JSON is just JavaScript object notation. So it is, in the end, pretty similar. You can also create JSON files yourself. And let me do it for you so you really understand how this works. So data.json, for example, the file name is of course up to you, but every JSON file ends with a .json extension. So now we created a JSON file. Usually you write JSON data inside of those brackets right here, so opening and closing brackets. And inside of those brackets, you can now define your key value pairs. So I could have a key username, for example, and the value for username would be NPC codes. You could have a sub count, that one could be 1300. And you could, for example, have a variable is broke, so a key is broke, and that one could be true, like so. So you separate each key value pair inside of JSON by using a comma, but the last key value pair doesn't have a comma. So that is the normal structure. And now this is normal JSON data. And usually when you send the data to the server, this is the form that the data will have. So this is what you will store on the server. Later on, when you want to get this data again, you will get this JSON data back from the server, and then you somehow have to convert this JSON data back to normal JavaScript code. So back to normal JavaScript objects. So that is the process. And let me also draw this for you so you really understand this. For example, if you have a user, he's accessing your website on a PC, for example, like so. And then on his PC, inside of his browser, he's running JavaScript, so right here essentially. And then maybe you want to store some data on a server, so on a web server, like this, for example. And a web server, in the end, is just a big computer, essentially. So even your own computer could be a web server, but usually the web server is a more powerful computer. But it's just important to know that any computer can serve as a server or as a client. But you will understand more about servers in my PHP course. For now, just remember that this is essentially your computer or the computer of your user, and this is a web server. So a server where you store data, for example. So user data maybe, or forms of data. That's up to you. And now you maybe want to store some data that the user entered, for example, on a web server. And in order to do so, you can convert the objects, so your JavaScript objects, to JSON code, and then you store this JSON code on the server. Later on, when you need to get this data back from the server, you will get JSON data back from the server. And of course, before storing the data on the server, you need to convert your JavaScript objects to JSON code, so you can store them on the server. And later on, when receiving the JSON code, you somehow need to go back from JSON code to normal JavaScript code, so to JavaScript objects. So that is the core principle. And now let me close this. So now we could create this JSON data by using json.stringify. We could store this data on a web server, for example, and later on, we might get this data back from the web server. So let me make something that is pretty similar. We're going to store this JSON data inside of a variable. So user JSON, for example, like so. So now we stored this JSON data inside of the user JSON variable. So console.log user JSON. This is what this currently looks like. So just normal JSON data essentially. But now I need to go back from JSON data to normal JavaScript objects, because later on, when I would receive data from the server, I would have to convert this JSON data back to normal JavaScript objects. So let me store this inside of a user object variable, for example. And now I can go from JSON to plain JavaScript by using json.parse. So this will allow me to parse JSON data. So I'm going to parse our user JSON variable right here that includes JSON data, like so. And now I'm going to console.log user object, like this. And now you can see this here is again a normal JavaScript object. I'm also going to console.log user JSON. So you see this side by side. And this here is now the JSON data, and this is our JavaScript object. So by using json.stringify, we can create JSON data. And by using json.parse, we can go back from JSON data to normal JavaScript data or JavaScript objects again. And that is really important, especially when working with servers. Because, again, if you want to store data on a server, you convert it to JSON data. And when receiving data from a server, for example, you will have to turn it back from JSON to JavaScript. And those are the most important things you need to understand for now. If you didn't get everything at this point in time, it's not that bad. I will explain this a lot more later on in this course. Let me now introduce you to callback functions. And callback functions are functions passed into other functions. What do I mean by that? Let me show you. So imagine we have a function to greet a user. And then we have a function that calls this greet user function. And that's a simple example that might not make too much sense at first, but it's really good to understand how callback functions work. So imagine we have this function that greets a user, for example. So greet user like this. And this one just console.logs hello bro, for example, like this. And now we have another function that calls this function. So function call greet user, for example. And this one now expects a function. So we say callback right here. And inside of this function, we're just going to execute our function. So our callback function like this. So we expect to get the function as a parameter. And then instead of the function body right here, we essentially execute this callback function. So now I can call greet user, so I can call the call greet user function, so this one, as an argument to this function, I pass the greet user function right here. And now I'm going to save this. And you can see we're getting hello bro. I could, of course, also create another function, for example, to insult the user, for example. And now I could console.log you are dumb, for example, like this. And now I can call the call greet user function and pass greet user to this function, but I can also pass insult user to this function. And now one time we are greeting the user and the other time we are insulting the user. So depending on which function we pass, we get a different behavior for a call greet user. So that is the basic concept. And this here might seem unnecessary at first, but under the hood, instead of JavaScript, we use callback functions all the time. If you remember the map method, for example, so let me show you. Const numbers 1, 2, 3, and 4, numbers.map, for example, you can see that Visual Studio Code already indicates that this here is a callback function. And indeed it is, and it also makes sense because right here we are just passing another function to the map function. So right here we just pass this function to the map function and, for example, say that we want to have num times 2. So this here is just a function inside of another function call. So this here is a callback function. And even without knowing, you will use callback functions a lot. And that is the basic principle about a callback function. So to summarize, callback functions are just functions passed into other functions. Let's now understand promises. And promises handle code that finishes later. So essentially code that will finish in the future. And it is somewhat similar to tasks, for example, in the real world that finish in the future. If you think about an order at a restaurant, for example, you're going to order, the waiter is going to take your order, and in the end, he will either accept the order or he will reject the order. So you're either going to get the pizza or you're not going to get the pizza. So one of those two cases is going to happen. And a promise is pretty similar. You want something that will happen in the future, and in the future, this will either be accepted or it will be rejected. And depending on what case is going to happen, we can define, using JavaScript, the code that should be executed. And let me just show you how this works, because this is probably a little bit easier. So I'm going to create an order pizza variable right here, which is equal to a new promise, like this. So by using this syntax, we can create a new promise. Inside of this promise, we can now again pass a callback function. And by default, JavaScript gives us a value for resolve and for reject. So the first one is resolve. So the first parameter that we can get is resolve. And the second one is reject. And you will understand this in a second. Right here, as a callback function, we of course pass an arrow function like this. And now we are going to have a variable inside of this function essentially. And that one can have the name let order successful, for example, be equal. And for now, let's say it's equal to true. So the order has been successful. We essentially got our pizza, for example, like this. And maybe pizza available is a more descriptive name. And now we can check if pizza is available. So if we did get our pizza, then we can essentially call this resolve parameter right here, like so. And this again is just a function that we can call, and we can also pass a value. So your order has been successful, like so. If the pizza is not available, so else, we can reject this right here and say your order has been declined, for example, like this. And by taking a look at this, you already understand how a promise works. We can create a promise by using the new promise keyword. And if you take a look at this, this here is pretty similar to the normal constructor that we call when creating an object. And in fact, in JavaScript, most things are objects, so this also makes sense. So right here, we are just creating a promise object. This promise object expects to get a callback function as a parameter. And right here, JavaScript allows us to access the resolve parameter and the reject parameter inside of our callback function, like this. And whenever we do something that should resolve our promise, then we can use the resolve function right here and pass a message to this resolve function. And whenever we want to reject the promise, essentially, we can use the reject function and pass a message right here. So promise essentially says that we promise that in the future, the result will either be resolved or rejected. And in the future, so right here, for example, we are going to say that the promise is now resolved. And right here, in the future, we are saying that the promise right here is rejected. So that is how this works. And I will also show you a better example later on. But for now, just remember that a promise is something that you can use if the result is not available at the moment. And only in the future, it will either be resolved and rejected. And we can define what we want to do for both circumstances. But of course, right here, we only define a promise. We also need to call a promise. And we can do so by calling order pizza like so. And then you can define a then block right here. This one again is a function. And inside of those brackets right here, we can now again define a callback function. And again, let me do this first of all, and then you will understand this. Right here, I'm getting the message like so. And let me just console.log the message like this. And now we can also chain the catch method right here. And right here, we are getting an error. And we can just console.log the error for now. As you can see, your order has been successful. If we now set pizza available to false, your order has been declined. So this seems to work. But now let me explain everything to you step by step. Right here, we are defining the behavior of our promise. So we are saying that we want to create a new promise. We also define the conditions if a pizza is available, so that we will resolve the promise if a pizza is available. And we also define the other condition, so that we will essentially reject the promise if a pizza is not available. Right here, we're essentially executing the promise. We're executing this promise, and since pizza is available is equal to true, we're jumping into this if condition right here when executing this promise. And right here, we are resolving this promise. And resolving this promise will then redirect us to the then block right here. So right here, we only define the conditions for this promise, and the actual things that we will do later on when resolving this promise will be defined within the then block, and when rejecting the promise, the actual things that we're going to do later on will be defined inside of the catch block. So right here, I could also say hello, for example, and now we will print hello every time we resolve this promise. And right here, I could, of course, also just print error, for example, every time we reject this promise. And now this will be the behavior. So again, instead of the new promise statement right here, we always define the behavior, and the actual things that we will do later on will be within the then block and the catch block. So right here, we essentially just, when calling resolve, say, execute the then block. And right here, when we reject the promise, we essentially just say execute the catch block. But this is not really the most practical example. And for now, I really want you to understand the basics. It's not really important for you to memorize this. It's important that you understand the concepts, because later on, we will use a different syntax anyways. So it's only important to understand that this here is something that will only happen in the future. When resolving the promise, we redirect to the then block, because this here is the future essentially, or we reject and redirect to the catch block. So this here is also the future. Those things right here will not happen instantly. And something where you use this, for example, is a server call. So maybe you want to get data from the server. And why is that something that will happen in the future? If you think about your connection to a server, you maybe want to get data from a server. So you're going to ask the server to get data. Asking the server takes a little bit of time because, of course, you have to send data via cable, for example, so through the internet. And this connection, of course, takes a little bit of time. Then the server has to process your request. It will decide what the response is going to be. Then it will send the response through the internet, which again takes a little bit of time, because in the end, information cannot travel faster than light, because oftentimes we transfer information via light, and nothing is faster than light. So it will at least take the amount of time that the light needs from your PC essentially to the server. But that's a little bit technical, so you don't even need to understand this. The only thing that is important is that sending the request to a server will take a little bit of time. Then processing your request will take a little bit of time for the server. So the server also needs some time to process your request. And then sending the data back to you will again take a little bit of time. So when sending the request to the server, maybe you want to get the profile of a certain user, takes a little bit of time. And you know that you will only get the response in the future. You will not get the response when sending it immediately. So there is essentially a delay between a request and response. And that is important because that is something where you can use a promise. You send a request to the server, and the server essentially promises that you will get the data in the future. And if you think about a server example, for example, you essentially create a promise. You then, for example, say, if the server responds with a positive response, for example, we're going to resolve this promise, and therefore we are going to redirect to the then block and execute whatever we defined inside of the then block. Otherwise, if the server rejects our request, for example, we want to redirect to the catch block and execute whatever we defined right here. So this is essentially how this works. And now I will also show you this real example with a real server, for example. So then you might understand this a little bit better. So let me now show you a real example in the real world where we work with an API to get some data. And let me explain all of this to you by using a real example. So by using an API, for example. In our case, let's go over to Google and let's search for Pokemon API, for example. Right here, we're having the Poke API like this. I'm also going to maximize this window. And now you can see that this here is the link to get a connection to this API. So I'm just going to copy this entire thing right here. I'll paste this into a new tab so I can show this to you and explain this to you. And as you can see, this here's what we're getting. And this is essentially JSON data. So we already took a look at this. So this here should also be familiar to you. Let me make this a little bit bigger. So you see we have those key value pairs essentially. So this here's the key, so abilities, and the value is an array for abilities essentially. So what exactly is an API? If you think about your computer, for example, you're oftentimes running programs on your computer. And if you think about a server, I already told you that a server is actually just a normal computer. Usually it's a little more powerful. So usually a server is a computer that is pretty powerful. But that's most of the times the only difference between your computer and a server. But a server can also be a bad computer. So that's not really something that has to be like that. It's just something that usually is like that, because a server oftentimes should be a little bit more powerful to process all of the requests. But again, a server in the end is just a normal computer. And on this server, you can run a program. On your computer, you can also run a program. On the server, you might have slightly different programs, for example. So maybe on the server, there's running a program that, for example, processes your requests and then responses with the necessary data, for example. So maybe you're asking the server to get some data, for example, to get some user data. So for example, load a user that is currently logged in. Then you send this request to the server, and the server will reply with either the user data, or it will reply and say that you don't have access to this data, for example. And an API is an application programming interface. But in the end, it's essentially just a computer program that you're talking to. So you don't really have to memorize this complicated name. But the thing that you have to remember is that an API is just a program on another server, for example, that you're talking to. And this right here is an API, because right here, you're essentially sending a request to this API right here to get data. In our case, we want to get data about a certain Pokemon. So in our case, the Pokemon Ditto. And essentially, an API also has an address. So if you think about your house, for example, you also have an address. You have a street and you have a number. A URL is pretty similar to your house. It's just the address of an API. So maybe you're living in a certain street and have a certain house number, and this API right here has a certain URL. So the address of this API is essentially pokeapi.co/api/v2/pokemon/ditto. And by entering this URL in the browser and pressing enter, we are essentially sending a request to this API, so to this program. This program will then, on the server, so not on our computer, but on the server, try to process our request essentially. It will decide whether our request has been valid. And if the request has been valid, it will send a response. And as a response, we're getting this data right here. So that is the data that the server sends us once we request the data. Of course, the server could also reply and say that we don't have access to this data. But right here, we have access to this data because it's an open API that essentially shares its data with pretty much everyone. So by using this link, we can access the data from this API right here. And this data is just some JSON data. So later on, we already learned that we can turn this JSON data into normal JavaScript objects, for example. And of course, if you take a look, once I copy, paste this link in here, and I'll press enter, you can see that it loads for a very short time. And that is the time that it takes for the request to get to the server, to be processed, and then for the server to send the response. So that is the time that it takes for our promise to either resolve or reject. But let me actually just close this for now. Let's go back to our website. And let me just show you a real example right here. Like this. Let's go to the console. Let me just delete all of this, like so. And now, if you want to do a request to a certain API, like the Pokey API, for example, inside of JavaScript, you will always use the fetch method. So we can just use fetch right here. So that is a built-in method that the JavaScript team provides for us to, for example, ask an API for some data. And now we can, within those brackets, insert an input, like the URL right here. And now this will send a fetch request to this API right here. I'm going to save this. And now let me also just console.log the result of this, console.log fetch. And you can see we're getting a promise that is currently pending. But right here, you also see the promise state. So it is now fulfilled already. The promise result is a response right here. So we can see all of those things right here if we console.log our promise. So as you can see, this here just essentially sends back a promise. And now we already know from before that when we get back a promise, that we can always use then and catch, for example. Previously, we created this promise ourselves by using the new promise syntax, but usually you will not really do this. Usually things will just be a promise on their own. So this here is a promise already, so we don't have to create a new promise by using the new promise keyword, of course. And the promise will automatically either get resolved if the request has been successful, or rejected automatically if the request was not successful, essentially. And therefore, we can immediately just use then right here and decide what we want to do when the promise is fulfilled. And we can also chain the catch block right here and decide what we want to do if the promise has been rejected. Right here, we expect to get a response, for example, like so. And let's pass an error function. And for now, let me just console.log the response for you so you understand how this looks. And you can see this here is our response. This response is essentially an object that includes a body, headers, OK status, redirected, a status, and so on. And status code of 200 means OK. So the request was OK. So successful, essentially. But again, those things will be explained a lot more in my PHP course. For now, you just have to know that this response essentially gives us an object. On this response object, I can also access .json, like so. So I can use the .json method. And now you can see that we're getting another promise. So when using the fetch method, we're getting back a promise, which will then get resolved. So we're either going to call the then block, or it will get rejected. So we're going to call the catch block. But then, once we use response.json, this method right here will return another promise. So we first have a promise, and this here returns another promise. So we essentially have two promises in a row. First of all, this promise will get resolved, like so. And then we somehow also need to resolve this promise for response.json, for example. And under those circumstances, we can chain then blocks. So we need another then block right here. We should also return response.json right here. So that is also important. And right here, within the second then block, we then get the data. So let me console.log the data for you, like so. And now we're getting this data. And this data is just a normal JavaScript object, essentially. So we can just access this object the way we would pretty much access any normal object. So we can, for example, access data.name, for example. And now we would get D2, as you can see, because we, for example, have the name property right here. We can also access the order number, so 214. So once I'm going to access data.order, we will get 214 in the console, as you can see. I can also catch an error, for example, and say if I have an error, I'm just going to console.log the error, for example, like so. And now let me, for example, do this request to an invalid URL. This will take a short time, and then we're getting this error, 404. And 404, you probably know that from websites. 404 means not found. So this source there has not been found. I'm going to get the original state, it works again. And essentially, using the fetch method together with response.json and then data later on is something that you essentially just have to remember. That's just the way the web works, and pretty much any API call will work. Every time you request data from an API, you will first get this response right here. Then you will call response.json to transform the JSON data to an object essentially, and this will return another promise. You can then chain another then block, and right here you will then get the data once the promise has been resolved essentially. And now you can do pretty much anything you like with the data. So you could also store this data, or you could just log it the way that we did it right now. And I know this here can be a little bit confusing in the beginning, but once you did this once or twice, you will definitely just remember the syntax. And as I mentioned, pretty much every API call is the exact same. So you will just remember this pattern. And we will also learn about an easier way in the following lectures. So don't worry about it. I only want you to understand what a promise is, that it will be resolved or rejected at one point in time. And right here within the then block, you just define what you want to do once the promise is resolved. And in the catch block, you define what you want to do if the promise is rejected. And that is the most important stuff that you need to know about promises. So promises just handle code that finishes later, so in the future essentially. Let's now understand async and await. And async and await make promises easier to read. So essentially everything we did up to this point by using then and catch and so on can be replaced by using async and await. And they make everything a lot easier, and this is also the recommended modern syntax. So you should always use async and await, but understanding the core principles behind async and await, so promises in general, is nevertheless important. So it's important that you at least understood the concepts that we covered up to this point. If you forget how to implement then and catch and resolve and reject later on, it's not really that bad. So let me now implement our API call, for example, using async and await. So maybe we want to create a function to fetch data. So const fetch data, which is our variable, is going to be equal to this arrow function right here. And this here should be data. Or actually we can also say fetch Pokemon, because that is a little more descriptive. Now we want to use a try catch block right here, because every time we call the server, there can occur an error. And we want to catch this error inside of the catch block. So let's just console.log the error inside of the catch block, like so. And now inside of this try block, we can fetch the data. So again, we're going to use the fetch function that JavaScript provides, and we'll send a request again to this API here, so to this URL, like so. And now, instead of using .then, for example, and .catch, we can just say that we're going to await this right here. And await essentially means that we're going to wait for the result. And once the result is there, we can do pretty much anything we like with the result. And in our case, we will store the result, so the response, inside of a response variable, like so. So right now, let me go back to this page right here. And right now, we're just storing the response that we'll get at a certain point inside of this response variable. But you can see we're getting this error right here. So wait is only valid inside of async functions. So every time you use a wait inside of a function, you just have to mark this function as an asynchronous function. Because of course, now it's not synchronous anymore. It's asynchronous because fetching data takes a little bit of time. You send a request, you wait for a short time until you get the response. So remembering this is pretty simple. every time you have to wait for something because it's asynchronous. So the task takes a little bit of time. You use await. And if you use await inside of a function, you have to use async in front of those brackets right here. So you have to mark that function as asynchronous. Now again, I can, for example, console.log the response for you again. And now let me also call this function, so fetch Pokemon. So I'm going to execute it. And you can see this here is the response. Now let me also log response.json for you. Again, this is a promise. So now I can again say that I want to store the result of this promise instead of the variable data, for example. And since this is a promise, we can again await the result. And now we can store the result instead of data. Let me now console.log data for you. And you can see we have the same result that we had previously. So we're getting all of this data right here. The only difference is that this time, every time we expect a promise, we can just use await. And the try catch block will do the error handling for us. So we don't need then and catch. And this here is a lot better and a lot more readable. So that is the modern way to write the exact same. So to work with promises. And again, you should usually always use async and await when working with promises these days. So this here is the modern way. And something that I didn't really explain at this point is what exactly this .json method right here does. So usually, when we're using the fetch method, we're getting back a promise. And in the future, this promise will be resolved or rejected. So by using await, we're saying wait for the response. And once you have the response, store it inside of this response variable. And then we take our response and use response.json, which again creates a promise. And once this promise has been resolved, we store the result instead of data. And the .json method right here that we can call on the promise object essentially will just transform this JSON data, which we're getting right here from the server, into a normal JavaScript object. So .json turns JSON data into a JavaScript object so we can use it instead of JavaScript. And understanding that is really important. So this here is just a normal response that we get from the server, but we cannot really use this response at this point. In order to use this response, so this JSON data, we have to call response.json, which again is first of all a promise. And once response.json is resolved, it will hold the actual data. So we can store this data instead of this data variable, for example. And this data is then the data that we can work with. But just test this out yourself, and I'm sure you'll understand this. And that is all you need to know about async and await. So async and await make promises easier to read. Let's now have another practice project. And now I want you to create a random user generator. So I want you to use an API that creates a random user every time you send a fetch request. And then I want you to send this data or to log this data in the console. So log it and make it look somewhat alright. And that is your task. So feel free to try this on your own. And once you're done, you can come back and take a look at my solution. So let's get started. So first of all, I'm going to go over to Google and I'm going to search for a random user generator API. I'm just going to use the first link. I'm sure there are other ones that you can use as well, but I will use this one. Let me maximize this window. And you can see we now got this person right here. So I'm going to reload the page. We're getting Ellie or Brian. I'm going to reload. We're getting another one, and so on. And now let's scroll down. And right here, you can see how to use. And we can just copy this URL at this point in time, because this here will allow us to get the data from the API. So let me open a new window. I'm going to paste this URL in. And you can see we're getting the data as JSON data. So right here, this is a JSON object, if you want to call it like that. Well, it's actually just JSON data. And inside of those brackets right here, we have result, for example, gender, female, name, and so on. So all of that stuff that we might be interested in. So phone number as well. So all of the things. And now we want to get this data inside of JavaScript. Let me get back to the original view. And now let me create a function to get the random user. So const get random user is equal. Again, let's use an arrow function right here. And we have a try catch block because we're going to call a server. And every time we're going to call a server, so make an API call, there can of course occur an error. And in case we're getting one, I just want to log it for now. Now I also want to fetch data, so I use fetch, and as an input, I will use this URL. We have to await this because this here is an asynchronous request that will take a little bit of time. And now I'm going to store the result inside of a response variable like this. So this is now what we're getting, but since we're using await, we also need to mark this function as asynchronous. And now let me call this function for now. So get random user like so. And I'm just going to console.log the response for now like so. This is the response. But at this point in time, we cannot really use it. So I'm going to use .json on our response to turn this JSON data into a normal JavaScript object. And then I will store the data inside of the data variable like so. Let me now console.log the data that we're getting from the server, so from the API. And at the moment it's a promise. We need to await this here, of course. And now we're getting this result. And now if we open this object, you can see that we have a couple of key value pairs. We have info, we have results, and so on. And actually we probably want to get results right here. So I'm going to access the results key, so data.results. And I can do so because this is just a normal object. Now I have this array, and inside of this array, I have a lot of stuff inside of the first cell essentially. So at index number 0. So let me access this array by using index number 0. And now this is an object once again. And now I could, for example, access the gender, I could access the email, and so on. So let me, for example, try to get email like so. And this is the email. And now I can, of course, also format this by using backtick characters. Let me go into a new line like this. And now I can, for example, say email : like this. So email, and email is going to be whatever we have right here like this. You can see this here is the email that we're getting. Let me just duplicate this line here a couple of times. Let me also try to get gender, for example. If I remember correctly, this here was gender, like so. So now gender is female. Let me remove this white space, like so. And the same right here, like so. And right here, I don't know, maybe there also exists something like name. Let me test this. Otherwise, I have to take a look again. Actually, there does not exist something that is called name. So let me take a look at the array again, like this. And actually, let me just go back and use another console.log statement. And now we're getting this right here again. And maybe I can use something like, maybe the phone number. So .phone. And now we're having the phone number as well. Let me delete this here again. Let's have phone right here. And you can see now this here is formatted properly. And you can see now we essentially got the data from an API. And now we use this data that was inside of an object and displayed it inside of a console.log statement. And this here is essentially just accessing objects and arrays the way we would do usually. I know this here can look a little more confusing if you take a look at it like this, for example. So data, but under the hood, this is just an object. You open this object, and now you see that this object has the keys info and results. So we could access info by using .info the way we would do usually, but you can also use results like so. And now we can access results. And if you take a look at results, you see that this is just an array and it only has one single element. So only index number 0. How can we access an array? We can access arrays by using the index right here. So again, we're just accessing an array the way we would do usually. And now you can see that this is just an object. How can we access an object? Again, we can just use the dot notation. So we could access, for example, DOP, email, gender, ID, login, name. So I think you get the idea. We can access all of those key value pairs again. And if you would, for example, access name now, so dot name, you will see that name is just another object. So it's essentially an object inside of an object. And now, inside of this object, you could also access dot first, for example, or dot last, or dot title. So all of those properties as well. So this here looks confusing at first, so the data object, but in the end, those are just objects nested within one object, or arrays nested within our main object, so the data object. So in the end, you can just access all of those data points essentially by just using the normal way to access objects and arrays. So that is important to understand. And once you understand this, it becomes a lot less confusing. And that is all you have to do to solve this random user generator project. Let's now understand the strict mode in JavaScript. And strict mode just catches common JavaScript mistakes. Imagine we're having a variable, user for example, and that one is equal to npc. I'm now going to console.log our user like this. And you can see we're seeing npc in the console. But the problem is that this is not really good practice. Usually, when defining a variable, you always want to use the const keyword or the let keyword, like so. But without using const or let, this is not really good. And now we can just say that we want to use strict mode by typing use strict right here. And you can see, once I say use strict, I'm getting an uncaught reference error. User is not defined. So use strict essentially enables strict mode, and the strict mode is just a little bit stricter. So this here will cause an error. Well, under normal circumstances, this here would somehow work, even though it's not really valid to be honest, but it would go through. So the strict mode will essentially throw errors a little bit earlier. And oftentimes you want to do this because this will essentially prevent a lot of problems because you will just catch them a little bit earlier. So right now, I would probably have missed this problem right here without using strict mode. But now that I have strict mode, I know that this here is actually not that good. So I can just add const right here, and now it works. So if you want to catch your mistakes a little bit earlier, you can always use strict mode. Let me now introduce you to the call stack and to the event loop. The call stack runs normal code first, and the event loop runs asynchronous code later. So let me show you what I mean by this. And in order to really understand this, I first of all want to introduce you to two functions, to set interval and to set timeout. We can, for example, use the built-in set timeout function that JavaScript provides. And right here, we can, for example, as a first argument, define a callback function once again. And I can, for example, say console.log 1 second pass, for example, like so. And now right here, after a comma, I can define the timeout. So how many milliseconds should pass up to the point where we execute this code right here. And in our case, let's say 1000 milliseconds, so essentially 1 second. And now you can see, after 1 second, we're getting 1 second passed. I can also use 2000 milliseconds, and now we will get 1 second passed after 2 seconds. So this here should of course be 2 seconds passed. And I think you get the idea. Set timeout just sets a timeout, and after that duration passed essentially, we will execute this line of code right here. And this here is of course asynchronous code, because at runtime, we will not execute this code immediately, but we will run this code, and then we will wait for 2 seconds and execute this line of code later. So it's again asynchronous. And set interval is pretty similar. The only difference is that set interval executes something inside of different intervals or specific intervals. So I could say 1 second passed once again, like so. I'm going to define a time of 1000 milliseconds, so 1 second. And now after 1 second, we're getting 1 second passed, 2 seconds passed. So 2 seconds passed is our set timeout function. and now we're getting 1 second passed over and over again. So after every second, set interval will execute this here once again. And both of those functions are asynchronous, because once running this code, essentially, it does not happen immediately. It takes a short time, and then the code runs. So similar to a server call, set timeout and set interval are asynchronous. And that is important to know for the following thing that I want to show you. Because now I already mentioned that code will run from top to bottom. So imagine I have a console.log statement here, and this here says first, for example. Right here, I'm going to say second, and now right below, I'm going to console.log third. So if you remember what I said previously, this here should run first. Then we're going to run this and wait for 2 seconds, and then we should see second in the console, and this here will run last, and we should see third in the console. So let me save this and show you how this really works. And you can see first comes first, third comes second in the console, and second comes last. So why is that? The reason for this is the call stack and the event loop. So it would be kind of bad for a program if you would have to wait for every single timeout. So imagine this here would be 10,000 or 100,000 or 1 million, it doesn't matter. Just imagine this here takes a long time, essentially. And sometimes server calls can also take a long time. It would be really bad if the program would literally just stop and wait for this to finish, because then nothing afterwards could happen. And a lot of stuff right here should, for example, happen, especially if this call takes a lot of time. And because of this, we have the call stack that runs normal code first. So this here will get executed immediately, and this here will get executed immediately, and this here will get added to the event loop. And the event loop will always take a look at the events. It will keep them into consideration, and once this time passed, essentially, it will get back to our program and pass the result to our program. So this here will be passed to our program once the result exists. But before that, we're literally just going to pass this entire thing right here to the event loop. So the call stack can keep going and keep executing whatever we have afterwards. So that is the non-blocking nature of JavaScript. Without this non-blocking nature of JavaScript, we would have to wait for this here for pretty much ever. And that would of course be bad behavior. So the call stack will always run the normal code immediately, and the event loop will handle all of the asynchronous code and then get back with the result and give us the result once the result exists. And we can also see that if we take a look at our fetch request that we did previously. So let's take a look at the Pokemon API once again, for example. Let's just click on this link right here, and let's again copy this one. And now let me go back to the document, and let's now, for example, fetch something once again. So I'm going to have a response, for example. That one is equal to await, fetch. Let's just fetch whatever we have from this URL right here. So await is only valid instead of async functions. So we need to use a function or create a function. We can do so by saying const fetch Pokemon is equal to an asynchronous function. We're going to create that one. We will have a try catch block in here. For catch, I'm going to console.log our error, and right here, I'm going to wait for my response. And now let me just console.log my response, and you can see, I also have to execute this, of course. So now let's execute this function, and you can see we're getting first, we're getting third, and only afterwards we're getting the response. Because again, this here is asynchronous. Calling a server takes a little bit of time, and up to that point, we already finished first and third, and later on, once the result exists, so once this response here exists, we are going to see that in the console. So the event loop will give us that result once it exists. And that is something that is really important. You don't really have to think too much about it because it will happen under the hood anyways, but knowing the principle is kind of important. And that is all you need to know about the call stack, which runs code immediately, and the event loop, which will give us the result once the result is there. Let's now understand hoisting. And hoisting moves declarations to the top before the code runs. Let me show you what I mean by this. Imagine we are creating a function, greet user, for example, like this. And this function should just greet a user. Therefore, we can console.log, hey, hope you are doing good, for example, like this. And now, maybe I'm going to call this function right above the declaration. So greet user right here. And you can see this here works. So hey, hope you're doing good. And the reason for this is hoisting, because hoisting essentially moves declarations to the top before the code runs. So under the hood, JavaScript takes this declaration and moves it right here to the top, like so. And therefore, this will work. So to be precise, this here works, because under the hood, it looks like this instead of the real code. And that is all you need to know about hoisting. Let's now understand the temporal dead zone. So as already mentioned, declarations will be moved to the top. So if I'm going to say let age be equal to 28, and I'm going to console.log our age right here, according to hoisting, this here should work. I'm going to save this, but you can see we're getting an uncaught reference error. Cannot access age before initialization. So this right here is what you call the temporal dead zone. So for variables, they somehow get hoisted, but you cannot really use them before you initialize them. So you shouldn't do it like this. For variables that use let and const, you should always initialize them first and only access them afterwards. So for functions, it's actually kind of alright if you use them before declaring them. But for variables that use let and const, that doesn't work. So understanding the temporal dead zone is also kind of right. But I'm going to be honest, understanding the temporal dead zone and hoisting is kind of alright, because now you somehow know a little more about JavaScript. But in the end, I always recommend you to structure your code in a logical way, which means even though you could, for example, declare a function and call it before declaring it, I don't think that it makes too much sense. Usually, you would always declare your function first in a well-written program, in my opinion, and after you essentially declared it, you can call it. So if you write your code like this, I think it's more readable, and it's actually also a little more intuitive. So I don't really see why you would want to call this function here before declaring it. But again, understanding how JavaScript works is kind of nice from time to time. Let's now take a look at modules. And modules let us split code into different files. So imagine we want to have one file for maybe math operations, then we want to have one file for maybe greeting the user, and then we maybe want to have another file for, I don't know, calculating the power level of superheroes, for example. So I think you get the idea. You maybe want to code your JavaScript code into different modules and then access one module from another module, for example. So maybe instead of the module where you want to calculate a superhero's power level, you might need some math functions. So you want to access those math functions instead of that module, for example. And let me show you how this works. So imagine we have a math function right here, like calculate sum. We're getting num1 and num2 like this, and we're just going to return num1 plus num2, for example. How can I now access this function right here inside of another module? I can do so by using the export keyword right here. And you can see I'm exporting this function, but I'm also getting this uncaught syntax error, unexpected token export. And the reason for this is that this here, so our index.js file, is currently not a module. In order to declare something as a module, we have to go to our index.html, and right here, we have to declare our script tag as a module. So we have to define this here as a module in general. I can do so by using script module, as you can see, instead of VS Code. And the only difference is that you write here at a type being equal to module, essentially, to the script tag. You should, of course, also have the defer attribute and the source, which is index.js. And now you can see that this warning, or this error to be precise, is gone, because now we declared this script tag right here, so this file right here, as a module. So if you want to use a JavaScript file as a module, you always have to declare it as a module by using type equals module. Now I can go back to my index.js, exporting this function here works, and now I could import it inside of another JavaScript file, for example. So let me create one. I could say this here is whatever.js, like so. And now let me also include this whatever.js file instead of my index.js by just adding another script tag of type source. This here points to our whatever.js file. I'll again use the defer attribute right here. Let me test whether this works by just console.logging hey. We are getting hey in the console, so this works. And now I need to import the previously exported function from our index.js file. So right here, we exported calculate sum. And now within my whatever.js, I need to import this function, and then I need to access it. I can import a function by using the import keyword. Now instead of those brackets right here, I can define the function name, so calculate sum. And now I need to define the path. So I'm going to import that from, and now I want to get this function right here, so calculate sum from ./index.js. So from our index.js file right here. Let me save this. And you can see again, we get this error right here, cannot use import statement outside a module. So again, let's go to our index.html and let's add type equals module right here. The error is now gone. And let's go back and let me just call calculate sum right here. For num1, I'm going to use 100. For num2, maybe 200. And we're not seeing anything because we of course need to console.log this right here. So console.log calculate sum, and we're now getting 300 in the console. So now we exported this function right here instead of our index module, so instead of this JavaScript module, and we imported it later on instead of our whatever module. And then we can access this in any way we like. And understanding modules when splitting your code in JavaScript can be really important because it allows you to essentially group all of your functions and your functionality, objects, and so on instead of different files. And then you can access one file from another file and have everything logically separated. And especially when you have extremely big projects, for example, or also bigger projects in general, this is a really important concept because it allows you to stay organized while writing organized code that also stays maintainable for a long time. And also for other developers, it's probably a little bit easier if you have one module for math functions, for example, and so on. So I think you get the idea. And that is all you need to know about modules. So to summarize, modules just let us split code across different files and allow us to keep our projects organized. Let me now introduce you to selecting HTML elements, because before we can even do something with any HTML element, we first have to select it. So we have to get a reference essentially to this HTML element instead of JavaScript. So imagine we wanted to modify this h1 right here that, for example, says npc codes. Then we first need to get a reference to this h1 tag right here. We also could want to get a reference to a p tag that maybe has a little bit of placeholder text, like so. So now we have those elements on our website, but we first need to get a reference to these elements instead of JavaScript. And for now, you don't need to completely understand this. It will all make a little more sense during the next lectures, but now just stick with me. So we can select HTML elements by using JavaScript in multiple different ways. We can, for example, use an ID to select a certain HTML element. So this here could, for example, have an ID of heading. And now I could use this ID heading to select this element instead of JavaScript. In order to do so, or in order to select pretty much anything, you will always use the document. Because again, the document holds a reference to our HTML document and therefore to all of the HTML elements on our page. So I'm going to use document Now we can, again, since this is an object, call a method on this object, and JavaScript provides the getElement by ID method for us. And now, right here, we can just define within the brackets the ID name essentially. In our case, it's heading, and this will allow us to select an element. Now we can store the selected element, the selected HTML element, inside of a variable. So I could, for example, say that this variable has the name heading. This here can be anything though. That's up to you, but I like to use descriptive names, so heading might fit right here. And now let me console.log heading for you. And don't worry, we will not use the console that long anymore. You will see real effects on the website soon. But for now, let's just take a look at the heading inside of the console. And you can see we're getting this h1 element that we have on our index.html page. So this here is the exact reference to this element right here. We could also get a reference to our paragraph by using an ID. So this one could have an ID of text, for example. And now I can use this ID to get a text reference. So const text is equal to document get element by ID. And now the ID is text, of course, like so. Let me console.log the text for you. And now we also have a reference to our text. Let me delete this and let me just add a comment. So by using getElement by ID, you can get a reference by using an ID. You can also get elements by using a class name. So you can get a reference by using class names. So let me for now delete the ID right here on this paragraph. Let me duplicate this paragraph 2 more times. And now we have 3 paragraphs. And let me add a class to this paragraph of text. And now let me just add this class to all of the paragraphs. So right here and right here. And now we have 3 paragraphs who all have the exact same class. And now I can, for example, say const text, for example, is equal. Again, we use the document. And again, we use a document method. So document.getElements, plural this time because we are selecting multiple elements, by class name essentially. Opening and closing brackets, and inside of those brackets, as a string again, so as an argument, we have to pass the class name, the specific class name, like so. And now let me just console.log our texts right here. And you can see we're getting an HTML collection, which is pretty much an array. And now I could, for example, access the first element by using texts of 0, texts of 1, of 2, and so on. So I think you get the idea. And now I can also loop over this texts collection essentially, which is not really an array, but pretty similar. So I cannot do something like map or for each on this texts collection, but you can use a normal for loop. So for let text of text essentially, and now we can just console.log the individual text. So this works. Let me also change the text so you see that this in fact works. This is 1, this here will be 2, and this here will be 3, like so. And you can see we're getting 1, 2, and 3. So now we selected all of those elements inside of a collection, which again is pretty similar to an array. So let me delete all of this. And now we can also get a reference to an element by using tag names. Imagine we are using the p tag right here. Let me also remove the class, like so, and like so we don't need it anymore. And now let's say we want to get every tag that has a p tag. So p right here. And we can do so by saying document.getElement by tag name. Or to be precise, get elements, like so. Because of course, we can have multiple p tags on our page, and then we of course will get them as a collection once again. So again, opening and closing brackets, and this method expects us to enter a tag name instead of quotation marks, so as a string. And in our case, we want to get a p tag, or all of the p tags. And now I store them instead of a variable. So maybe paragraphs this time, like so. And now let me just console console.log our paragraphs for you. And you can see we're having a collection once again. So once again, I could also just use a for loop. So for let p of paragraphs, and now I'm just going to console.log p like so. And you see we're getting our paragraphs once again. So all of them right here. So this is how you get a reference by using the tag name. And of course, you could also get a reference to our h1 by using document, get element, or get elements by tag names like this. And now I could specify h1 and let me console.log h1. I don't even know if this is all right, but it seems to be all right. Of course, this here is not the best name, I'm going to be honest. But for now, you see that we again have a collection and we could access our heading by using h1 of 0. So you will always get a collection even if you just have a single element when using get elements by tag name. So that is important. Now, next up, we can also get them by using a CSS selector. A CSS selector would be a hashtag heading, for example, or for a class, it would be dot heading if we have a class heading, for example. So I think you understand how this works. We are just using CSS selectors inside of JavaScript to select an element. We can do so by using document.querySelector. And now we have query selector and query selector all. And I will explain the difference to you in a second. But let's start by taking a look at query selector. And now I'm going to get hashtag heading. So I use the CSS selector within those brackets right here. And now I'm going to store this within a variable const query heading, for example, like this. And I'm going to console.log query heading. And you can see I have this h1 right here. So this is the h1 that we're getting from our query. So query. And you see this is the query selection right here. And now I can, of course, also use a class, for example. So imagine I have a class right here, like Ayo. Let me just use a random class so I see that this works as well, like this and like this. And now I'm just going to use dot Ayo, like so. And you can see I'm only getting the first element. So only element number 1. And query selector will just return the first element. And that's essentially it. If I have multiple elements that I want to select, then I have to use query selector all, like this. And this will now again return a node list, which again is similar to a normal array. And now under those circumstances, I would have to loop over this one once again. So for let h1, for example, of query heading console.log h1. And again, h1 is a bad name, but I'm going to do it like this. And now you can see we're again getting all of the individual elements. So query selector, if you only want to get the first matching element, and query selector all, if you want to get all of the elements that match this query essentially. And this here is always a CSS selector. So I could of course also use P, and it would get the exact same result because an element selector exists in CSS as well. So this is the normal element selector in CSS. This would be the class selector in CSS. And this here would be the ID selector in CSS. But I think most of you know CSS, so this shouldn't be new to you. And now let me also add right here. So we are getting a reference by using CSS selectors essentially, like this. And you see those are all of the options that we can use to select an HTML element. So to get access to a certain HTML element inside of JavaScript. And now this is really useful because now we can target a specific element on our page, on our index website. And we can, for example, change the style. We can change the text later on. We can manipulate those elements in all forms essentially. And we will also do that very soon. So to summarize, you can get a reference to an element by using a CSS selector. So by either using query selector or query selector all. You can get a reference to an element by using the tag name. So something like h1, p, UL, OL, and so on, you can get a reference by using class names. So whatever class name you define, and this will return a collection, so something that is similar to an array. And you can also get a reference by using an ID. And of course, what exactly you use is to a certain degree personal preference and also depends on the situation. I usually recommend you to use an ID if possible, and especially if you only want to get a single element, or otherwise maybe a class name if you need to get multiple elements. And that is all you need to know about selectors instead of JavaScript. Let's now get to the interesting parts. And let's now understand how we can change or add text content, for example, and inner HTML, which is also pretty much text. But I will show you how this works in a second. So we've already learned how to select specific elements instead of HTML. So now imagine we have a paragraph right here. And that one says hello for now. And at this point, we will also not need the console anymore. So let me make this here a little bit bigger so you can really see this. And let me also make this window right here a little bit smaller. And now imagine we wanted to get this p tag and maybe change the text hello to something else. So I'm going to use an ID, for example, and this ID will be text. Now I have to select this ID inside my JavaScript file, and we can do it the way we did it up to this point. So const text is equal to document.getElement by ID, and the ID was text. So I'm just going to use text right here. So now I have a reference to my text, and now I somehow need to change the text. And I can do so by using text content or inner HTML. So I can use text dot, and again, this here is an object that has properties and methods, because again, pretty much everything in JavaScript is an object. And now I can use text dot text content, which is a property, and I can set this equal, so I can override this property using JavaScript and set it to something else. So I can, for example, say hello guys, like so. I'll end this by using a semicolon, and I'm going to save this. And you can see we're now having hello guys. So this allows me to change the text content. Now I can also use text.inner HTML, so the inner HTML property, to override this text here once again. So I can say, oh wow, for whatever reason. And now we are seeing oh wow right here. Because again, JavaScript executes from top to bottom. So first we get the element, then we override the text by using hello guys, and then we override the text once again by using oh wow. So what is the difference between inner HTML and text content? The difference is that when using inner HTML, you can write normal HTML essentially right here. So I could also turn this here into an H1, and now I can, for example, say hello, and I can end this by using the closing H1 tag. I'm going to save this, and you can see this here is now an H1. If I would do the exact same, instead of text content, I would get this result right here. So let me delete this. Now I would get this result. So text content will essentially just display everything as plain text, whereas inner HTML also allows you to write HTML code. And something that is really important to understand when using inner HTML and text content is that you want to avoid inner HTML whenever possible. And you especially want to avoid inner HTML when you display user content. So imagine, for example, you have an input field of type text, and that one allows the user to, for example, write a comment on your website. You then store this comment inside of your database, and other users are able to load this comment, to see this comment, for example. Like if you think about Instagram, on Instagram, people can write comments and then other people can read those comments. If you now load those comments and use inner HTML to display those comments on your website, one of the users could, for example, write something like this, so hello, like this, and this will now get executed as HTML code if you use inner HTML. So this would have the H1 formatting, which of course would break your entire website. And this is a really simple example. You could also use JavaScript code in HTML because in the end that would work. And that is a lot worse. So using this here is really a security risk if you load user content and display it on your page using inner HTML. So whenever possible, and especially if you load user content, avoid inner HTML. If possible, and usually it is possible, always use text content. So never try to use inner HTML if you can avoid it. You can use inner HTML if you are the one that defines this content and the content is not user generated. So if you, for example, just say text.innerHTML is equal to this right here, this is kind of alright. I would still argue that it's better to use text content. But if this here is content that you get from a database later on, once you start using a database, and you essentially allow users to input something and you just display what the user entered essentially, then you don't want to use this at all, because that is really risky. So the only takeaway is use text content whenever possible, and especially if you have user-generated content like comments, usernames, and so on. Just avoid inner HTML at all and use text content instead. So to summarize, text content changes only text, while inner HTML can just insert normal HTML. Let me now introduce you to getAttribute and setAttribute. And getAttribute allows you to read an attribute, and setAttribute changes an attribute. So think about a website where we have an anchor tag, for example. That one has an href attribute, and this one, for example, redirects, let's say, to google.com, for example. So I'm going to copy this link, I'll paste it into the href attribute right here, and instead of the tags, so between opening and closing tag, I will have Google right here. So when the user clicks Google, he will get redirected to the Google page. So this is just normal HTML. And now let's try to get this anchor tag, so this link, by giving it an ID of link, for example. And now we're going to select this one instead of our JavaScript file. So const link is equal to document.getElement by ID. And we want to get the element that has the ID link. So up to this point, everything is normal. And now we can read an attribute by using the getAttribute method. So again, we can access our link, which as always is just a JavaScript object. And now we can access the getAttribute method on this object, like so. And right here, we just have to define what kind of attribute we want to get. For us, this would probably be the href attribute. Now I'm just going to console.log the result of this operation, and I don't have the console at the moment. So let me make this here a little bit bigger, inspect, let me open the console, and right here you can see that we're getting the link. So https google.com/whatever. So I think you get the idea. So this right here is just a link that we entered right here. So by using getAttribute, we are able to get access to an attribute. And now I could, of course, also store the value instead of a variable. So I could just say this here is the actual link. I don't have a better name right now, but you could get or come up with a better one like this. And I could also console.log the actual link like this. And this would actually be the same result. So when you need the link, you can always store it inside of a variable or pretty much any attribute. So I can get access to an attribute by using getAttribute, but now you maybe also want to set an attribute. And in order to do so, we can again access our link object, and now we can just use the setAttribute method right here. And that one expects two parameters. The first one is the qualified name. So essentially, what kind of attribute do we want to set? For us, it's the href attribute, and the second parameter, so the second argument we have to pass, is the actual value. And maybe we want to redirect to, let's go back and let's, for example, search for cameras. So I'm just going to redirect the user to maybe Amazon, this camera website. So let me go over to that website, I'll copy that link, and as the second value, I'll paste it in here essentially. Let me now close the console and let me press this link, and this should now redirect us to Amazon instead of Google. So you can see we're getting redirected to this camera right here on Amazon. So this seems to work. Let me also minimize this here once again, and let me also show you an alternative way. So let me just delete this here for now, like so. Let me press Google again. We're getting redirected to Google now. Let me go back, and now there's also shorthand syntax for set attribute. So for a lot of attributes, we can just use the object name again, and then you could just say href, for example. And now we can just say that link.href is equal to maybe this link right here that again redirects to Amazon. I'm going to press Google right here, and you can see it again redirects us to Amazon. So for a lot of attributes, or for most attributes to be precise, there exists this shorthand syntax. So for images, when you want to set a source, for example, you could also use image.source to access the source attribute right here. And then you could say that this is equal to whatever source you have. I don't have an image right now, but I think you understand the idea. So to summarize, you can always use get attribute to read an attribute, and you can always set an attribute by using set attribute. And most of the times, you can just use the shorthand syntax, which essentially just means you type out the object name. So essentially the object that you got from the HTML page, followed by a dot and followed by the attribute name. So maybe image.source, link.href, and so on. So I think you get the idea. And that were the most important things you need to know about get attribute and set attribute. Let's now take a look at how we can create elements, how we can append elements, and how we can remove elements. To create an element, we use create element. To append an element, we use append. And to remove an element, we use remove. Let me show you. Imagine we have a div right here. And let's give this div an ID of container, like so. Now we want to get access to this div container instead of JavaScript. So I create a new variable, const container is equal to document.getElement by ID. And we want to get a reference to our container, like this. And now we can create a new element by using create element. To be precise, we access our document and use the .createElement method of the document object. Let me show you. So for now, let's say document.createElement, like so. And imagine we want to create a new p tag, for example, like this. And now we can store this created element inside of a JavaScript variable. So const text could be equal to document.createElement p. So we are creating this p tag and storing it inside of this text variable. Now we can use text content to give this paragraph, so this text, a little bit of text. So I'm going to say text.text content is equal to hello guys, for example, like this. But now we're not able to see this on our page. Why is that? The reason for this is that we did not add this text right here to our DOM yet. So in order to change that, we have to append this text right here, so this text element, to our document. And now we can, for example, say that we want to add, so append this element to our container. In order to do so, we can say container.append, and now we define the element that we want to append to our container. And a short reminder, the container is just this div right here. And now to this container div, we want to append our text, so our paragraph. I'll save this, and now you can see we're having hello guys. Let me make this a little bit bigger. Let me go to inspect. And now let's take a look at our body. So we have this body, we have this div inside of our body, and inside of this div right here, we have our paragraph. So append essentially takes an element that we define within those brackets and puts it as a child element to the defined element. So in our case, it appends our child, so our text, to this container element, so to our div. And that is how append works. Now, let me minimize this and let me show you how we can use that together with a couple of other things that we've learned up to this point. Imagine we want to create a link, for example. And now I can, for example, say const link is equal to document dot create element like this. And a link, so a link tag is an anchor tag in HTML. So we will create an anchor tag. And now I can just set the href attribute of this link by using link dot href, for example. And this could be equal to a random link. Let me just get Google because it's probably the easiest, like this. And now we also set the href attribute right here. And now we can also add some text right here. So we can say link dot text content is equal to go to Google, for example, like this. And now we're not seeing it because we didn't append this link to our document, for example. So let's just say container dot append, and I want to append my link element to the container. And now you can see we're getting this link, go to Google. I could also add a target equals underline blank attribute. I'm not entirely sure, but I think we have to use it by using set attribute. So I'm just going to use link dot set attribute. I want to set the target attribute, and the value is going to be underline blank. I'm not even sure if there is a shortcut for target, but I don't think so. But again, you can just look it up. Now I added this attribute as well. I'm going to click on go to Google, and you can see we opened it in a new tab and it redirected us to Google. So this here essentially uses all of the stuff that we've learned up to this point. We're getting an element by using the document ID. We're then creating a new element by using .createElement on the document object. We then define an attribute by using the .href property right here. Afterwards, we set the text content by using the .textContent property. And afterwards, we use the setAttribute method to set the target equals underline blank attribute right here. And then in the end, we append this link to our container element, so to our div. So this is pretty much all we've learned up to this point. So I think this is a good repetition. Now it's also possible to remove elements from a page. So maybe I have a little bit of text inside of this container. So hello guys, for example, but let me delete all of this. And now imagine I want to remove this container from the page. In order to do so, I can just use the remove method. So this is really easy. You just specify the element, so the reference to the element, followed by a dot, and then you call the remove method on this object. And you can see this just removed the element from our document. Let's now understand how to style using JavaScript. So usually when styling, you most of the times use CSS. Imagine we have a div, and that div has an ID box, for example, like this. And now we can, for example, link a style sheet right here. And inside of our style sheet, we could, for example, target our hashtag box element like this. We could give it a width of 50 pixels, a height of 50 pixels, so 50 pixels, and maybe a background of yellow like this. Or let's use yellow-green, because this is a little less annoying, like so. But now we can do the exact same by using JavaScript. So let me just delete this right here, and let me show you how to do it using JavaScript. First of all, of course, we need to get a reference to our box. So we'll just do it the way we've done it up to this point. So const box is equal to document, get element by ID, and we want to get a reference to our box like this. And now we can style elements by accessing the element, so the reference. Now we can use the dot notation to access the style property of the box object, like so. And now we can use another dot because style, again, is an object provided by JavaScript. And now we can just use the color property, for example, or the background property, or the width property, like so. Let's access the width property and set this equal to 50 pixels. So 50 pixels. You always define those values inside of quotation marks, like so. Box.style.height could be equal to 50 pixels as well. And now let's also define a background color. So box.style.background like this. And this could be equal to yellow, for example. And you can see we now have this yellow square right here. This could also be yellow-green, like so. And I think you understand how this works. And something that is important to notice is you can see that the properties, every time you use or access the style object, have a pretty familiar look. So the naming is pretty much the exact same if you compare it to normal CSS. But there is a small difference. If you think about background color inside of CSS, for example, so hashtag box, and now let's use background color, you can see that the naming convention is to use one name and separate it from another name by using a minus. So background minus color. If you take a look at JavaScript though, we use camel case once again. So the first letter is lowercase, so the first letter of the first word, and every new word will start with a capital letter. So background color would be written like this. And this is pretty much all of the time like that. So this here is how it works. Now you can actually take a look at a lot of different properties. So I can also use box.style dot, and by using dot on the style object, you will get a lot of different properties and you will learn them pretty fast, especially if you know CSS. That's no problem at all. So to summarize, you can always add inline CSS essentially by using the selector, so the variable name that you use to select an element, followed by a dot. Then you access the style object of our selected element, and this style object then provides a lot of different properties to apply CSS styling essentially. So I can, for example, access the dot width property to define the width, the dot height property to define the height, and so on. So that is how this works. But now you could also replace an entire class by using the class name property. Let me show you. Let me delete those styles right now. Let me open CSS again, and let me again define something for our box. So width 50 pixels, height 50 pixels, background yellow, green, for example, like so. So now we use CSS to define these styles right here. But now I can essentially replace this by using JavaScript. So by using the class name property. In order to do so, I will again access our box. I will use the dot notation, and now I can use the class name property right here. And I can set this equal to maybe whatever, or from minus JavaScript, like so. So now we added the class from minus JavaScript, and actually at the moment we still have an ID right here. So let me use a class of box for now, like so. And now let me comment this out right here so you really understand how this works. So now we have the class box on our HTML element, and I'm going to target the class box by saying dot box, and you can see now CSS applies those styles to our box. Now I'm going to go back to JavaScript, and once I comment this line out and we essentially apply box.className to from JavaScript, and actually this didn't change anything because of course we need to get the element, or we're getting the element by using an ID at the moment. So actually I'll just add the ID box as well, but I will only use that ID for selecting the element and not for styling. So now we're essentially adding the CSS style inside of our CSS file, so .box, but you can see that this CSS style has been removed once we added box.className. So .className will essentially remove all of the existing class names. So .box, so this class right here, will be removed, and instead it adds whatever we define right here. So in our case, from minus JavaScript. And now I can add this style to our, or this class to our style sheet, like this. And I could, for example, add the exact same styles, but let me turn this into a blue box. And once I save this, you can see that we now have a blue box, because right here inside of our JavaScript file, we are essentially removing .box, so the .box class from that element, and we're adding from JavaScript to that element, so that class right here. And of course, we can just style this class that we now added to this element by using CSS. So that is completely valid. And now let me show you another important way to essentially add classes, remove classes, or toggle classes. And that is probably one of the most common ways. So imagine we have the box class right here and the ID box. Now, let me go back to our CSS file. Let me delete this for now. And let me go back to our JavaScript file and let me save this and remove this right here as well. So now we have a box once again. Now I'm going to access the class list property. And now I can again access the add method like so. And now I can just define any class I want to add right here. So this could be Wayo, for example. Let me now, instead of our style sheet, add a style for the Wayo class. And let me maybe override the width to 100 pixels, for example. And you can see it now takes the width of this class because, of course, in CSS, things that come later essentially override things that come earlier if the selector specificity is the exact same. And at this point, we have a class targeting our element and a class targeting our element. So the selector specificity is the exact same, and then the element that comes later inside of the document will override the previous value. But the thing that is important is that our element now has the class box, and it also has the class Wayo. So both of those classes now exist on this element, so on this div right here. We can also remove a class. So I could, for example, say box.classList.remove. And now I could remove the Wayo class like this. And now the style is gone. But I could also remove the box class. And now the entire style is gone. So I think you get how this works. And now I can also use toggle, for example. So let me use box.classList.toggle like so. And let me toggle the box class. And you can see now the box class is back again. And the reason for this is that toggle will add the box class if it does not exist yet, and it will remove the box class if it exists. So if I'm going to remove this line, so if we never remove the box class, it essentially exists. And if the box class exists, toggle will remove it. So now we should remove it. And therefore, this element is now gone. So essentially, toggle just toggles the state. If it exists, it will not exist afterwards anymore. If it doesn't exist, it will exist afterwards. And this is pretty cool if you combine it with buttons later on, for example, because you can toggle essentially the state when clicking a button, for example. So to summarize those ones, you can always access the .classList property, and then you can access the add method to add a certain class, the remove method to remove a certain class, and the toggle method to toggle between states, so between a class. So turn a class on if it's off, or off if it's on. And to summarize all of this, you can always use the style property to add inline styles. You can use the class name property to replace all of the existing classes and add a new one. And you can use the class list property to add, remove, or toggle classes. And that is all you need to know about styling in CSS. Let me now introduce you to one of the most important things in JavaScript, and that are events. An event lets us react to user actions. So what is a user action? A user action is, for example, when the user clicks on a button or clicks on a page or enters something inside of an input field, and so on. So all of those things where the user does something is what you call an event. And you can add events to all kinds of elements, essentially. You can add events to the entire document, to a certain button, to a certain input field, and so on. Let's start by creating a button that has the text click, for example. And let's also add an ID of btn, for example. So now we have this click button right here. And now, instead of JavaScript, we can add an event listener to this button, so we can react to the click event, for example. Let me show you. First of all, we need to get a reference to this button. So let's say const btn, so that is our variable name. is equal to document. And now we get this element by ID, and the element has the ID button like this. So now we have our reference. And now by using this reference, we can add an event listener to this button. Let me show it to you, and then I will explain it to you. So we use btn.addEventListener. So we will use the addEventListener method right here. And now, as the first argument, we have to pass the type of an event. And the type is usually within those quotation marks. So we have a lot of different events: blur, cancel, change, click, and so on. And if you want to remember at least one event, it's definitely the click event. And you will use this event probably 90% of the time. So this is the most important event overall. And now, as a second argument, we can pass a callback function, like so. And when I first started using JavaScript, I never knew why or how I should know what kind of event I should use right here. So this here was really confusing. But in the end, there exist a couple of events that the JavaScript team essentially provided. And the click event is one of them. And you just have to define the name of the event instead of those quotation marks. And you just have to memorize them. So whenever you want to react to a click event, the event name, so the argument that you pass right here, is click. If you want to react to a user input, for example, the event name is input, for example, as far as I know. So yeah, input. And there exist a lot of other events, so maybe mouse down, mouse enter, mouse leave, and so on. So in case you want to use those events, you can always look them up, of course, or you can also remember the ones that you use pretty often. And the click event, again, is probably the most important one. So that one is something that you should probably remember, but you will remember it anyways after using it a couple of times. And this here just says that we're going to react to a click event, and we will do whatever we define right here within this callback function whenever we click this button, essentially. Because to this button, we added the event listener. So what we're saying right here essentially is that to our button element that we selected previously, we want to add an event listener, and this event listener now listens to all of the click events. And every time we click on this button, essentially, we execute whatever we define right here as a callback function. And by default, we can also get the event object right here. So JavaScript will also provide this event right here. And now we can just console.log clicked every time we clicked on this button, for example. So let me just make this a little bit bigger. I'm going to inspect. I'm going to go to the console and I will click. And you can see we're getting clicked in the console. And every time I click, we're adding one clicked right here in the console. And of course, the logic could also be a little more complex. You could add text every time you click on this button. So I could, for example, add a new element to the DOM and so on. So that is up to you. But the important thing is that you can now react to button clicks. So if users click this button, you will just see clicked in the console, or you can do whatever you like. Let's also take a look at the event object, like so. Once I click, we should see this event object in the console, and you can see this is what we're seeing. So we're getting this super big object that has a lot of information. So maybe layer X, layer Y, offset X, offset Y, page X, and so on. So a lot of information, also information about the position on the screen, so on the X position, Y position, and so on. And also the type right here, which is the type click, for example, and the target right here. And especially the target might be important from time to time. You probably want to use it from time to time. It's not that important, but I will show you how it looks like in case you ever want to use it. So I'm going to click it, and you can see this here essentially gives us the target. So this essentially outputs whatever we clicked. And under those circumstances, we of course click the button. And this makes sense if you, for example, want to check if event.target, so if the clicked button, for example, is equal to an element, for example. And that is something that you will probably understand a little bit better once you start to use React, or a JavaScript framework. For now, it might happen that you use it from time to time, but probably not that often. Nevertheless, this here can be helpful. So in general, the event object just gives us a lot of information about the event that happened. And from time to time, you probably want to use it. If you don't want to use the event at all, you can also just get rid of it, and you can just do whatever you like right here. So I could just console.log clicked, for example. And now, instead of just console.logging clicked, I could also target my button, so btn. I could change the style, maybe of the background, like so, and maybe the style is equal to yellow, for example. Now I'm going to click the button, and you can see we now have a background color of yellow. Again, this here looks terrible, but I think you understand the idea. By using an event listener, you can react to events and do or manipulate your page in any way you like. And right here, we are listening to the click event. But there exist a lot of different events, and I will show you some of the most important ones. Always remember, click is probably the most important one, but there exist a couple of others that are probably kind of nice to see. Let's imagine we have an input field of type text, for example, and that one will probably have an ID of username. So maybe we want to get a username. Now I want to get a reference to that username inside of JavaScript. So I'm going to say const username is equal to document get element by ID, and I want to get a reference to my username. So to the element that has an ID of username. Now, again, I can add an event listener to my username. So I'm going to say username dot add event listener. And let me also get rid of the console like so. And now I want to add that event listener. This time, let's, for example, listen to the input element like this. Again, second argument is always a callback function like this. And now let me also get our event. I can also use E for event. And I'm just going to console.log E, for example. I'm going to inspect this once again. So let me just make this a little bit bigger again. Let's take a look at the console. And I'm going to enter something. And every time we enter a value, so a new character, we're getting this event object right here. And now we can also see the value that we entered right here by just accessing our username right here. So username. And now this element has a dot value property that we can use to read the actual value. So, hey, like so. And you can see we're console.logging the value right here. So now this would be kind of useful to track the actual value that a user entered right here. And for example, if the user should enter at least 3 characters, we can, for example, check if the length of our value is at least 3 characters. So we can check if username.input.length, for example, is greater than 3 characters. So at least 4 characters under those circumstances. Then we're going to console.log, okay, like this. And otherwise, we are going to console.log to short, for example, like this. And actually, this here needs to be value, of course. So that was my bad. And now let me just enter something again. And you can see we're getting too short, too short, too short. And now that it's long enough, we're getting okay. And of course, this here could also be a little bit better. So I could just use a paragraph right here, for example. And let me give that one an ID of success, for example. And right here, I keep it empty. And now I can, for example, try to get a reference to this paragraph. So I can say const success message is equal to document get element by ID. I'm going to get a reference to my success message. Now I could, for example, say that success message dot inner or text content, so that was my bad, is equal to maybe username needs 4 characters like this. And otherwise, so if we have enough characters, I can just say success message dot text content. And now I'm going to say very good, bro, like this. See, in real time, we can have a success message right here. But again, I need to switch this here. So this here needs to be right here. And this here needs to be right here. So my bad, but now it should work. So I'm going to say age, and we are getting, hey, username needs to be 4 characters. And I'm going to say hello. And once I have 4 characters, we're getting very good, bro. So this would be a possibility to give the user essentially a live updated success or error message. So to give him live feedback on whether his username meets certain criteria or not. So if his username, for example, meets certain standards or not. And you can see this here already feels really interactive. And that is really cool about JavaScript. So now we took a look at the click event and the input event. Let me show you a couple more. There also exists the submit event. So let me create a form, for example, of type post. Instead of this form, let's have an input field of type text. And let's also have a button of type submit, for example, like this. And now I need to get a reference instead of JavaScript to this form. So I'll add an ID of form, for example. I'm going to go over to my index.js. I will just delete everything. I will create a reference, so const form is equal to document, get element by ID, and I want to get a reference to my form like this. And now let me add an event listener to this form as well. So form.add event listener. And this time, let's react to a submit event. So this event will be automatically triggered once the user essentially submits our form. So this form right here. And now, again, I have access to my event object, so event, and we have to pass the callback function right here. So this callback function will again be triggered once the user submits this form. And right here, we can just console.log our event, for example, like this. And now the button needs some text, of course. So submit, for example. Let me go back and I'm going to submit. And you can see we're getting this error right here. And you can see this here is the default behavior of a form. But oftentimes you want to prevent this default behavior of a form. And in order to do so, we can use our event. So something that you do pretty often in JavaScript is adding event.preventDefault. So the prevent default method, because this will prevent the default behavior of a form where it essentially submits the form immediately. Let me paste that in here and let me now submit the form. And you can see the default behavior now is turned off. So by default, usually when submitting a form, it will automatically use whatever we have right here as an action attribute and will essentially try to submit this form to that location. And it will also reload the page. But to prevent this behavior, we can just use event.preventDefault. So this will just prevent the default behavior, so essentially submitting the form automatically when we press the submit button, and also reloading page automatically when submitting the form. And oftentimes you want to define the behavior for your forms yourself. So we'll always start by using event.preventDefault. Right here, you could now, for example, define your own logic. So you could, for example, say when the user submits this form that you, for example, want to add a text somewhere. So maybe you have a paragraph right here. That one has an ID of username. And now we can, for example, get a reference to this username. So const username is equal to document, get element by ID, username, like this. And maybe we just want to display the username inside of this username paragraph right here. So now we could just use username dot text content, and let's say this one is equal to whatever we entered inside of this input field. So again, let's give this one an ID of input, and now let's get a reference to our input field as well. So const input is equal to document get element by ID input, like this. And now we could, for example, just say that this is equal to input dot value, like so, and like so, yeah. And now let me test this for you. So we are just going to minimize this. I'm going to enter a username, so maybe npc codes. I will press submit. And right here, instead of the paragraph, we are now having NPC codes. And I could also reset input.value to an empty string afterwards, like so. So this would be valid as well. I'm going to say NPC codes. I submit it, and you can see it also clears our old input.value, so our old value. And right here, we used a lot of the stuff that we learned up to this point. So I can always, or you pretty much always start by getting access to a certain HTML element, and then you use the same concepts over and over again to essentially manipulate your values in the way you like. And this here really becomes repetitive once you did it for a couple of weeks or months, I would say. So you will definitely get used to this, even though it might seem confusing to you at first. And we will also go over this over and over throughout the rest of this course. So I'm certain that you will understand all of this by the end of this course. Let me now introduce you to the next event. And that one might happen from time to time. So maybe you want to react to a key press, for example. And in order to do so, we can, for example, also add an event listener to the entire document. So document.add event listener. And now we can, for example, react to the key down event. You could also react to key up. And as far as I know, key down essentially reacts once the key is pressed, whereas key up only reacts once you release the key on your keyboard. So the difference is not really that big, but in case you're interested, that is the difference. And now, as a second argument, as always, we just add our callback function right here. And for now, we can just console.log our event, for example, that we also have to accept, of course, like this. And let me inspect this in the console. So console right here. And once I'm going to press a key, essentially, so this one, you can see that we're getting this keyboard event essentially. And that includes a lot of stuff that we could, for example, get. And you can see that we're also getting the key property on this object. So I could, for example, use event.key, so .key to detect the key that I've pressed essentially. And now I'm going to press E, for example. You can see we're getting E in the console, maybe W, X, Y, and so on. So I think you understand how this works. So by using key down, we can essentially react to a key press. And now I want to show you one more event listener that is probably important from time to time, or that you might be interested from time to time. So let's again add an event listener to our entire document. And this time you can already see DOM content loaded. I'm going to add my callback function once again right here. And for now, I'm just going to console.log content has been loaded, for example, like this. I'm going to save this. And you can see it took a short time. And then I'm getting the message, content has been loaded, like this. So every time I'm going to save my document, it will take a short time. And once the entire DOM has been loaded, so once everything has been loaded right here, we're getting this content has been loaded message right here. So this will essentially notify us once the entire document, so once this entire page right here has been loaded. And this will allow us to do all kinds of things once content has been loaded, for example. So once the entire page is ready. So right here, we can add stuff, for example, that should only be executed once the entire page has been loaded. So this is also kind of useful from time to time. But again, the most important event is definitely the click event. And probably from time to time, you will also use the input event. There, of course, exist a lot more events, and you can look all of them up if you need to. And in case you ever want to react to a certain user action, I'm pretty certain that there exists an event for that. And if you don't know the event, you can also just ask ChatGPT, and I'm sure that he will tell you pretty much every event that you could possibly need. And that is pretty much all you really need to know about events. So, to summarize, events just let us react to user actions. And especially the click event is important, which allows us to react to user clicks. Let me now introduce you to the local storage in JavaScript. The local storage allows you to store data in the browser. And you have a couple of methods as well that allow you to save data by using setItem, to get data by using getItem, and to remove data by using removeItem. So first of all, what exactly is the local storage? Of course, you can just get a server and therefore store data on a server. So essentially on another computer somewhere else in the world. Can of course be close to you, but can also be in a different country, on a different continent, and so on. So I can of course store data on an external server. But oftentimes you want to store data in the user's browser. So imagine, for example, you have a shopping website. So something like Amazon, maybe a shoe website, a clothing brand, and so on. And the user essentially adds something to his cart. And then he maybe adds a couple of shoes, maybe a couple of trousers, and so on. And maybe he leaves the website and decides to come back later on. If you think about most modern websites, your cart will still be there. So you will still have your shoes and your trousers inside of your cart, even though you essentially left the website and came back later. And that is the local storage, because you use the local storage essentially over there to save the cart, so the user's cart, in his own browser. And later on, when he decides to come back, you load that data from the local storage, so from the user's local storage, and therefore you still know what he had inside of his cart, for example. Another example is the color preference, for example. So when the user decides to select dark mode, for example, you can save that inside of the user's local storage, and every time he visits that website again, you can just take a look at the local storage, and if you save dark mode to the local storage, you can then just select dark mode once again. So if I'm the user, for example, and I would select dark mode right here, I could save that within my own browser right here, or we will code it in a way that we will save it inside of my browser. And later on, when I decide to reload the page, I decide to quit the page and come back, we will just take a look at our local storage once I come back, and then we can load the data from the local storage and adjust our page in a way that fits whatever we have saved in the local storage. But I think it's easier if I just show it to you. So first of all, we can store items inside of the local storage by using setItem. So we can use local storage dot setItem like so. And this is a method, and that one expects two arguments. The first one is the key, and the second one is the value. So we could have a key of language, for example. The language could be EN for English, for example. And this would allow us, for example, to store a website's language in the user's browser. So maybe we have a couple of different languages, and the first time the user selects a language like English, German, and so on, you can just save that to the local storage, like so. And now I essentially saved that and therefore stored this key value pair in the local storage, in the user's local storage. So we can now take a look at the local storage by going over to the application tab right here. And now you see a lot of different storages right here. Here you have session storage, extension storage, cookies, and also the local storage. And we need the local storage. So let's go to the local storage. We can expand it right here. This here is our current URL, so our current domain. And if I'm now going to expand this, you can see that we have a key, language, and a value, EN. I could of course also store something like dark mode, and this could be true, for example, like this. And now we have the key dark mode, and the value is true. So I can store as many things as you like inside of the local storage. And later on, you can, for example, read the value. And you could, for example, then use an if condition to, for example, do something if the language is English, to do something else if the English is German, and so on. So I think you get the idea. So let me now show you how to get the item. In order to get an item, so an item to get a key value pair, we use local storage dot get item, so the get item method. And right here, we have to define the key. So the key is, for example, language. And this will now give me back the corresponding value. So for us, it should give us value. So I'm going to store this inside of a language variable like so. And let me now console.log the language right here. Let's go back to the console. And you can see we're getting EN because our language in the local storage is currently set to EN. Of course, from time to time, we also want to remove a certain key value pair. And in order to do so, we can use the remove item method. Again, we access local storage like so, and then we just access the remove item method. Right here, we have to define the key once again. And maybe I want to get rid of dark minus mode. I'm going to save this. And you can see we removed dark mode right here. So to summarize, you can store data in the local storage. You can then get the corresponding key value pairs by using getItem. Depending on the result, you can of course use something like an if condition, or you can pretty much do anything you like. So you could check if language is equal to en, and depending on the result, you could, for example, choose a different website structure or adjust your website any way you like. And in the end, if you want to remove an item, you can also remove an item by using the remove item method. And that is the local storage. But let me now also show you something else. You can also store objects inside of the local storage. So maybe a user object. That's probably not that common, or maybe a card object. And a card object, as already mentioned, might be kind of common. So let's imagine that we have a card right here. Let me also get rid of those lines. We don't need them for now. And we have a shopping cart. And this is an object. And maybe we have Nike shoes, and we have 10 of them, and maybe Adidas like this, and we have 20 of them. So maybe we are pretty rich. And we also have shoes or trousers, 20 for example. So that is our current card. And usually, of course, you would have the exact model and so on, but I don't really know much about shoes, so I keep it like that. And now you can just store that inside of the local storage as well. So we can again use local storage dot set item like so. And now as a key, we could, for example, use card, but as a value, we now have to save JSON data because you cannot store normal JavaScript objects inside of the local storage. And you can also not store arrays inside of the local storage. So we first have to transform this to JSON data. And we've already learned how to do this. We can just use JSON.stringify. And now let's stringify our card object like so. I'm going to save this. And you can see we now have the card and the value is our stringified, so our JSON data right here. Now let me try to get this data once again. So I'm going to say local storage dot get item, and let me get our card like so. And let me store this inside of a new variable. So const local storage card, for example. And for now, let me just console.log the local storage card. And let me also remove this line right here. This is not necessary anymore. And let's go back to the console. And you can see this is our card. But now this is still JSON data. So in order to get back the original object, I'm just going to use JSON.parse. And I'm just going to parse my local storage card. And now we have an object again. So now I could just use this object once the user comes back to my page. And I could just enter or put those items back into the cart. So now the user will feel as if he has never left your page, because the page looks exactly the same as when he left. And by using the local storage, you essentially have a little server on the user's PC, and that can be kind of beneficial from time to time. Of course, you don't use the local storage to store user data, for example, like his register information inside of the browser, but it's good for things like the card, the language, and so on. Sensitive information like a password, of course, doesn't belong into the local storage. Also because a hacker could, for example, get access to the user's local storage. The local storage is not really that secure, and then he would have essentially all of the information. Therefore, local storage is good for things that don't have to be that secure, like maybe card information, language, and stuff that is pretty small in general, so just a little bit of text. But it would be really bad for either big data, so images, or really sensitive information like credit card number, user information, and so on. And that is all you need to know about the local storage in JavaScript. And we've previously already seen that the session storage, if you go over to application, is pretty close to the local storage. So right here, we have the local storage. And right here, we have the session storage. And we can also open the session storage for our page. And at the moment, we have one key, whatever this is, I don't even know about it. And we can later on add a couple more. So first of all, what is the session storage? The session storage only stores data for the current browser tab. So for one session. Once you close this tab, essentially, so once you leave this site, everything will be deleted. And that is the difference to the local storage. The local storage will save your data even after closing this tab right here, for example. And once you come back, the local storage will still be the same. The session storage, on the other hand, will be deleted immediately once you, for example, quit your session. So, for example, close the browser tab. And once you come back, the session storage is essentially gone. So the local storage is a lot more common. You can use the session storage from time to time, but yeah, as already mentioned, it's more rare. So it doesn't happen that often. Something where you could probably use the session storage is if you have a register page and you, for example, want to store the register data, so the data that the user has already entered instead of the session storage. And if you, for example, goes to another tab on your website, so stays in the exact same browser, but maybe goes back to your home page and then back to the register page, under those circumstances, you could, for example, use a session storage. Because during that session, it will essentially store all of the data. But again, it's not that common. But let me show you how the session storage works anyways. It's actually pretty similar to the normal storage, so to the normal local storage. We can access it by using session storage instead of local storage. And again, we can use set item to set an item. Again, we need to define a key and a value. So this here could be user email for the key. And let's have an email of npc@gmail.com, for example. I'm going to save this. And you can see it added the key user email and the value npc@gmail.com to our session storage. If I later on want to get that item, I can use session storage dot get item like so. And again, I need to define a key. So I'm going to use my key right here. Of course, I can store this inside of a variable. So const user email is equal to that. And I can console.log the user email like so. Let's take a look at our console again. You can see we're getting the email right here. And now let's go back to our application tab and to the session storage. And right here, I can of course also remove an item. So I can just use session storage.remove item. Again, I need to define the key. So user email. And now I can also just remove our user email right here. So I can use pretty much the exact same syntax. The only difference to the local storage is that you use session storage right here instead of local storage. We can also store objects. So I could also have a user object, for example. So const user, maybe he entered his username. That one is npc. Maybe he entered an email at gmail.com. And maybe, I don't know, you probably wouldn't want to save a password, but let's save the password as well. Hello123 like this. And now we can just store this inside of the session storage. And let me delete this because this would be bad practice. So I'm not going to do this, but you get the idea. So you can just store this now inside of the session storage the same way we did previously. The only difference is, again, we use session storage dot set item. For the key, we can use user data. And again, we need to turn this to JSON data. So JSON.stringify, and we're going to stringify our user object like this. Now we have the user data stored inside of our session storage. And now I can again get our user data. So const user data is equal to session storage dot get item. And let's get the item that has the key user data like this. Let's take a look at the console like so. I first of all have to log it, of course. So console.log user data. And now this is our user data. And as done previously, we need to convert this to a normal JavaScript object by using json.parse. And let's parse our user data like this. And now we have a normal object again. So we first use stringify, to store it inside of the session storage, and then we use JSON.parse to parse the data when getting it back from the session storage. So I can pretty much store the exact same stuff inside of the session storage, but the difference is that the session storage will be gone once I essentially quit the session, so once I close my browser window, essentially. Whereas the local storage will persist even after closing the browser window. And again, most of the times, the local storage might be the better fit, but there exist situations where you probably want to use the session storage. And that always depends on the situation. So understanding that the local storage persists, whereas the session storage will be gone after every single session, so once you quit your browser, is definitely important. And that is all you need to know about the session storage in JavaScript. Let's now take a look at cookies. And I already want to tell you in advance that you can just take a look at this lecture. It's not that important that you really remember all of this. It's kind of nice if you understand what cookies are. But the rest is not that important for a JavaScript course because you more often use cookies when working with a backend. So when working with something like PHP, for example. Because a cookie again allows you to store something in the browser as plain text essentially. So it's somewhat similar to the local storage. But the point about cookies is that you can send them to a server when you send a request to a server. And that is really the purpose of cookies. So cookies are not really there to store information in the user's browser. You could do that technically, but you would usually just use the local storage. So you would much rather use the cookie to store information that is related to your server, for example, and so on. So usually, again, you will send the cookie to a server together with your request, and then the server will use this cookie. But understanding the cookie instead of this JavaScript course can be kinda good already. So let's go to the application tab. And right here, we have the cookies tab again, and we can open that and go to the cookies tab for our website. So you can create a new cookie by using document.cookie. So document.cookie is equal, and now you can create a new value, so a new key value pair for your cookie by using something like this. So username equals NPC, for example, like this. And I'm going to save this. And you can see we now have all of those values. Let me make this a little bit bigger and this here as well. And you can see we have a name, so that is the key. So username for us. We have a value, that is the actual value. And right here, we also have domain. We have a path. This here says that this cookie is available or is valid on our entire website, essentially. We also have an expiration date. At the moment, this is set to session expiration as far as I know, and so on. So you have a lot of stuff right there. You can also set an expiration date by using expires and using a path, but for this course, this is not really that important. All you really have to know is that you can also use a cookie to essentially store key value pairs inside of your browser, and this cookie will be sent together with your requests to a server later on. And that is the real power of cookies. So right here, you don't really have to understand much more. Usually, you will not really touch cookies using JavaScript. If you would now want to get the value of your cookies, you can just access them by using document.cookie. I'm going to console.log them, or I'm going to take a look at my console right here, and you can see we're getting our cookie. I can also set multiple cookies. So maybe let me store my password, which would be terrible, but let me just say password is 123 or MPC123. And now you can see every single string that we save within our cookie will get separated by using a semicolon by default. I could add another one, so maybe biceps, and I have a bicep size of 12 centimeters, and so on. So I think you get the idea. This is what the cookie in the end looks like. So it's just plain text. Let's take a look at our application tab, and you see this is what the key value pairs look like. And if we are going to access the cookie later on, it will look like this. So the individual key value pairs will be separated by using a semicolon. Again, this here is not really that important inside of a JavaScript course. Understanding the basics is important, but we will get to that inside of my PHP course. So for now, just remember that a cookie will be stored inside of the browser. And usually when you work with a server, the cookie will also be sent together with your request to that server. And oftentimes it's, for example, to validate that the current user, for example, has the necessary rights to get the data, for example. But again, that's for my PHP course. Let's now take a look at the window, document, navigator, and location object in JavaScript. And JavaScript provides all of those objects to us. We have already seen the document object. So let me again console.log the document object for you. And you can see this is what it looks like. We've already seen this before, but the document object is just a representation of our entire document. And we can use the document object to, for example, get elements by their ID, for example. So document, get element by ID, and so on. So this is how this works. So to summarize, so the document object is just an object provided by the JavaScript team that allows us to access pretty much every single element and get information about our document in general. So for example, .title, for example. So I think you got this at this point. But there also exists the window object. So let me console.log the window object. And the window represents the browser window. If you take a look at the window object inside of the browser or inside of the console, you can see that it has a lot of properties. And a lot of them will never be touched by you, but something that you might want to use from time to time is, for example, inner width or inner height. If you want to do something depending on the height or the width of your browser window. So this window essentially represents your browser window. And now you could, for example, access inner width like this. And let me just log this in the console and change the value. Let me reload this. And actually I need to change this right here. And I'm going to reload this. And you can see we now have a different width because we changed the width of our browser window right here. So that is how this works, like so. So the window object just gives us a lot of information about our window. Let's go back, like so. Let me make this here a little bit bigger. And now you can also access inner height like this. And I think you understand how this works. Now we also have the navigator. And the navigator gives us information about the browser in general, like so. So this is the navigator object. And you can see we have a lot of stuff right here. We have something like device memory, GPU, geolocation, and so on. And now I can, for example, access navigator.language, for example. And you can see my device browser language is English. So the navigator just allows us to access a lot of information about the browser, to be precise. And now, last, we have the location. And the location, as the name implies, gives us information about the current URL, so the current location we are on our website. This here is the location object. And you can see we have a lot of stuff like href, origin, and so on. So we can, of course, also change the href by using location.href. And we can maybe redirect to a different page. So maybe Google. I'm going to copy that href right here. I'll paste it in here. And once I save this, we should get redirected to Google. I'm going to save this. And you can see it redirects us to Google. So I can use this here for navigation, for example. And in general, the location object gives us information about the current location on our website we are on, essentially. So about our current URL. And those were the most important things about window, document, navigator, and location. So to summarize, the window represents the browser window, the document represents the loaded HTML page, so the document essentially, the navigator gives information about your browser, and the location gives information about the current URL, so your current location. And those are the most important things you need to know about those objects in JavaScript. Let's now take a look at alert, prompt, and confirm. And alert shows a message, prompt also shows a message, but also asks the user for text input, and confirm asks the user for yes or no. So let me minimize the console for this. Let me make this here a little bit smaller. And let's start by taking a look at alert. For example, maybe we want to tell the user that he is dumb, for example. So you're dumb, like this. Now he has an alert and he can press OK and he cannot do anything else. So that is kind of nice. You can also give him more information about anything else, but that is up to you, of course. We can also use a prompt, are you 18, for example. Now we're asking whether he's 18 or not. Maybe he can say yes or no, whatsoever, like this. Or he can also ask or choose a username. What is your username, like this. And now we can also store the result. So whatever the user enters right here instead of a variable. So const username is equal to this prompt. I'm going to save this. Let's say npc. And let me just console.log our username. So we really see that this works. Let me make this here a little bit bigger. I'm going to press cancel, inspect. Let's go over to the console. And let me just reload the page, npc. And you can see we're getting npc in the console. So we stored the result of what the user entered inside of our variable username. And then we were logging the username variable inside of the console. So that is how this works. And now let's also take a look at confirm. Let me make this here a little bit smaller. And now we can just ask or confirm, are you 18, like this. And now we can press OK or cancel. And we can, for example, store the result instead of a variable. So is already 18, for example. And let me again console.log is already 18 right here. I'm going to press OK. Let me also take a look at the console. And in the console, we can see that this is true. Let me save this again. Are you 18? I'm going to cancel. And we're getting false. So this right here, so confirm, will return either true or false. And afterwards, we could, for example, do something depending on his reply. So to summarize, alert just shows a normal alert, so a normal message. Prompt allows the user to enter something, and then you can store whatever he entered inside of a variable. And confirm asks the user for either yes or no. And again, you could also store that result in a variable. And that is all you need to know about alert, prompt, and confirm.